Hello. Is this working? Working? Can somebody confirm? For some reason, my computer is starting to acting up. Hello and welcome. Let me just see if things are working for me. Danny or somebody, can you please confirm that this is working?
Hey there, yes, it is working, but you have some connection problem. That's what I experience.
Mm-hmm. So, all right. So if you can hear me, let me quickly do the introduction. I'm very happy that we're having a whole day dedicated to TDD. We're lucky to have some amazing speakers from all over the world presenting today. In a way, I feel this event is the passing of the baton from my generation to the younger generations who will continue building our world. Before we start, I would like to acknowledge the generous help of the young TDDers who didn't spare effort in organizing this event. First and foremost, Daniel Mocha, Job Mitt, Dave Aronson, Mario Cervera, Maxi Contieri, Rodrigo Martinez Diaz. Some of them will also be giving their talks today. Thank you very much, guys. This event wouldn't be possible without you burning the midnight oil. We discovered TDD about 25 years ago, thanks to Kent Beck. But then we continued refining that discovery by following James Granning's Zombies formula, Ron Jeffries' Never Let the Code Not Be Working algorithm, G. Paul Hill's microtests and rework avoidance theory and the finality premise, and many other brilliant improvements. And when you stop and think, aren't we very fortunate today to have G. Paul and James open the conference with their keynotes? Right now, I feel endless gratitude to these two luminaries because I've certainly learned a lot from them. So why TDD? Why was I compelled to organize this event? I make my living by leading software engineering teams in adopting the best principles, processes, and practices when creating software. It's a nice job and I love it dearly. It brings me a lot of gratification to see so many teams eagerly embrace clean code, clean design, agility, DevOps, DevSecOps, etc. But the bane of my existence continues to be TDD. Because it's super easy for me to introduce and sell agility, clean code, clean architecture, etc. Everyone wants to be more agile, more clean, more secure, with better, sturdier architecture. But when it comes to selling TDD, many teams, in my experience, go, TDD, interesting. We will consider it definitely. But you see, right now, there's no time for it. Also, I was teaching software courses on software development, and I was always declined by the universities and colleges when I insisted on adding TDD to my curriculum. So in my view, TDD is actually old news that didn't travel well. I would like us to fix that. I'm hoping this conference today will make TDD more prominent. I would like to legitimize TDD to see it added to all software engineering courses. Also, I would like to see it being a prerequisite for many software engineering job postings. A little bit about me. I am a scientist by education and by training. I spent the first 5 years of my professional career doing scientific research, and then I switched to doing software engineering. Our profession is based on science, and science is based on the empirical approach. If a phenomenon under study is not observable and is not repeatable, it's not worth wasting time studying. Science studies nature and learns from nature. And nature works incessantly. It's a continuous flow. Nature has no master plan. Everything happens as a response to what happened earlier. The feedback loops are very tight, and any apparent progress or regress is piecemeal. Or as Ray Kurzweil wrote, evolution applies positive feedback. The more capable methods resulting from one stage of evolutionary progress are used to create the next stage. And everywhere we look in nature, we see stepwise refinement in one shape, form, or another. To me, the nature is perfect. But don't listen to me. Let's have a quick Zen segment in this talk where I will repeat one incident with the famous Zen master. So the student approached Zen master and asked him, "Master, what is the secret of enlightenment?" And the master replied, "In summer, we sweat. In winter, we shiver." So that's perfection. But the moment we introduce a plan into this situation, we create 4 problems. As Prussian Field Marshal Helmut von Moltke famously said, "No plan survives first contact with the enemy." So what are those 4 problems? The first one is uncertainty. Basically, we're not sure if the plan is actually doable or not. The second problem introduced by the plan is ambiguity. We're not sure if others have actually understood the plan. The third problem is incompleteness. We're not sure if we have all the information needed to implement the plan, and we often don't. The fourth and final one is confusion. We're not sure if we are even going in the right direction. So that's a fact of life. These 4 problems tend to make us feel uneasy. And we look for ways or for methods to deal with that uneasiness. TDD is one such method. It forces us to maximize our focus on expectations. To minimize ambiguity and the risk of incompleteness, those expectations need to be very small and very crisply defined. Once we slice expectations to the tiniest possible size, that gives us a bit of a feeling of relief. Those small expectations suddenly look quite doable, and it's easier to see that we're going in the right direction. So, a little bit about my personal experience with TDD. My first paying programming job was in the role of a junior programmer, and I started with a 3-month probationary period. Many of you have probably gone through a similar experience. Second week on my job, my boss calls me into her office and tells me that she is very impressed with my productivity levels. She told me that she was observing me spending hours just writing code, never stopping to try to compile, build, and run and test. She thought that was super impressive, especially compared to my older colleagues who were proceeding much slower. My older colleagues would make a change, then try to compile and run, then spend some time entering test data. They were being careful. My boss wasn't impressed with that. She thought that real pros know what they're doing and they're therefore doing it straight. Of course, she obviously never tried developing software. And later on, I learned the hard way how wrong that sentiment that states real pros just write code straight away is. I soon learned, after being burnt by my catastrophic mistakes, and I got nearly fired from the job, to also adopt the walk gingerly approach that my older and more experienced colleagues were doing. So I switched to making a little bit of a diff to the code, and then I would stop coding and carefully go compile, build, configure, run the app, log into the app using various credentials, and navigate the app, type and retype test data, then open a debugger and step through to see if the code is behaving as I was expecting. And so I've spent years developing software in such a snail-paced fashion. Needless to say, my productivity plummeted. I could barely scratch 10% of my time on the job dedicated to actually writing code. Up to 90% of my time at the keyboard was non-productive. The boss thought that's the way the cookie crumbles, and had no qualms with such slow-paced progress. The bosses didn't know any better back then. Then one day I stumbled upon extreme programming, and I think it was back in 2001. It sounded to me like the stupidest thing I've ever heard, but as Kent Beck says, sometimes that's the ticket. If you stumble upon an obviously brilliant idea, you know for sure that someone has already implemented it successfully. But a seemingly stupid idea, I had to try it. And to cut a long story short, it took me a while to clue into the fact that TDD is actually a good way to eliminate that non-productive heated keyboard waste. And I'm pretty sure Gipo is going to talk a little bit about that. The first thing I've noticed after maybe a couple of years of fumbling with TDD was that, hey, how come I'm not using debugger anymore? What's up with that? That was the first breakthrough for me. What a relief, no more endless debugging sessions. But other TDD-related breakthroughs were still waiting for me to discover them. The next big aha moment hit me when I realized that I'm not manually running the app after making each diff. That was a tremendous relief. Not having to run the app, not having to log in for the umpteenth time, and many times with different test credentials that I had to remember or have a list of, and not having to navigate and click around. That was so annoying back in pre-TDD days. And also, no need to mess with configuration. No need to manually juggle different environments. No more it works on my computer embarrassing excuses. Finally, gone are the days of having to manually type and retype and make typos, all those streams of test data. Of course, there are many more equally, if not even more important benefits of TDD, and we're going to be hearing about those today. If we fast forward to today, you will find me leading DevOps teams and teaching TDD Dojo sessions using mob programming. I'm helping people graduate from white belt all the way up to the black TDD belt. And in my world, XP and TDD rule. I could talk all day about TDD, but today we have much more capable experts than me to talk about it. And I'm definitely looking forward to that. So here's Gipo Hill to teach us about the beauty and the elegance of TDD. Have a great day and enjoy the conference. And Gipo, over to you.
Thank you, Alex, for the nice introduction.
We love having you here. We love having you here, Gipo.
Great. Thank you very much. Hi. Good morning. Welcome to the conference. Good afternoon. Welcome to the conference. Good evening. Good night. Welcome to the conference. My name is Gipo Hill, and I know that's kind of a strange name. It's Gipo. It's a nickname for grandfather. And now, you know, I'm a bitter old man, so naturally I look like a grandfather. But I actually got that name, 31 years ago, when I was presented at a very young age with my very first grandchild. And of course, that's a really young age to be a grandpa. And my friends and family thought that was hilarious. So they called me that at every opportunity. And when I put myself out in the world and started talking to people, I just started calling myself Gipo. So now you know the backstory on that name. Today, I'm going to start by the conference by talking both about TDD and about something bigger than test-driven development. And I'm going to frame this in the form of what I call garlic and rice advice. I had a friend at the start of the pandemic that, she had been a professional chef for something like 35 years. And, professional chefs in quarantine, they don't have a whole lot to do. So she'd done all the Netflix binging that she could imagine pulling off. And she had read all the books that she was gonna read. And so she wanted something to do. So she decided to write the ultimate beginner's cookbook. And she was going to do it live on Twitter. And I'm sitting here and I'm waiting for this. I'm waiting for this to start churning out of her, all this stuff. And she had one tweet, and it had 2 points in it. Point number 1, that's too much rice. And point number 2, that's not enough garlic. And I thought to myself, well, that, come on. You think about that. Of course, I laughed. You think about that and you're like, well, geez, actually, that's pretty good advice, especially for people who are just getting into cooking. Because the first thing you do when you're a starter cook is you cook a humongous amount of rice because rice swells up. And then you take one little tiny bit of garlic and you try to flavor it. And it doesn't work because garlic is a lot weaker once it's cooked than when it's sitting there in your hands. And I thought to myself, well, what is my rice and garlic advice? What advice could I give blind to just about anybody in just about any situation? And that advice is this: take many more, much smaller steps. If you want to get there faster, if you want to get to value faster, if you want to get to change faster, if you want to change code faster, take many more, much smaller steps. So unwind. You just heard my case. There's my case. I'm going to map it out in a little more detail, but let's go backwards. If you go and study the software development, design methodologies and everything from the old days, from 80s, from 90s, kicking it old school, what you're going to find is that they have lots and lots of demonstration projects. And all of these projects have 3 things in common. They have small scope. They are really ridiculously tiny compared to the applications that we write today. The typical one would be a point of sale system for are you ready for this? A videotape rental store. That would be the typical sort of app that you would see in these old school design documents. The next thing that would be true of all of them is that they all had single-threaded construction. There was one person, maybe 3 people in a small team, and they are the ones who wrote all the software from beginning to end. And the third thing that was true of all of them is that the target itself, the end point of sale video rental system, was fixed and final. It was defined at the beginning. We do it, and then it's defined for all time going forward. So I tease those books because basically they elaborated an extremely detailed software development process consisting of 3 steps: nothing, everything, move on. And the thing is, of course, I'm making a joke, right? And these people helped me so much in my career. They helped me get so strong at a certain kind of software development. And I'm teasing them when I say that, but that's really how it felt compared to what we do now, which is work on gigantic apps with substantial multiple teams to a constant rhythm of change happening inside that application at all times. So when somebody gives me a problem, almost before the second sentence is out, I'm breaking it up into its pieces. I'm solving the puzzle. I'm solving the problem. Baby, it's a geek thing, all right? It's what I do, okay? I break puzzles into parts. That's how I work. And that idea is fundamental to what we do for a living, but it's also really deep in those 80s old school design approaches. And they look like this. As they have morphed up to our current day, we decompose the problem up front into its separate final parts. We then divvy it up amongst the teams, or if we're in a team, amongst the individuals. We're going to finish each part to its final state, and then we're going to put them all together, and then we're going to move on. We're going to go to a separate project, something else. It's going to be done. It's done. It's done. Forget about it. And this hybrid approach graphically looks kind of like this. This is the sort of popular idea that you will see of how software should be developed at companies that are very small, but also at companies that are classic high-end enterprises. It looks like this. We're going to invest a whole bunch of value because we've got to pay people to do this stuff. We're going to determine the target by writing everything we know about the target down. We're going to let geeks like me break it up into its final finished pieces. Then we're going to divvy those pieces up into multiple streams that will come running towards this grand finale, at which time we will assemble all the final parts, and then we will receive the value, hopefully more value than we put into this thing in the first place. That is the sort of modern version of that 80s take. And unfortunately, it doesn't work very well. So I'm here to introduce you to this idea, and it's very relevant to TDD, but as I say, relevant to more than just TDD. Stride limited activated steps. You're looking out and trying to decide what to do. And my proposal is that you do this. You write down the possible steps you could take away from here. You scratch off any of the steps whose endpoint you could not ship. Then you scratch off any of the steps that would be longer than the amount of time that we've set for this particular activity. I'll tell you about that in a little more detail a little bit later. And then finally, you scratch off all the steps that would actually result in negative user value. Now, the user value doesn't have to go up, but it has to at least stay the same. So that's what I mean when I say stride limited activated steps. Again, going with a picture of it, this is a picture of a single step. We sink a little bit of cost. We're at a state where we are active right now. Why do I say that? Because most of us, most of the time, are already shipping. We are already, this trade in the 40 years since 1980, this trade has gone from almost no brownfield development to almost continuous 90% brownfield development. We do not get a blank page in this trade anymore. The trade is already full of a working app. So we start from a place of actually being activated most of the time. A single step then is the gap in time between the time we are activated that it creates benefit for us. And what I'm proposing is that we absolutely fix the maximum duration of that gap. In fact, above all other considerations about the gap. In other words, if the steps we're talking about are the space between two tests in a test-driven development environment, if we're coding, I'm proposing we fix that maximum duration to something well under an hour. Now, obviously, it varies depending upon my environment, but working in Kotlin, the absolute maximum that I would wait between steps, that I would be willing to sit between steps, is about half an hour. Most of the steps I take when I am test driving code in Kotlin and developing new stuff are actually more like 10 minutes, 15 minutes. I'm talking about a ridiculously small step. I used to just come on screen and say blankly to everybody, no, smaller, yeah, smaller. I started TDD 20 years ago. And if you asked me, what is the one thing that test-driven development, what is the hardest thing to learn and what is the most important thing that you learned in your 20 years of test-driven development? And it would be, no, smaller. Take smaller steps. Now, what's this going to produce? Instead of that thing with the three things and the team and the thing, it's going to produce something that looks like this. And I know that when you see this, your head is not going to instantly say that's the most efficient path. Nevertheless, that is my case, and I'm going to give it to you in some detail now. The most efficient path is to make each one of those steps you see rambling across that screen, however lazy looking you think they are, the same size or smaller, to limit the size of your steps, even if it means you're going to have to take more of them, even if it means you're going to have to take steps that don't produce direct user value, even if it means you're going to have to take steps that are off the path of the perfect straight line towards your system. Now, the walking skeleton part over here on the side, walking skeleton is a term by Alistair Coburn, and what it means is essentially we start by modern architectures almost always have layers wrapped around a core, and what we want to do when we make a walking skeleton is do the crudest, simplest thing that is one single pathway from pixels to bits, from bits back out to pixels that touches every one of those layers, the center of that layer. That's what that walking skeleton concept is. Now, of course, if you're already in Brownfield, there is no walking skeleton. You have a working app, and the walking skeleton is the working app. So you can sort of smoosh that aside if you're already spending all your time working on apps that have already shipped. But as soon as I get a walking skeleton, I can start doing stride limited activated steps, and I can bring myself onto this most efficient path. Now, so notice these circles. It might be a little hard to see on your screen, but some of these guys, all of these guys have a red ball, a red circle at the beginning. That represents the cost of that. Some of them have a green at their end, like this very first one, but you'll notice that some of them don't. That green is the extrinsic value. It is the value of whatever you got done being given to you. It's optional. Remember, I said I pick steps. I don't have to pick steps that are only going to improve the user's experience. And improving the user's experience is, of course, how we make money. We are allowed to take steps that don't improve it. We're just not allowed to take steps that make it worse. All right. So if they don't improve it, you're not going to get a green circle. And then there's this blue circle, and the blue circle is the intrinsic benefit that comes just because you finished a step, not for any other reason, not because of what that step was, but because it's in fact a step that you were taking. Here's the case in detail. Looking over at my time here, making sure I'm good to go. The case in detail is this. Although that funky looking picture seems like it would be inefficient, a large part of the reasoning that you're using to decide that is coming out of your belief that software is actually plain geometry. It isn't. Software isn't plain geometry. Step 2, the directed parallelization, the central intelligence that is doing the splitting up of the tasks and integrating them at the end. Directed parallelization is what we call NP hard. I'll explain what that means when we get there. Third thing I've already touched upon, steps have intrinsic value. They have value above and beyond the question of whether or not they actually improve the user's experience. And the fourth point, we're going to spend a lot of time on each of these actually. The fourth point is that changeability actually costs less than rework avoidance. What do I mean rework avoidance? Remember when we said we had that puzzle part? And we had the puzzle and we broke it up into its final parts? Final is a really important word there. The reason we break it up into final parts is because we don't want to change anything we already changed. We want to avoid rework. And avoiding rework is, in fact, the entire essence. It's the centerpiece of that weird three-limbed thing that is, unfortunately, the most common way that software is built and developed in the world today. The fourth plank here is that changeability actually costs less than rework avoidance cost. All right, let's take them one at a time. First of all, everybody knows the shortest distance between 2 points is a straight line, and yet my line that I've drawn on this screen is not straight. It's not a straight line. What the hell, G-Pa? The only place where the shortest distance between 2 points is a straight line is on a two-dimensional featureless plane. Now, you know this. You just don't think of it because you've sort of fallen into the trap of reasoning from a hyper simple abstraction, the beautiful, smooth plane, into thinking that that applies to the real world, but you actually know it applies to the real world. I'm not going to show you the brand name here. I'm sure you can guess, but I like soda and I drink it all the time as a comfort thing. And the nearest place at which I can buy a 6-pack of these is about a mile and a half that way. I'm out on my deck. I can't see it, but it's about a mile and a half that way. Think about the nearest place that you could get a soda if we were in the same place. I was your guest and you, oh my God, I got to get sodas for this guy. He's obsessed with soda. Draw a straight line to it. Is anybody here going to walk a straight line to that? Pfft, are you kidding me? The first thing I would do, I would fall off this 2nd-story deck down to the earth. Then about 10 meters away, I would descend a ravine that is about 25 meters deep, which I would then have to climb back up. Of course, I couldn't climb back up it very easily because my clothes would be soaking wet because I would have swum across a river in order to pursue the shortest distance between 2 points. The surface has obstacles. But here's the thing, that's not all. Act before midnight tonight, and you get not only the surface having obstacles that you have to go around and maneuver in order to get to the point fastest, but the vehicle you're in is changing as you drive it. The vehicle self-modifies. Because, what vehicle am I talking about? Oh, the software. The software is changing as you approach wherever it is you're going. Every step, in fact, changes the software. So the vehicle that we're actually using to get to this destination is undergoing modification while you are driving it. But wait, act before midnight tonight, and you get not only the surface obstacles and not only the self-modifying vehicle, you also get the fact that both the target and the obstacles move. In this way, we've finally stepped away from the concept of a plane. We stepped away once towards the concept of the actual terrain around us, but we stepped away again. Now we're off into really weird space because the terrain between me and Ashley's Market, Central Virginia, stop by anytime. The distance between me and Ashley's Market, straight line or not, the terrain doesn't change fast enough to matter to me, right? It doesn't suddenly, the river doesn't suddenly go away and then suddenly come back. Neither does the ravine. This 2nd-story deck on which I'm sitting right now has been a 2nd-story deck its entire lifetime and probably will be until the day everything falls apart. The terrain doesn't actually change and the obstacles don't actually move in real life terrain. In software, they do constantly. The terrain changes because of new tech. It changes because of new technicians. And the target, no matter how much we thought to ourselves that we understood that finished, polished, complete, perfect jigsaw puzzle, that's got nothing to do with actual software. Not only is that not the target, really, but that target itself is constantly moving. Now, you know this. Have you ever had a marketing or salesperson come to your team and say, you know what? I know I told you that our most important thing was to do X, but if you could do Y in 3 weeks, I can close a $300 million deal for the company. Anybody who's been in software long enough has experienced the target changing dramatically, sometimes honestly, sometimes with a day notice. So that's why plain geometry just doesn't capture the reality of software development. The surface has obstacles on it. The vehicle self-modifies, and both the targets and the target and the obstacles move around on us. Now, that means that the sort of detailed, meticulous planning that we would have that final puzzle put together, it isn't just hard, it's impossible. It cannot be done. You can't throw more thinking at it. You can't throw more money at it. It's not possible. Second point, directed parallelism doesn't scale. What? We have these three streams. And what we're doing is we have a central intelligence. And it could be a single person or it could be a small group, whatever, that is directing those three parallel processes. That's expensive, even a little bit. But the problem is the expense goes up radically with the number of parts that are in play, the number of entities. We have an extraordinarily strong tendency to think of the work in front of us as being like laying bricks. Now, if it takes you 10 minutes to lay 10 bricks, it is reasonable to expect that it will take you 500 minutes to lay 500 bricks. That's the blue line. We can describe problems we can describe the effort we need to solve a problem by relating it to the number of entities in that problem. That is true of nearly every problem. And there are different kinds of problem out there. There are problems where that relationship, if we express it as a function, there are problems where that relationship is a polynomial, where if you drew the curve, it would be a straight line like that nice blue, or something slightly off the straight line. If there are economies of scale, it's a very common concept from capitalism, it isn't a straight line. A line actually declines. It doesn't permanently decline, but it declines. Once you get to 1,000 bricks, it's all the same deal, right? And that's essentially what economies of scale represent. But there's still another kind of problem. All of these problems that can be expressed the way we've talked so far are polynomial on n. NP problems are non-polynomial on n. And what that means is that the relationship between n and the actual effort you have to put into the game takes a curve kind of like this red curve here. Juggling bricks. We're not laying bricks anymore, we're juggling them. I'll come back to that in a second. So what are we saying here? What I'm saying is, of course, the problem gets harder when you make the problem bigger. So bigger number on the input, bigger on the effort. NP problems don't just get bigger on the input to bigger on the effort. They get bigger on the effort. Now, I know that not all of you are computer scientists, but I know some of you are computer scientists, and you know I just gave you a very loosey-goosey description of the concept of non-polynomial problems. An NP hard problem is a problem that has a curve like this red one that can be broken up into smaller problems, each of which has a curve like that red one. In other words, NP hard is harder than what you probably mostly learned in school, which was NP complete. Okay. Directed parallelism is this business of managing your 27 teams working on one application. And what we're saying here is that that problem is NP complete. It works fine when the N is 2 teams. It works okay when it's 5 teams. It becomes impossible when there are 20 teams. I'm just guessing at those numbers. I think they're actually probably a little smaller in real life. I think the best way to understand it is that, as I said, the difference between laying bricks and juggling bricks. If it takes you 1 minute to do one brick, it takes you 10 minutes to do 10 bricks. But bump, as long as you're laying them. No one in the history of ever has ever successfully juggled, anybody? 12 bricks or 12 anything. The world record for juggling, and it's disputed. There are two people. One claims to have done it and has witnesses. One did it on video. There are two people in the world who have ever juggled 11 things at one time. Just two. Juggling bricks is an NP hard problem. It's got a curve that looks like that red curve on my screen, not a curve that looks like that blue. And what I'm saying is that directed parallelism, a central intelligence managing all of this, is also an NP hard problem. Now, you don't have to take my word for it. You can look around. How many meetings you been in this week? This week, were you in a bunch of meetings? Were they planning meetings? Were they scrum meetings? Were they stand-up meetings? Did you use Jira? Did they take a lot of time? Managing directed parallelism is extremely expensive and extremely difficult. What about your last 5 deployments? Were they press a button, ship that bad boy? Or were they spend an hour, stress? Oh, brush fire, put it out. Oh, brush fire, put it out. Oh, brush fire, put it out. The reason is because they are the product of directed parallelism. They're the product of individuals or small teams who are cherry picking changes to a system in order to get it to the deployment stage. Directed parallelism does not scale. And that's the second plank of my case in favor of many more much smaller steps. Now, my third one, boring slide, sorry, didn't have time. Steps have intrinsic benefit. Steps are good in and of themselves, especially if we're talking about systems that involve humans. All those little steps, jiggity-jaggeting across your screen, every single one of them offers reversibility and steerability and interruptibility. I'm going to put those 3 first, and I'm going to kind of clump them all together. Do you ever see that, or did you ever hear, I'm sure you have, you might have even said it yourself from time to time, if you interrupt me, I have to start over. I can't talk to you right now. And you know what? You might even use the juggling metaphor. I can't talk to you right now. I'm juggling 9 things. And if you give me a 10th thing, I'm going to blow it. And I'm going to have to drop all the balls. I'm going to have to start all over again. God, why are you constantly interrupting me? The reason that is so is because you are between 2 states of availability, of shippability, of completeness. Between those 2 states, you can't be interrupted. Not by your boss, not by your colleague, not by your kid, not by your dog. You can't be interrupted. If you're interrupted, you have to start all over again. But if you're at one of those arrows where you have actually applied, you've actually put the change out to the world, then cool. Let me go help you. Let me go help you with that toy. Let me go help you with this meeting. Let me go help you here or there or the other place. That is interruptibility. But it isn't just interruptibility. There's also steerability, because here's the thing. Same thing exactly. If I'm in the middle of a step, I can't steer. I can't change direction. I have to finish that step. Now, if I finish the step, I'm interruptible and I can steer. I can go in some different direction than what I was planning to go on after that. But if I'm in the middle of that step, I can't. So interruptibility and steerability are kind of the same thing. We can't get the one unless we also have the other. And steerability is a huge value. And of course, personally, as individuals, Interruptibility is also a huge value. What about reversibility? Well, these are small steps. And one of the big differences between taking many more much smaller steps and taking these great big gigantic strides is this. It's okay to be wrong. You can take a small step, look at it and say, yeah, no, I don't really like that. Let's take it back. If you're coding, and we started this conversation by talking strictly about coding, what does it cost you? Remember, I already timed it. I said it's going to cost you somewhere significantly less than an hour. Taking it all back is no big deal. Git reset -- hard. It's no big deal. I know. If a lot of people think the programming is typing, programming isn't typing. Programming is thinking. And when you throw away your code, you're not throwing away your thinking. You're throwing away your typing. Reversibility means that our small steps can go forwards and then they can go backwards. And they can go off at this sort of angle and then right back down to that sort of angle when you realize you headed in the wrong direction. So there's two ways in which we can effectively do reversals when we have taken small enough steps. What about grokability? Grok, I'm hoping everybody here is comfortable with that term. It comes from Robert A. Heinlein, Stranger in a Strange Land. Grok means to understand instantly and intuitively and correctly and perfectly. Okay, but we use it casually to say, I get it. I see what's going on here. I grok this situation. So grokability is our ability to hold the whole step in our head at one time. It is, in fact, another kind of juggling. The N, in terms of step size, is always about how many things do I have in play. In code, it's typically how many small elements of the code do I have to line up before I'm available, before I've shipped, before I've actually applied the change that I wanted to apply. When that N gets big, we're right back at that juggling. We're right back at that juggling curve again. We have hit an NP difficult problem. Only this time, the problem isn't a mathematical theory problem. It's actually a problem of psychology. 1954, George Miller proposed that based on the research his grad students were doing, he proposed that the limits on human bandwidth were, this is a famous number, you might have heard of it, 7 plus or minus 2, somewhere between 5 and 9 things. And since then, that proposition has been tested 1,000 times by grad students all over the planet. I mean, 1954 was a long time ago. And here is the thing. The modern consensus is that Miller was wrong. God, he was so wrong. The actual number is more like 5 plus or minus 1. Really? The limit on human mental bandwidth is between 4 and 6 independent entities, balls in the air that are unrelated at one time. Now, of course, the balls we're working on in our steps are somewhat related. So that number can go up from there. But what we're saying is that when I take a smaller step, I have fewer things in play. And because of that, I am more likely to be able to hold all those things in my head and manipulate them successfully mentally as I manipulate them successfully in the code. What about rhythm? Rhythm, computers don't care about rhythm in any way, shape, or form. The code doesn't care about rhythm in any way, shape, or form. So then, why do software development teams care so much about rhythm? Why do software development organizations want their people to have rhythm? Because the humans use rhythm very, very successfully and importantly. Periods of tension, periods of release. Alternating tension and release. That thing has actual biochemical impact in your head, right? It actually changes you when you go from tense to release, tension to release. Smaller steps gives us more and better rhythm. One of the things that we always do whenever we make a big release, like in those old school technique, we always have a great big party. We're so happy. Then we go back to work on Monday and start shipping the first hot fix, but that's neither here nor there. And the thing is, it's supposed to be this tremendous reward for us. It's supposed to make us high on life. Mostly what it does is make us high on alcohol, but that's neither here nor there. The bang from a big bang rhythm release is actually very short-lived, because your body doesn't actually care that much about how much reward it gets. It cares about whether the reward is distributed correctly on an as-needed basis. And rhythm is the thing that lets you do that. It is one of the most fundamental elements of motivation. I've written about that. You can talk to me sometime about ramps, where rhythm is actually one of the first and most important elements of human motivation. Smaller steps let us control rhythm. Finally, we have target parallelism. Do you work on a team whose customers have a single interest? Whose stakeholders, whose boss types are all interested in only one thing, the same thing? No, of course you don't, because nobody does. Because everybody in the room upstairs, the fancy room that you don't get to go to unless you're really, really in trouble or really, really good, they are all individuals with their own interests and their own pursuits and their own targets. One of the great myths of software development is the idea that you are only ever servicing one target. You are constantly servicing many targets. So how do smaller steps help with that? The granularity of the steps lets me say, I'm going to do this part from column A from that boss, and then I'm going to do this part from column B from that part boss. And it doesn't only just let me do that on a, oh, it's the rules. It actually lets me smoothly adjust the gradient. If at some point or another it really does seem like the company is more interested in the column A target, I can put more column A work into the game. And vice versa, if it's column B. Or, remember steerability, if it's a whole new thing that had never occurred to us when we were planning our operation. So target parallelism becomes a very real thing in small steps. I can't do that if my step is enormous, because remember, I can't do anything else while I'm doing a step. I can only work on that step. So I just can't get there unless I fall back to directed parallelism. And we've already spent a whole bunch of time talking about how directed parallelism just isn't going to get us there. Whew. That was a really long time on one slide. Let's talk about changeability in TDD. Really, I'm not. What I'm really doing is I'm going after my fourth plank. I'm pointing out that rework avoidance processes are actually extremely expensive. And now I'm going to talk to you about the fact that actually changeability and our modern changeability practices are not terribly expensive. Specifically, let's start just with test-driven development. We're here at a test-driven development conference. TDD gives us automated consequence detection. What do I mean? What I mean is when I'm doing test-driven development, I'm writing a test that says, remember, it fails because it doesn't do that yet. Then I make a change and it passes because it does do that. The consequence of my change is actually detected. And it's not just detected, it's actually detected automatically. That is by running the program. Running the test kit. Furthermore, I don't just run the one test, I run all the tests. So not only is that true in terms of me being able to detect the consequence of my change for the new work, it's also true in terms of me being able to detect the consequence of my change for the old work. And that is actually of more value than the new, to be perfectly frank. Why? Because the worst bugs in the world are the ones you had no idea that you just shipped. The ones where you make your users experience sometimes astonishingly bad because it never occurred to you that the consequence of this tiny little change was actually going to be to completely destroy the application and bring down the entire continental power grid and the stock exchange at the same time. It simply never occurred to you. But automated consequence detection helps with that a lot. Next thing TDD does in terms of making it possible for us to do this is context switching support. Interruptibility means going from one context to another. Context switching is inherently somewhat expensive, but the tests that we have in test-driven development help us tightly narrow our focus. I don't want you to think about that other context you were just in. I just want you to think about this context right now. Furthermore, that context is mechanically described. That's the automation of our consequence detection. Context switching support is enormous for helping us manage these humongous products and projects that we work on. Finally, there's collaboration support. You know, when I'm arguing with somebody about what the code does, blah, 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 I'm such a pain in the butt, right? And the other person's like, no, it takes that problem, it handles that problem, blah, 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 blah. The thing about the tests are they are executable documentation. They are proof. If I'm so convinced that the code won't handle X, well, I should write a test that fails because the code doesn't handle X. In fact, doing that is actually significantly faster than the 5 emails and the 2 meetings it takes for me to talk to somebody else about the problem. I can show up with the test. I can prove that it doesn't work, or I can be astonished and delighted that it does work, and I can add that test into our automated consequence detection. Rework avoidance, all the parallelism, the management, the control, the sit down. One day, Winnie the Pooh sat down and began to think. Think, 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 think. Rework avoidance theory is extremely expensive. We have learned an enormous amount about managing change in the last 20 years because we had to. And test-driven development is just one of the consequences of that learning how to deal with change. There's more changeability technique, right? And the world doesn't just revolve around TDD, even though I know this conference does. There's working by story. Stories also narrow our focus part of the way. They narrow it down to this is the next step. Next stepping is, of course, fundamental to what we're trying to do. Most stories, even in shops that are practicing Agile, most stories are required to end in a green circle. They don't have to. That's one of the great myths. But it doesn't matter. Stories narrow the focus part way to next step. Pairing, mobbing, and the new word for mobbing is ensemble programming, which I approve of. I just used mobbing here because the slide's a little bit older. These two things maximize our collaboration and our knowledge sharing, which are critical to handling incoming changes. Remember, these things are so big, we don't have one person who knows everything about them anymore. It's not like the 80s. We have to have many people in the room, and they have to be collaborating well. So everything we learned about pairing and mobbing is that we actually increase the changeability of not just of our code, but of our whole process. Trunk-based development. Oh, Lord, please kill off those branches. Please, my friends, you've got to get rid of those branches. They are not helping you. They are hurting you. Trunk-based development, coupled with the pairing and mobbing, coupled with what we call pull and swarm, where we take one story and push it all the way through the system before we take on another story. All of this is optimizing our parallelism at minimum cost. Now, it's not free, but it is minimum. Why? When you saw all those arrows bouncing around, all those individual steps, hey, you know what? Every one of those was a shippable moment. Every one of them, there's no requirement that they all be done by the same person or the same team or anything. The only requirement is that each step is small enough and shippable at the end, that it's actually applied. If it's applied, we're good. We can do all of this and optimize our parallel process. Parallel targets, yes, but also parallel work streams, parallel people contributing to the product. As I say, there's no free lunch. Almost done here. There is no free lunch. I'm not proposing to you, if there are any boss types or CEOs in the room, I'm not proposing that this costs you nothing. It does cost you something. You have to do some unlearning and you have to do some new learning. The biggest single thing you have to unlearn is this idea of pre-commitment, where you commit to the finality of a target. If you can let go of that, you'll probably be able to find the other two pieces of this. And the other two pieces of the unlearning are letting go of hierarchical command and control. You do not need a central intelligence directing your parallel process. You need granularity that is small enough that you don't have to solve every problem in your head before you solve it in real life. That's what you need. And then finally, additive production reasoning, which is all that whole rework avoidance concept where every step takes the surface of the product, one unit of stepdom further. We can add them all up. We can roll them up in Jira. We can see the status of every line of code. Letting go of that. Unlearning that stuff is not easy because we all came up, especially the older folks, we all came up in a model in which pre-commitment, hierarchical command and control, and additive production reasoning were fundamental to our model. But you got to unlearn them. Meanwhile, there's stuff you got to learn. Test-driven development itself. I learned test-driven development. I started learning test-driven development about 22 years ago. And I would say it took me about 2 years to get to the place where I was sure where I was pretty confident I knew what I didn't understand. Then it took me about 2 more years of practice to come up with tentative solutions to those problems I didn't understand. And then it took me about 2 more years of practice to get to a place where I don't have any automated answers to these problems anymore. I'm able to actually look at each puzzle independently. I don't give rules. I don't use never, always in my test-driven development lessons or in my test-driven development work. Instead, I rely on my judgment. I fly by the seat of my pants. And remember that the seat of my pants, my judgment has come from making many, many mistakes over a long period of time. Now, it wasn't all red bars. There were wins, big wins along that way. But you got to learn test-driven development. It isn't as simple as red, green, refactor. Nothing in life is as simple as that until you get extraordinarily good at it. Next thing you got to learn, path-focused design. Path-focused design is this business of making sure that every step is actually shippable. It means changing yourself away from this model of the finished part and towards this model of I need to ship this even if it's not finished. Path-focused design is about attending to the idea that I've shown you in that effective change path that I showed you before. Finally, you got to learn how to collaborate. The best collaboration that we have comes at this point from mobbing, from pairing, and from swarming. Swarming is, we're not in a mob, but we're all working on the same problem at a different time. I mean, at the same time, just gathered around a table on our individual machines. That's what swarming really is. Mobbing, pairing, and swarming are hard. They're not natural skills, and they're especially not natural skills in a trade dominated by the belief that knowing syntax is at the heart of programming. And unfortunately, our trade is dominated by that belief. So we got a whole lot of people who think that there's a technical solution to every problem, who think that it would be best if we all sat in darkened rooms and worked quietly by ourselves to spin out brilliant thoughts. And, you know, that's not insane. It comes from our history, because in 1980, that was actually a pretty damn good way to write programs. It's just not a good way to write programs anymore. So that means that we have to learn collaboration. We have to learn how to pair well. We have to learn how to mob well. We have to learn how to swarm well. These things were not taught to us. And most of us did not, you know, grow up in a way that we could understand how to apply our relationships that we have in our households and our families, our successful, happy relationships, to our work life. But now we have to do that. So we're just about done here. Throw everything you got at a walking skeleton to get to a walking skeleton as soon as possible. That's only true if you're in Greenfield. The rest of the time, we're in Legacy. We already got ourselves a walking skeleton. Adopt the 3 criteria. Each step must fit. Each step must be shippable, must be put into the field. Each step must not make the user's experience worse. Third, use multiple teams or multiple individuals adding steps to approach the minimum viable product. And fourth, keep going that way. This is the route to effective change. And it's actually represented right there in test-driven development. But I said at the beginning that we were going to talk about more than test-driven development. This is the route to effective change in your code. It's the route to effective change in your person. It's the route to effective change in your process, in your teams, in your organization. It is the route to effective change everywhere, which is a central part of my thing. And it is the thing that I learned by learning test-driven development, or starting to learn it. I'm still learning it all those years ago. So I know that I'm sitting here with a room full of people who are actually technicians, but I'm going to ask you this closing question, which is just this. What do you want to change? You don't have to just change code. Look around you. Look around you outside. Look at the world. We can change the world using exactly these ideas. If you want more value faster, if you want more successful change, if you want more money, if you want any of those things, my rice and garlic advice to you is take many more, much smaller steps. Thank you very much. And thank you, Alex and the other organizers, for helping me and for getting me all set up. And I am good to go, I think.
Thank you, Jupa.
Thanks.
Listen, we are now really regretting calling you in, because a lot of us speakers are thinking of quitting. There's nothing more to say, basically. And well,
I don't think so. I'm going to be watching the rest of the conference. So.
You kicked it out of the ballpark. What I would like to ask you, Jipo, if you have time, please go back, and if you have time, read the comments. It's a shitstorm of phenomenal comments. People are blown away, bowled over. You also managed to confuse some people. We did talk a little bit while you were talking about branching being poor man's modularization. And the recommendation is to maybe stop branching and be more collaborative and work in real time on a real code base. Do you have any further advice on that? How do we clarify situation? Some people are confused. Like, I don't understand. How can I get rid of branches? I have a local branch. I'm making diffs. Isn't that a branch? What's going on there?
You know why you need those diffs, and you know why you need that branch? You need them, of course, because the step you're taking is very large. It is so large that it's going to take you a long time. It's going to have a lot of moving parts to it, and it's going to be broken Your code is going to be broken for a long period of time. That's why we have branches. What if our step wasn't that big? Now, you'll look at this and you'll say, well, I can't make my step any smaller than this, GPaw, you cranky old bastard, because you're too attached to positive value. You're too committed to, I can't put code in the system unless it makes the user's experience better. But that's why I introduced that third criterion, which is it has to not make the user's life worse, right? I've changed a greater than to a greater than or equal to in strictly geek terms. And once you do that, once you let go of this idea that it has to be on the straight line to user value, then you can make those steps small enough that actually you can make them pretty fearlessly. I'm not saying that that is easy for people who've spent their lives not thinking that way to learn, but it can be done, and it is done all the time, in fact.
Thank you, GPaw. There's so much to unpack from what you presented today. Even though I know I read absolutely everything you write. And folks, please subscribe to GPaw's newsletter. This is like a gold mine of all these things are there. But now today I learned many more new things, and I'm pretty sure you're going to be tweeting and handing your muses about this.
I'm easy to find. GPaw Hill on Twitter. You'll see it all come spewing out of me, including the angry opinions and the music commentary. So
music,
check me out.
Playlist music. If you ever get in doldrums or something, just ping GPaw. He's going to give you like a beefy list of music to listen to. He's going to even comment. He's going to say, "Look, pay attention to this, to how Pat Metheny now soaring on his guitar, and isn't he describing what's happening in your head right now? And how is that possible?" So, GPaw, you're amazing. We love you. You and I had talks before, and we're constantly back and forth. Please go back and read the comments, and if you have time, maybe reply to some of those.
I absolutely will. I'm going to have to log in, it looks like, in order to answer them, but I will.
Sure. Awesome. Anything else to add? Because we were now moving into another big, beefy presentation. But before we go, would you like to add anything else?
Look outside the monitor. Look outside the monitor, people. Don't just use these ideas to change code. Change the world. Change the damn world. That's all.
That's all. Awesome. Thank you. So now, I am going to introduce Mr. Agile himself, co-author or co-signatory, my friend and dear colleague James Granning, a phenomenal kick-ass software engineer working with embedded systems, and you know that this is the real deal. He's not dealing with piddly stuff. James is phenomenal. I owe so much to James for introducing and teaching me Zombies formula, which I use daily. It's just a brilliant thing to introduce James. Also, you did introduce the planning poker and other things. I will let you talk now. We're looking forward to your presentation, and take it away. Have fun. Oh, for some reason we're not hearing you. Is your mic on? Can others hear James? No audio. No audio for some reason, James. I don't know if you can hear us. James, can you check in your settings on the camera and microphone, you should be able to check the microphone setting in the StreamYard. Sorry, folks, we're having some technical difficulties. But we're not running out of time yet. Oh, of course, it's going to be worth the wait. Yeah, in my case, I had to disable my external microphone. It wouldn't work with this guy here. Okay. Yeah, James, on our side, the microphone icon is crossed. It seems like it's muted. I don't know whether not active or maybe try re-entering. Leave the studio and then enter again. Maybe that will fix it. Okay. So, any good jokes while we're waiting? How's the weather today for you guys? We're already getting pretty hot. It's in Vancouver. It's early morning. It's 8:22. It's James. Sorry about that, folks. But anyway, thank you everyone for amazing comments and questions. I was reading and I was like, wow, this is gold. And many of us here as speakers, we have a back room, and we were chatting about the comments, and they're great. And too bad we cannot have more time. Oh, here's James. Hey, oh, still not working. Oh my God. What's going on? Murphy's Law, Gremlins, and etc. I cannot unmute. Oh, it says here your microphone isn't connected. From my end, let's see if I can. Okay. James, maybe you could share your screen, and maybe we can mob style troubleshoot. And you can hear me, right, James? Yeah. So maybe disconnect if you have your external microphone and use the PC built-in mic. Try that. James is asking someone to call. Yeah. Ad blocker. Oh, maybe it's an ad blocker on your PC. No. Tried to call you, but it was busy. Try again. Hey, so you know ad blocker, right? Mm-hmm. Okay. So while we are maybe waiting, GPaw said he can maybe entertain the crowd while we are trying to figure it out. Would that be okay? Dave says here maybe browsers is denied access to microphone. No, no. Maybe, yeah, maybe reboot.
All right, can you hear me now?
Yeah,
All right.
finally.
Can you hear me now?
Yep. Take
Oh,
it away.
geez. Well, the mysteries of Linux. So I just wasted 10 minutes. Sorry about that. I wanted to start out. Hi, everybody. Thanks for coming in. I'm sorry about my inability to get technology to work. But sometimes it's a mystery. I think oftentimes all this stuff we use works by accident. And, so now Mike and I go back a long ways. So it's really interesting to hear Mike discovering things, and I feel like I've discovered some similar things. And I know that test driven has changed me. And a couple of notes I took from Mike is, consequences. What's the consequence of this next change? And, when you go and do a bunch of things all at once, and then you spend, a day trying to figure out what you did wrong when you did 5 steps of a process that's supposed to lead to a new web page coming up, and you debug it all day. And then the next day you get to debug all the things you changed that you shouldn't have changed. Mike's talking about consequences there. Now, I always try to look for this natural problem-solving path. There might not be one, but so you invent one. But if I don't do the thing, what happens? And can I move my code a little bit closer and closer and closer to the target? So I never anticipated that that's what test-driven was really going to do, and it's moved into a lot of my my life. So it actually has kind of changed my life as well. But so, Mike, great talk. Thanks for that. Let's see now. I can see you can see part of my screen. I'm going to probably have to adjust this a little bit. So give me 1 second now that I'm seeing my cropped screen behind me. And I got to get out of the way a little bit. So I'm going to talk to you today about technical excellence. And this talk started about 10 years ago when the Scrum people invited me to come and talk at their Scrum gathering. And I said, well, I've got some problems with Scrum. Is it okay if I tell you about it? And they said, well, sure, that'd be fine. Just be nice. And it's like, okay, I can do that. But at any rate, technical excellence, as a young guy, computer programming is just about typing. I saw this and thought, stay away. I don't want to be typing. This is the last thing I want to do. It's like it wasn't cool to type back when I went to high school. So I tried to avoid computers. And then I ran into a calculus class where the professor made us do some programming. And it turned out it was fun. And I realized someone would repay me. And that's kind of how I got started down this path. And the day I walked into my job, somebody handed me this page out of a spec, and I became an embedded systems engineer. I had a little electronics background with my EECS degree, but so I got involved in embedded systems. And back in those days, we got to toggle in the bits to boot the computer. That was always a fun and not error-prone task at all. Kind of primitive. If you want to erase your program, you had to shine UV light on it, and that would erase your program. And you had some tools, kind of clunky. You could probably shoot a 30-06 at this and wouldn't do any harm to it. And you debugged your code with logic analyzers and maybe printed out output. Well, if we had a spare serial port to print out debug messages, that would have been an amazing innovation, but we didn't have any such thing back then. Now, this Agile thing, so 21 and a half years ago is probably when I met Mike at the bar in, sorry, Mike, telling the true story here, at the bar in Deerfield, Illinois, Extreme Programming Immersion 1. So back in those days, I'm learning from these guys. There's Kent and Ron Jeffries, Ward Cunningham, Martin Fowler. They were all at this, and Mike was there too, and we're learning from these guys. It was really, Mike knew a lot more about it than I did at this point. I was kind of a super newbie, and Mike was maybe about a year into it already. But extreme programming, and extreme programming is, kind of what I've put my arms around as important thing to the way I develop and kind of the way that I work a lot of technical things. This Agile Manifesto thing that I was invited to, Bob Martin, who I worked with and have known for a long time, we were lifelong friends, professional lifelong friends. He said, James, do you want to go to the Lightweight Method Summit in Snowbird, Utah? And well, a younger James said, where? Yeah, okay, I could make it. We're going skiing. Yeah, I can do that. And at the time of the Agile Manifesto, this was a very popular book, right? Managing the Software Process. And this said some words to the effect that made us think anyway, that if you just had a better process, the people wouldn't matter, right? It wouldn't be a people problem. It would be a process problem. You just have a better process. And I kind of came into extreme programming with this on my mind. And, there were companies, ones that we were consulting with, that said, well, the coding is not a valuable skill. We're going to do all the design work here in the United States. And then we're going to email those designs. Were they using email back then? Yeah, of course, they're using email back then, to other places where we can get that work done more cheaply. And, there's plug replaceable programming units. And I don't know if this was Watt's intention, is that the people didn't matter, but this is what the industry was hearing: better processes. And I saw extreme programming as a better process, because we were suffering a lot from defects and delays and frustration. And so here's this Agile Manifesto thing. And I just bring this up because the first statement was like kind of mind-blowing for me, because here I'm with all these technical guys. I'm expecting to be talking about technology, and they're talking about people. And that's what the first statement was about, and the puzzle that is people. And this is, a lot of Agile now is focused on the people side. But, me, I'm just an engineer, and I'm kind of looking at how do we do the work. And that's really what drew me into this. I'm not saying the people side's not important. We'll come back to that. But let's talk about the engineering side. A phenomenon happened. Somebody offered a certification, and people started taking these Scrum classes. I'm sure there's some of you out there that are certified Scrum masters or some such thing. And so here's the first ever class. It was held at our organization in the suburbs of Chicago. Ken Schwaber's there, and Mike Cohen, some others. And, Scrum has gone a long way. There's hundreds of thousands of certified Scrum Masters. This is old data. I was looking for the up-to-date data, but this old data will work. There's 300 and some thousand certified Scrum Masters in whatever year this was, 2013, 2014. And, Ken, what's Scrum supposed to do? Well, Scrum exposes the inadequacy and dysfunction of an organization. So you can find your problems, right? This is about continuous improvement. Make problems transparent so you can fix them. And, there's something we were studying back then in the 80s, which sounded really similar to that philosophy, that approach, which is total quality management was the name it was known by before. Then it changes its name every decade. Six Sigma, Lean Six Sigma, whatever they're calling it these days. But involved in it is the problem-solving cycle, right? Plan, do, check, act, PDCA. There's a number of different acronyms that surround this cycle, but it's all about what problem are we solving? Would this work? Let's go try it. Oh, it worked. Let's institute that. Oh, it didn't work. Let's not institute it, right? So here's this cycle. Good idea, Scrum. But what are most people in Scrum doing these days, it seems? They're doing the do cycle. Okay, somebody goes off to Scrum Master School and comes back and has people doing this iterative cycle. We're going to get into some of the consequences of this, but I'm still kind of seeing that the world is blind to what's happening. And we're following this, too many people end up following this dogma of Scrum, right? Dogma followers, not so many problem solvers. So I'm seeing this do cycle in Scrum, and what could we do different? And here is a book I ran into in researching for doing a talk like this, and the debrief. I'm interested in aircraft and fighter pilots and such. My father was a World War II fighter pilot, and so I wanted to find out, how did pilots go through continuous improvement? And this author of this book describes what his path to becoming a fighter pilot, and how if he didn't learn to fix problems in himself, in his abilities, in the problems of flying an aircraft, he never would have been able to fly. He said you got two chances to get better at something. And if you couldn't continually learn and get better, there'd be a problem. So here's a problem that the Air Force had, refueling. High stress for the pilot of the plane being refueled. You got to fly behind this little point there, right? And nose the airplane into that so you might be low on fuel, and you might have just come up from a battle, so you're fatigued. And this is a hard thing to do. And so they wanted to solve this problem. And now fighter pilots are tough. It's like, no, I can do it. I'm sure, my dad was a mild-mannered guy, but, lots of special breed. Well, they came up with a new solution. Why don't you go fly formation behind the tanker and let the tanker boom operator worry about filling your plane up? So now the pilot gets to relax for a little bit, and here we go. They made an improvement on that process. And so what's Scrum supposed to do? Oh yeah, Scrum's supposed to do this continuous improvement. And how are we doing at that? About 10 years ago, let's see, before I get into that one, here's an interesting article by a guy named David Dunning. I'm sure, famous guy, but he surveyed some companies about how they're doing. And 32% of the engineers at a company said that they were in the top 5%. And another company said 42% of the engineers think they were in the top 5%. And I love this statement he makes here is, so much for being lonely at the top. That's pretty good. So 40% think they're in the top 5%. And by my math, no, it's not really scientific math, but 87.5% of them are definitely wrong, because they can't all be in that top 5%. And a guy that I know, a friend of mine, online friend, wrote this article. Well, you've seen the Dreyfus skill acquisition model before. And, you go through a progression. There's being a novice and an advanced beginner and starting to become competent. Then you get good at something you're doing, and then maybe you go on to become an expert. Right now, people doing software development, you can do a lot of amazing things. You can get things to work and that other people can't do. Programming is really hard. And what my friend observed in his own trying to learn how to bowl was that he initially was really good at bowling, but he plateaued because he had some fundamentals wrong. And so he self-diagnosed himself as an expert beginner, and to get good at bowling, he had to go relearn bowling and lower his score and work his way back up to take the top away. And one of the things that he thinks happens to developers is that we get this idea that we're an expert and that we know everything. Now, there was a long time ago when I got out of school, I kind of thought, a new field, software development, I kind of thought I knew everything, but I got to tell you, you don't know how much you don't know until you think that once, and then you start to learn stuff and realize, there's a lot to learn in our world. Getting the app to work is not easy, right? Something I would call, in tongue-in-cheek, the aptitude test. See how I spell it over there, right? If you can get the app to work, you might have an aptitude to become a professional programmer. But getting the app to work is just a start, right? There's a lot more to it than just getting the app to work. Now, how's our industry doing at improving over these 20 years of Agile? I know we're at a test-driven development conference, but for me, test-driven is at the core of it. To be successful, you need it. And so that's why I'm taking you through this story here. Alistair planned a meeting about 10 years ago of people that were in the first Snowbird thing. And of course, it was the right place, so I had to go back. And this was a more planned out meeting, but we did come up with some ideas about what to fix. And the number one thing to fix was demand technical excellence. And for that, we have to be willing to change ourselves and to help others change. There's some other points, I don't remember them, what they are, but these two really stuck with me. And these were ones that I had voted on as being an important thing about our industry. Now, we know what Ken says Scrum is about, but what's really happening? Well, unfortunately, what Ken says, people change Scrum to meet their inadequacies. Now, that makes me think Ken is saying don't change Scrum, but I don't think that's what he means. I can't really speak for him, but I don't think that's what he means. Try Scrum and then adopt it, but we're still having some of the same problems. Right. I'm sure a lot of people's lives are better, but some are still suffering. And if I look at this picture here, move over a little bit, we're iterating. And, when you start out in Scrum, they just say, start iterating. Oh, and I'm not using the S word, sprint. I'll show you in a second why not, but I'm not using the S word. So when you iterate, if you save your test till the end, what starts to happen? Well, at the bottom of this waterfall, there's no real problems, right? We're just looking for bugs. It's nice and peaceful. There I am under the waterfall, just enjoying life. And actually, the bottom of the waterfall is more like this, not that peaceful time down there. You're getting crushed. all your options have been used up, right? The pressure's on. Everybody's upset, bothered. They want to release. Those fires Mike was talking about, brush fires. Where do the brush fires start? Oh, look at, there's a name for this thing at the end of all these iterations, hardening. And I know a few years ago it was popular to talk about the hardening sprint. Ooh, now I use that word, sorry. The hardening sprint, where you go and start to, finish your testing. What happens during that hardening sprint? Well, there's some little brush fires and we put them out. And then someone says, that might have been the last bug. And then, what happens after that? You put that one out, and what happens next? Well, it seems like the firefighting goes on. Now, these guys have all the latest debugging and firefighting equipment available, and they're struggling, trying to get the fires out. And, here we are. The fire's coming under control. Things don't look so great. Why does this happen? Don't worry. We're 90% done with this bug fix. Can you really say that? Hacking in new features, chasing bugs, it's not what I would consider technical excellence, right? We'd like to prevent those things. Jeff Sutherland says the biggest problem is people can't ship a product after every sprint. There's that word again. Because everybody's busy doing the do cycle and they're not doing the improvement part. Oh yeah, sure, you're running your retrospectives, but what's really being focused on? What's our velocity? What's the due date? Can we get this done? Here's somebody ringing the bell. Come on, let's get back to work. A question I have for you. If you're in a Scrum or Agile environment, you're changing the cadence of delivery, right, to, now DevOps and such, continuous delivery. But if you're every other week trying to deliver, or every week delivering, you're changing the cadence of development. Have you changed how you do engineering of your products? Have you changed how you do the development of the products? Not just the delivery, the development. So I say incremental management and planning without incremental engineering skills is a recipe for pain. And excuse me, 1 second. Really? Hi. It's been totally quiet around here all morning, but due to my being late. Okay. So I'm going to propose a marriage of, what a lot of the world is doing right now, which is iterative development a la Scrum, and the engineering practices of extreme programming. I wonder, how is that marriage doing so far? There's somewhat of a marriage already. If you will go look at the Scrum world, there is a certified Scrum developer. And if we look at the numbers, on this day when I got the numbers from whoever it was at the Scrum Alliance that gave them to me, there were 333,000 Scrum masters, and there were 54 and some thousand Scrum developers. Interesting. I wonder what that means. Can we infer anything from those numbers? Well, yeah, obviously it takes 6 Scrum masters to master 1 CSD. Oh, of course, that's a conclusion to draw. Now, the developers kind of feel like when they send off their junior person to go to Scrum Master school, or maybe their manager to go to Scrum Master school, they come back and they start to feel like they're micromanaged. Now you have to have a daily meeting instead of a weekly meeting, right? So you get this micromanagement. And then they're talking about these sprints, and we've seen the Olympics. This is why I don't like to use the S word. You see what happens in the Olympics, and it's not just the ladies that can't survive and have, after they've given it everything, the guys are laying on the ground too. And then somebody wants to help them up and have them run another sprint. Okay, so I kind of object to that. And focus on how much can we deliver this iteration, right? Focus on this thing and committing. I liked how Mike talking about these commitments and such, but this person actually didn't know that they could have delivered this plywood to the job site in probably 5 small trips instead of 1 big trip. This didn't work out so well. And, we're wondering why the projects don't always end so well. So maybe we're not so good at bringing some of these ideas into the world. I was on Quora, and a question came across to me, and I read this question. Question in a nutshell: why do a lot of developers dislike Agile? And well, if you went and read the answers here, and there were a lot of answers about how these developers hate Agile. And if you read about what they were doing, you found out what they were doing was not really Agile at all. They were doing something that someone called Agile. They were iterating, but the engineers had no idea how to actually do iterative development. And so it was very painful. I wrote a little reply to it, and just to show about the popularity of how the world sees the negative side of iterating and not being ready to iterate. They don't understand maybe that part of it. There's 500,000 likes on the negative side of Agile when I looked at it. And well, I was kind of surprised that actually 100,000 people pushed like on mine, but that was kind of nice. But the bad news is the dislikes of iterative development a la Agile are bigger than the likes. It's kind of a problem. So why? Okay, what's missing? And I was out to dinner and with some business people, and as things go, I work my way onto the soapbox, and I said to the person I'm having dinner with, people are only doing the easy half of Agile. And he says, well, what's the hard half? I said, well, the hard half is the technical excellence side, of course, the part that I've got an affinity to. And he goes, no, that's not the hard half. The hard half is the people. It's like, oh, shoot. There's 3 halves: make room, technical excellence, and iterative planning. We've got to respect people too. And it's like, oh gosh, Kent and Ward and all the guys at the Agile Manifesto meeting thinking about the people side really is so critical, because we have to respect people's abilities to get this work done. And you need all 3 of these halves to be successful. And so you might have, you've seen this slide now here. If we get started in iterative development and iterative management, it's going to feel bad. It's going to hurt. You're going to be scared. You're going to wonder why no one cares about quality work anymore. Back in the old days, when we were teaching extreme programming immersions, we tried teaching top down, I think the first time, teach the planning and work our way into the technical practices, test-driven development, etc. And it was kind of a pain because people didn't know what they were trying to guess about in the planning. So we reversed that, and we were much more successful in our extreme programming immersions, starting developers out on day one with writing some code, iterating, getting small things done, working on a story, not knowing where the story came from, and then later in the week, introducing the planning cycle. It was easy once the people, let's say easier once people had an idea of what iterative engineering was all about. So, how's it going now? I do a lot of, when I teach a test-driven development class, I survey the people that are coming to my class just to find out where they are in their path. And, how much time do you spend? These are just numbers people make up of your given day coding. How much of your time is spent coding, adding value? How much time is spent testing? How much time is spent debugging? And you see there's some really high debug numbers here. And then you'll see one lonely person down there that doesn't do much debugging. That's usually the person who, was a self-starter on TDD. They had learned it somewhere else. They were brought into the company. They're having success with it. Now they want to spread the good word to other people. So this is a typical survey result on my survey. Here's another survey question. And Mike was talking about waiting for builds, and my tolerance for when I'm in TDD zone is much lower than Mike's. I know Mike was saying he doesn't want to go much more than 10 minutes. There's a lot of situations where 10 seconds might be a long time. If I'm waiting for a build, 10 seconds might be a long time. And when we're doing a test-driven development training class, and we have a 5-second build, which is usually way faster than anything anybody has in their production environments, we have a 5-second build, and they start to feel like to them that that's long. If it takes 7 seconds, it feels like it's long. But so here are the results from my informal survey of people that are about to take my class. Some people are spending up to a day waiting for a build. Many people are in the over a minute to, well, there's less than half the people have less than a minute wait. And that's going to be a problem if you want to stay focused. And fast feedback is about staying focused. And like Mike said, interruptibility. I know how irritable I get on some tasks where I do have some tasks still that can't be interrupted, or that when they're interrupted, it does send me way back. We'll talk about that another time. But so here are, people are waiting, and waiting is this thing you can do it. Sometimes your production build okay, but while you're working, inventing something, you want to keep this cycle time low. And I ask people, how do they test their code? And well, they go through debug logs. I wish I would have had one of those back in 1979. We look at printed output, inspect printed output. We go we deploy our code and go see if it works. I do this on my website sometimes. And there are single stepping through the debugger, right? Oh yeah, all these things. Oh yeah, and if Quora question, how often do you use a debugger? And here's a person who answered, well, I use it every time I code. Otherwise, how would I know that my code is doing what it's supposed to do? Well, there's another way, by the way. All these tools, right? Oh, those big logic analyzers now are a little dongle hanging off your computer. So the tools have gotten much more advanced than the ones I was using back in the old days. But congratulations. Yeah, here goes the fireworks. You are using state-of-the-art 1979 development practices, something I call, well, I'd call it if I could click that, debug later programming. Oh yeah, but now don't run off and put this on your resume, okay? Let's work on test-driven. Let's put that on your resume, not debug later programming. John Gall, if you haven't read this book, it's a really good book. Your program will have bugs and they will surprise you when you find them. So here is the guys from the commit strip enjoying their party. They fixed, 1,293 bugs. Oh, and here comes a bug spoiling the party. You're going to put down the champagne. One of the lead developers picks up his samurai sword and hacks the bug. Engineers a solution to the defect. And now they're ready to relax. Oh, good. We finally got the last one. And of course, they are surrounded. And some of these bugs are very confident that they're never going to be found. They're smirking and, well, you never know which one's going to strike next. Where did these bugs come from? Oh, yeah, it was somebody else that did it for sure. Are you sure? Can we take some responsibility here? Well, for starters, let's start managing the bugs. Well, actually, I'd rather not manage the bugs. I'd like to prevent them. And, I like to consider that test-driven is a way to prevent bugs. So I don't need one of these state-of-the-art bug categorization processes. I'd rather just not have any. Now, it's a tall order to get to, but it's something that we should strive for at any rate. And then you'll hear in the news about glitches. And this word glitch really bothers me because, when you see glitch in something, it's like, oh, well, we couldn't possibly understand the cause for that glitch. Okay, well, I'd like to consider that, there's a problem and we need to admit the problem. So all you developers, stand up with me, okay? Stand up with me, raise your right hand, and repeat after me. I am a programmer and I write bugs. I can't hear you, but if you were to tweet that, okay, here's the, you could tweet that to, what is it, #TDDconf and hashtag I write bugs. Okay, love to see you guys admitting that there's a problem, because if you can admit there's a problem, then there's something we can do about it. And when we do development in a big step, okay, and go start testing it. By the way, we test in small steps, very interesting, and we debug in small steps. You have no problem with small steps once you're debugging, and there's no other way at that point. What do you find? You find defects, just not all of them. And so it's not our fault, right? Yeah, well, actually, it is our fault we put them there. So here is debug later programming taken apart. Okay, if you're a physicist, I apologize for using physics here, but it kind of looks like a physics timing diagram. And so you make a mistake, and then time goes by, and someone discovers the mistake. And now we've got to find the root cause. Now, the bug isn't a bug until the root cause is found, right? And then once you find it, once there's a bug's been discovered, now you go find the cause. When did you put that bug in there? Oh, you didn't. Someone else did. Old code like Mike was talking about, unintended consequences. The new features all worked. It's only the old features that are broken now. And now you finally track down that problem. How long does it take to find a bug? Yeah, well, could take quite a long time. The fix might be really easy. And now what happens when you fix it? Well, lots of times other bugs come to the funeral when you fix it, and you're going to have to find them the hard way too. So yeah, I'd rather do something different. And Dr. Edsger Dijkstra has a suggestion for us. If you want to be more effective programmers, you should discover you shouldn't waste your time debugging. You should not introduce bugs to start with. Now, Dr. Dijkstra had in mind ideas of formalized proofs and such. I think the path to this in our day and age is small steps and test-driven development. I used to think it was test-driven development by itself, but small steps are also part of it. That was kind of something that really evolved. Practicing TDD helps you see, like Mike was saying, other things about the way to work. And the small steps are one of the really powerful things. You get yourself in trouble with it by taking too big of a step, go back and find the smaller step that works. I remember Kent saying, well, you'll come to peace with a step size. And if you ever make one too big, there are small steps that will help you get your code working. Right? And that's a non-elegant paraphrasing of what Kent was saying. But back to this marriage of XP and Scrum. So what is XP? Well, it's as an engineer, it focuses on engineering practices, and they're characterized by cranking the volume up, turning the volume up. Ken said to 10, but now after Spinal Tap, we have to crank them up to 11. And there's different practices here. Here in the core of extreme programming are the practices around test-driven development and other technical practices. I'm not going to take you through those, but test-driven development, as people in our conference know, some of you might be new to it, write a test, watch it fail, make it pass, refactor, repeat. You change your mind, clean your code up. And, what are we trying to get help with? Are we going to have these pressure drownings underneath the waterfall here? Are we going to be trapped down there? Well, maybe less. All right, we're hoping to be spending less time down there. What if your world could turn from the pressure of those dates being crushed at the bottom of the waterfall, those integration points and such, into a fast-moving stream? All right, so let's go look at how that might work. So, by the way, you're human. You're going to continue to make mistakes. And before I started test-driven development, I actually thought I was good at programming. And well, no, you actually don't. You're not that good at it. Every time you try to do something programming, you make mistakes. If I were to count them, I could count them per minute, not per hour, not other ways. My typing skills aren't great because I told you the story about the typing already, but I make mistakes frequently. Now with test-driven, the mistake is right in my face, right? So I can't ignore it. And when did I put the problem in? I just put it in within the last few minutes so I can find the cause. So if I get a new test to pass and I break 7 other tests, I can't celebrate that new test. I got to back out the change for the one new test that passed and preserve the prior 7, because existing features, like Mike was saying, are way more valuable than your new feature. I know some of my clients work in telecom and radio communications, and if they add some new capability that no one has or uses yet, and then break, how some call processing feature works, that's not a good thing. Let me just say. Now, finding the problem and fixing it could be quite easy now, and you got this tight feedback loop. And so here we are, our fast-moving stream. It's not all the tests and then all the development. It's cycles, small steps. That picture Mike drew of the walk, it looked like that walk we took, Mike, when we were working in Shenzhen that night, and we went out to play pool, right? That walk is how you get between those 2 points, all right? Small steps, firm footing each step of the way. And then when I'm working with new people to test driven, they say, well, I already know what I'm doing. I've got 10 years experience. And sometimes I wonder if we're getting the same experience year after year. Are we doing that improvement? Are we seeing that the way we're working, there's something else we can do? I know I spent 20 years of my career. Well, I did learn stuff throughout the career, but I didn't change how I programmed over those 20 years, not in any great extent. I wrote code and then tried to figure out what was wrong with it. Yeah, I'm already an expert beginner. Yeah, okay. So now I wonder, is your team doing test-driven development? Do you create unit tests? You can write tests after, but it's nowhere near as much fun as writing them as you go. And I forget what Mike called it, but there is that feedback loop, right? What was it? The rhythm, Mike? Is that what you're talking about? The rhythm of reward, right? If we're getting regular rewards, that's better than a big reward having to wait too long for it. So you get lots of wins. Every time you sit down, you get some wins. Now, you got to have unit tests. So if you can't figure out test-driven, at least start writing some automated tests. And there's different kinds of tests. You might have seen this testing pyramid. As you go up the pyramid, the bottom of the pyramid is about solid bricks of software doing what you, the programmer, think they're supposed to do. By the way, you're probably wrong about what they're supposed to do. You're going to change your mind over time, but these bricks are defined by their tests. They might do other things, but your tests say what they do. They might not say what they don't do, but that'd be nice as well. Now, the middle of the pyramid is supposed to say whether or not features work. Okay, so some teams will say, well, we should, if we're interested in delivering features that work to our customers, we should just focus on the middle of the pyramid. In the top is all manually tested. And here there's the base for here is wider because we're going to have more unit tests and other kinds of tests. And I'm going to tell you why that's important. So if you chose to just do manual tests or tests in the middle of the pyramid, and you're testing, let's just say, a subsystem that's been integrated where there's 3 interacting objects that each have 10 states or complexity 10. And so if we test them together, how many possibilities are there to thoroughly test this small subsystem? If you do the math, there's 1,000 tests. 1,000 tests for something that simple? No, let's not bother. Now let's draw a different picture. Okay, let's draw the picture of what if we unit tested each of those individual pieces? Well, now we're talking about 30 tests. Now that sounds practical. 1,000 sounds pretty impractical, but 30 sounds practical. And some integration tests to make sure that our things fit together properly. Hopefully some number smaller than 997, right? So that we're ahead of the game by thoroughly testing at the unit level and then testing, with more thought at the higher levels. Now, the higher level tests are important because, well, this code compiles and it links. There's some use cases that might have a problem. We're misusing some of the interfaces. I don't know, maybe that's a global variable access. It wasn't supposed to be accessed that way. At any rate, manual test is prevalent in people doing embedded systems. And a problem with that is, if you're iterating and doing development in all kinds of places, if you're relying on manual test, after the first iteration, after the second iteration, you must retest the first. After the third iteration, you must retest the first 2, and you can see where this is going. All right, we have an unsustainable growth, and I was being very kind. I made it linear, even though it's probably, as Mike called it, an NP problem. So it's probably a lot worse than this, but I'm just a nice guy. So, or play one on TV anyway. So we've got a gap, the untested code gap. And guess what's hiding in the untested code gap? Oh, yes, those brush fires waiting for lightning and are going to take off. So we have to automate tests. All right. Now, TDD is a challenge. It's hard to learn, but it's fun. All right. And so you will find all that, the cadence of rewards. You'll find it's fun. I ask people before my training classes to tell me what they like about development and what they don't like. And when we look through those, we play I suggest that some of the things that you don't like, you'll get to do less of those, and you'll get to do more of the things you do like. That kind of sounds like a win to me, at any rate. Now, technical excellence is more than just passing tests. And some of our earlier clients in teaching test-driven development back 20 years ago didn't really understand the refactoring side. And refactoring is really very critical. And I've been misquoting Martin for a long time on this, so I'm not going to stop now. Any fool can write code that the compiler understands. Now, comment here. Martin must not work with C and C++ because they are really hard to keep the compiler happy, at any rate. But it takes real skill to write code other programmers understand. All right. So what are those? So we need to write code. And I've heard Mike say this a lot too. You write code once, you read it over and over and over again. That's when you spend all your time on it. So we want to write code to be optimized for people reading it. And the skills that you need, first, you got to be able to detect when something's wrong. A good nose for bad code. Martin Fowler talks about those in the book. Then you got to have an idea of what would be better. And then you got to work your way towards it. And you don't do it in one big step, like Mike's trip to get another Diet Coke is not a straight line to Ashley's, Ashley's Diner or whatever it was, Ashley's store. You take a series of steps to get there, transformations, right? So these are 3 distinct skills to learn, which, of course, all this stuff makes our industry really interesting. And maybe you think code quality doesn't really matter and your bosses don't care, but they do care because bad code slows you down, and bad code could have some other problems, like the lawyers are coming. We have the problem of a litigious society, and when software is at fault, like it was for Toyota in the unintended acceleration, lots of money gets paid out. There is blood in the water coming for us. If we don't get our act in order, and if we don't get our act together, we're going to be led around with a nose ring. Okay. What we want to do is get our act in order, work deliberately, work with high quality. So why doesn't your team use TDD refactoring practices of extreme programming? We're different. You're different. I mentioned to you, I work with people in embedded systems, and they're different. They can't use TDD refactoring. Their hardware is prototype, and it's doesn't look so great. And by the way, their memory in their computers are limited, like Homer Simpson's tiny brain, or this watch, or this pacemaker. But sometimes the memories are big, like in a GPS system or an iPhone or a Large Hadron Detector, and they couldn't possibly use the practices of extreme programming because we've got constraints and timing. For instance, like a pacemaker, if it doesn't meet its deadline, that's not all that's going to be dead. We can't use extreme programming for something like embedded or test-driven development for embedded because I/O is specialized. You can't, I/O like a washing machine or a floor cleaning robot or a pacemaker or a car or a Large Hadron Detector. Oh yeah, we have special problems. These are expensive prototypes. And they have bugs too. And it's not our fault. Are you sure? Maybe it is our fault. Specialized UIs. Okay, enough of that. Yes, you are different. Now, I don't just work in embedded. I've worked in other areas too. And the insurance people have insisted that they're different. Embedded is special. Automotive is special. health insurance software is special, web services software is special, design automation is special, financial software is special. You are special. I don't want to break it to you, but it just doesn't matter. Well, it matters that you're special. But as far as applying ideas that work in one area to other areas is kind of what this world is about. Okay, so you can find you may be special, but a lot of the same problems exist in your work as they do in these other areas. So just remembering that there's a problem here getting shippable software. So what's in your way? Dysfunctions and inadequacies. Okay, so there's Agile's 3 halves, right? Iterative planning, respect for people, technical excellence. Me as an engineer, I focus on this technical excellence side, but it is essential to help people along with it, and to realize that we can't just start changing the cadence of how we work without changing how we work. Changing the cadence of delivery without changing how we work. Oftentimes we're given dates and things in planning as motivational. You've heard of stretch goals and motivational scheduling and things like this. Now, remember I told you I tried to avoid computers. And if you think about how developers work, pretty much there's almost nothing you'd rather be doing than solving these problems. You're solving them while you're sleeping, when you're playing. People will pay me for this? Well, yeah, of course. Now, learning, like Mike said, test-driven development does take some time. So the road to success does take some time. And no shortcuts. Okay, you're going to have to go learn the hard way. Although I'm going to be a little bit more optimistic here. I felt like I got value on the path almost immediately. Start to shorten your cycle time with the test. Start to think about how you're going to test something. If you've got an idea, so Mike mentioned you can't have a walking skeleton if you have an existing problem, existing product developed, you have an existing code base, an existing product. Although when you're adding a new feature, you might be able to have like a walking skeleton, try one path through that. This is how the test-driven developer is going to start to think about these things, is how do I start to make incremental progress? And we can develop a habit of solving problems in this incremental way. And that's about all I got to say. So thanks so much. To myself the whole time. All right, let's see. I feel like I'm by myself.
Thank you very much, James.
It
was an amazing talk. We all enjoyed, I think. I jumped in because Alex, I don't know where is Alex. I think he will join shortly. And we already have our next speaker prepared. Alex is here. Okay.
Sorry. James, this is awesome. Thank you so much. By the way, again, the comments are flying off the handle. And please, if you have time, if you can jump in and maybe review. There's a lot of discussion, a lot of questions. One common theme that I'm seeing is a lot of people are saying, I wish my manager is here to watch this. And I want to just mention that back in February, when we were celebrating 20 years of the Agile Manifesto anniversary, I invited James to give a talk at my company. It was well attended. There was a lot of managers, executives, and to this day, people keep referring back to your talk, James. It's very illuminating, very enlightening, and it really removes a lot of these sort of ambiguities, like, oh, why are we doing this, and blah, blah, blah. So, I think you packed so much into this talk, and I'm sure there will be ripple effects. We will, I think, now build a bigger community. We will be networking, and we will be reviewing your recorded talk. We will be referring back to it. I think, like, I'm slated to do the closing talk, and I almost feel like canceling it because I think you totally preempted everything I wanted to say.
No,
Because
of course not.
Debug later, getting quick feedback and all that. These are, I mean, timeless advices. And if you read through the comment section here, you will see that you're really hitting the spot, hitting the nerve. People love what you're talking about. You and GPA just like kicked it out of the gate. And now is the time for younger talents standing on your shoulders, if you don't mind. Yours and GPA's shoulder, and of course, Ken Beck, Ron Jeffries, and all the other. I call you guys big wigs, even though I'm not wearing a wig. So
the hair is getting pretty gray.
I know. It's I don't know what happened. So, would you like to add anything else? Because we can go through a lot of questions. It will take a lot of time, so maybe we can do it offline, if you don't mind.
I'll go through the questions. I don't know that I can respond to all, but
Sure.
Will there be any follow-up forms to have a conversation with people?
Yes, I'm planning to add whoever's interested to our Discord channel. We have a growing community on Discord. All we need to do is just send you the link. You can jump in and join, and we'll create a storm, right? So, in the interest of time, and I apologize to the audience, we had some technical difficulties. I'd like to introduce you to our colleague, Dave Aronson, and he can introduce our next speaker.
Thanks
James,
very much, Alex.
Thank you again. Thank you so much.
I had a
awesome.
great time.
Great time.
Yeah, sorry about my technical difficulties.
No
I'm going to get
problem,
good
no
at this technology one of these days.
No problem. Your talk was brilliant, and it was really worth the wait. So enjoy your weekend, and we'll talk later.
Thank you.
Cheers. Thank you. Hey, Dave, over to you.
Okay. Thank you, Alex. Our next speaker works as a developer advocate at Postman, where she advocates best practices for Postman, the larger API community, and an API-first approach to software development. She was previously a software consultant at ThoughtWorks, where she trained employees and worked on projects applying XP. Remember, that's extreme programming. Some of our previous speakers talked about that. The practices from that, like TDD, CI and CD, and pair programming. So now, presenting from India, let's hear from Meenakshi Dhanani.
Hello. Hi.
Hi. I'll
Am I?
leave it to you.
Okay. So
You're live.
like the sound, everything's all right.
Mm-hmm. Over to you.
Yeah. I just want to delay my presentation. I'm so nervous right now. Okay. Let me share my screen. I don't think my screen is visible yet. And it is now. Okay. So yes. So I'm going to be talking about which is better to code by contract, TDD, or API first. Don't get angry at me. I know everybody here is like TDD fans, which of course I am too. So yes, but let's find out what that is. But before I talk about, I know, thank you, Dave, for the introduction. I think you just said everything that I had asked you to about me. But so yeah, I'm a developer advocate at Postman. My day job usually is building a lot of content, contributing to open source Postman, helping out the community, and looking for opportunities such as conferences so that I can meet more people and talk about APIs and tooling and specifications, and get feedback on Postman, the product, which is an API platform, so that I can take it back to the engineering teams and just improve the overall developer experience. Besides, I'm currently learning Spanish, so I want to say to myself, buena suerte, which means good luck to me, especially because I'm following after GPO and James, so it's a lot of responsibility. So just bear with me. So what are we going to cover today or tonight? It's actually night in India, but yeah, I hope I don't sleep through my talk. But yes, so we're going to talk about firstly, we have to actually compare what is better to code by contract. We'll talk about what exactly coding by contract means, how to apply code by contract in while developing software. Overview of test-driven development, though I will not spend as much time on it, considering the previous talks have very well explained a lot of details about that. Next, we'll go on to understanding what the API-first approach to software development is, and then we will talk about TDD versus API-first. Cake by contract. This isn't a typo. So it's a little over 10 p.m. here in India, and it's post dinner. So dessert is definitely on my mind. And with that, I'm just going to use the analogy of a cake to talk about code, which isn't very new. I think a lot of us compare like cooking with coding. So that's my analogy. So, but that doesn't seem like a cake. What that is so there's this show that I watch a lot. It's called Fabulous Cakes. It comes on TLC. And on one of the episodes, there was this client which comes to like the Sweet Design Cakes. It's a bakery. And he wants to get a cake for his sister's birthday party. So the initial interaction of the team is they ask questions about his sister, Tiffany, and about her personality, what she likes. So this is the requirement gathering phase where they actually decide upon like what creature or what is the design of the cake that they want to build for Tiffany's birthday, and how big or like how many people are attending the party. So it's all to understand how the user, in this case, the client is like the people who are going to eat the cake, Tiffany mainly, like she's the main stakeholder here. And based on a lot of those things, they come up with this blueprint of the cake, which is a dragon cake. And let me tell you, I'm going to send the link to this episode in the chat. It's a 3 feet long cake. This is one of my favorite shows to watch. So this blueprint is essentially the contract that they agree upon. Like this is how the cake is going to be. And now in order to come up with the cake, they need to build the cake, right? So the development phase is where they actually build the cake. Since it's a 3 feet long cake, they break it up into different parts. So let's say the base of the dragon's body, and then the middle part is its hands, and the top, its face. So all of these are separate parts, and each one of the team members, they have divided this into each part. Each part has its own dimensions or how wide each part should be. Because if they don't decide on something like that, like if they don't decide on the specification of each of these parts, it's going to be very difficult to integrate the cake, and the cake is going to fall Tiffany doesn't want a fallen dragon. Tiffany wants the dragon to stand and the dragon to be tasty. And I sound hungry. But so we spoke about the blueprint, the first one. That's the contract that they've agreed upon with Tiffany's brother, and this is what's going to be delivered. And each of these pieces that make up the dragon, I am thinking in software terms as like the architecture of the entire app. So let's say each of these pieces is like a microservice, and they have to come together to build the entire app. And each of these pieces, if they don't have their own contracts, then it's very difficult for the entire piece, like the entire app, to come together. So I want to focus mainly on, like we always call like contract as like the external, like the main blueprint, that's the contract, right? But I also want to focus upon the contract that these internal pieces have, so that you can build the entire cake, or you can build the entire dragon. And yes, so all of those pieces come together. The Sweet Design Cakes team does a very good job. And finally, they're able to build the dragon, which is building the entire app for us. Like if it's a web app that I'm building on, a lot of microservices come together probably, and then we build the entire app. Just the difference between the cake and probably our code is that this one is just left to right. So it starts with the dragon and you actually make the cake. But then, okay, so the comments are distracting me. But yeah, but in case of software development, it will be iterative, it will be a cycle. I think probably the cake is in a cycle, like all of the stuff there is perishable. So, but in case of software, like we will build the software applications, we'll again go back, add features, fix stuff, and then this process is going to continue. But we spoke about contracts. So I've picked up the easiest definition that I could find on the internet about what a contract is. And it's a decision or arrangement between groups of people. So if the Sweet Design Cake team hadn't decided on a contract, it would be very difficult to collaborate on the different parts of the cake to have the cake stand and to be able to integrate that, which is why we should code by contract. So the first thing that happened throughout the process is that when you think from the perspective of just the contract and not exactly about the implementation, like not fretting about the implementation in advance, not over-engineering the way that we're used to, just thinking about what needs to be built, that is what happens when you try to have the contract first in place, and then you go about building the how you're supposed to build the thing. Good design, because now I'm thinking of all the stakeholders that are involved while building the contract. Even while building each of those pieces, right? The client of like the bottom piece is probably the top piece. So similarly, the client for say an order management service is maybe a billing service or a customer service. So I need to keep in mind all of these stakeholders. Stakeholders can be people, they can be different services, or they can be libraries that are going to use my code. So I need to account for them as well. And when I'm doing that, the design is actually from the perspective of the user or how the person would use, which greatly improves the design. Better collaboration, the team was able to break the cake up into different layers, different pieces, and each one of them independently could do their work. They can collaborate. I think the contract was not set in stone. So for example, let's say the bottom piece actually becomes way larger than it's supposed to be. They can have a communication about how they want to do the top pieces, and then they want to build the cake. But it's possible that's because each of them have agreed to follow like a certain contract and the way that it needs to be built. Predictable integration. Now that the contract is in place, all of them know that what piece is going to come on top of each other. So it's going to be pretty easy to integrate the entire thing. How do I apply code by contract? So again, I tried to pick up a couple of words on the internet, which seemed like they do not have a definition. So I just want to use an umbrella term, essentially just to focus on practices that focus on the what part of it and not the how part of it. They focus on the API, the contract, the specification. so that you can abstract out the implementation. So test-driven development, TDD, that's one of the practices which focuses on the what. API-first development, something that we're going to talk about in detail in the upcoming slides. Behavior-driven development is essentially, I used BDD when I used this tool called Cucumber to write functional tests, where it uses this language called Gherkin, which allows you to specify the behavior. But that, again, is inspired by TDD and essentially for you to focus on the behavior and the specification rather than the implementation. Design by contract. This is something that I actually found out while researching for this particular talk. And it is a software correctness methodology. It has preconditions, postconditions. But basically, this is a term which is coined by Bertrand Meyer, and it's implemented in the Eiffel language. So the contracts are actually part of the language. Like TDD, we do it as a practice, but this, like the language has these preconditions, postconditions. It isn't as popular. It had a couple of things with it, but yeah, I just listed it because it was still part of like the entire umbrella of code by contract. So test-driven development. And I am a fan of Martin Fowler, Ken Beck, and I think every one of those course signatories, and that's why it's so much pressure just talking after James. But Martin Fowler, who's also the chief scientist of ThoughtWorks, apart from being an author for a lot of books, and I really follow his blog. But he describes test-driven development as a technique for building software that guides software development by writing tests. And it was actually coined by Kent Beck as part of extreme programming. So I want to draw your attention to specifically the first part of the definition, which says for building software that guides software development by writing tests. So writing tests is actually how you implement, how you do the TDD, but the main focus area is why we're doing it is to build software that guides software development. So, and why I'm drawing so much attention to this, and one of the reasons why I put this under the code by contract is because a lot of times TDD is just thought of as a technique to increase your code coverage, and maybe the focus goes more on tests rather than the word driven. And it's important because I feel as a programmer as well, just thinking in terms of small incremental steps, but also writing the first test makes me focus on not the implementation, but what exactly I want this class to do, what I want the method to do, and focus on what is the API that this class should have, what's the contract that should be exposed. So there's a lot of thought that goes into that. And the driven keyword is actually a keyword here, very important. But yes, but a lot of attention goes to just the test part of it. So yeah, I just wanted to call out how important it is that it guides software development, that you drive your code through it. How you do it is the red-green refactor cycle. So you write the failing test just enough to make it pass, and then once it passes, if there's code smells that you see via code, you refactor and that cycle goes on. How it's beneficial, again, not going into the depths of this because I think a lot of speakers before me covered it in really great detail and so much better. So incrementally, it helps you to incrementally build, like Jeepo said, take more smaller steps. So it allows me to not get into like the over-engineering mode, which allows me to build really big things like the cake, the 3-feet cake. They built it because they made like small parts working. So self-testing code, because there is no code without the test written for them. So those tests serve as documentation, and there's enough confidence in the code that we're writing. Better design, again, because it helps you to think about the interface that you're exposing first and then write implementation for it. Next up, API first development, and this is something that I want to spend a little more time on. So Kin Lane, he also goes by API evangelist, and he's the chief evangelist at Postman. He describes API-first development as a philosophy and a way of life that involves beginning every software capability as an API before you even begin developing a user interface or any other element. So each of the software components are first well-designed API interfaces, and those can be reused across many applications and systems. Now that I'm done reading his code, I want to just dive into how to do API first development, because I think a lot of awareness, at least in the attendees, is for TDD, which is great, but I just want to introduce API first and how it is different and similar, and also because that's the topic of the talk. So what I'm going to do is let me move over to Postman, because that's what I keep using in all my talks. So any of y'all watching can try this out and share feedback about, I'm going to paste this on the chat. Yes. My day job is to get feedback on Postman, so I am definitely going to use the conference to do that. But what we're looking at right now is a Postman public workspace. So you don't need an account, but you can just visit the link and you can check all of this out. It has a link to everything that I'm using. But besides that, what I want to get your attention to is, so under the API tab, right, I created this API called Cakes API. Okay, so why did I create the Cakes API first? So let's say I'm building some software which this is a web app, and it has like a gallery of all the cakes that the bakery has, and you'll be able to place order, buy a cake and all that. So I made a cake API for starters, and this is what you would do if you were to do typical a typical API first. So you would have the API first, you would define the API, and we're going to use a specific format, which is called as Open API, to define the REST API. It's a specification. Once we have the definition, once we define the API, there is a lot of tooling that's available. So you'll easily, at the click of a button, be able to create a mock server, free the other teams to work on stuff that they built on top of the API, create documentation, and people can start testing the contract of the API, like the testing folks can start doing that. Somebody who's supposed to build UI on top of it is free to at least start building UI, because a mock server will be generated out of it. But so coming to the definition of the API, so this uses the OpenAPI 3 format, and this is the definition of the API. So you can see there is like a get and post request, and we define each of like what will be returned. This is the schema. This is JSON schema that we're using inside here. It's an array. It returns a list of items, which is like each cake, because the get request returns cake. So what happens as a result of defining the API first is that emphasis is laid on what the API wants to expose. So if I am like, when I do the post request, I will have to take into account who is going to be using this service. Is the order management, like, will this API be used to also post to create an order? So then I need to be able to build this cake API in such a way that it accepts all of the details that are required to create an order for a cake. And there are a lot of questions that you have to answer while defining the API. So again, this is a focus on the specification of the contract that is exposed. At this point of time, we're not thinking about the implementation and how it will be built, but just from a user perspective of like, take into account all of the stakeholders and see how the API is going to be used. Once you lock on, not lock, you could do this incrementally, but once you have the specification set, once you have the API definition, then you can move on to actually developing code for it. So one great thing about using these specifications, so there's OpenAPI, Async API, and there are a couple of specifications, but OpenAPI is really popular for REST APIs. One benefit of doing that is you can just quickly generate a mock server. So I can just create a mock server out of the Cakes API, and I will be able to hit that API and expect like random example responses from the API that come up. There is a lot of tooling in the sense that you could also derive documentation from the API definition, and you could also start writing tests. So I'm actually going to go to the collection. So what I've done here is I have this collection that I did generate from the OpenAPI, and this has the entire API definition that I'm using. What I did is I made a fork of this collection. So it's possible to create a fork just like GitHub and actually have version control and even contribute and raise PRs against collection. But essentially, I'm just using the fork so that I can use each of these collections for different purposes. So I made a fork out of it. I created a collection which serves as the mock server. So this points to a base URL which is generated when the mock server is created. And this mock server is created based on the OpenAPI specification that we saw, the first thing that we defined. So anybody else who wants to start building on top of this is free to do that. And this mock server returns random responses based on the definition. So I said a string and I said a number, and that's what it returns. So yeah, I could modify the response, and based on like the status code that I expect, I could get that. But there is tooling in the sense there's a mock server that you could create at the click of a button. And there is also visualization that you could do in addition to writing some contract tests. Because now that we've locked the contract, the testing team can actually go ahead and start writing contract tests for the APIs. And when it's built, they can check and see whether it's validated or it's following the contract or no. So the schema is valid. Let me go back to the presentation. Yes. So what I wanted to do is we saw how to API first. Like you come up with the definition, you define the define the API, all of the parameters, all of the responses, and based on that you build. Like you capitalize on the extensive tooling that's available, and you use the mock server, or you start building the API. Once you have the definition locked, you know what you want to build, you know what the API is supposed to do, and that's how you do it. Now that we have taken a look at both the approaches to do certain things, let's just put them left and right, and let's just do a quick comparison. So what TDD allows us is when we have the tests in place already, we can get faster feedback. If we add something, we remove something, we change something, a test fails, the CI pipeline fails, we get faster feedback. API first is earlier validation because we're now getting all of the different stakeholders in one place. We're validating the contract. We're like, this is what it's going to do. If you want to try it out, you try it out with the mock server and you see whether it makes sense to how you're supposed to use the API. So we're getting earlier validation instead of like building it later and then figuring out what went wrong. Emphasis of interface over implementation. Both of these approaches are still under the big umbrella of focusing on the what part, focusing on the contract. So there is emphasis on the interface over the implementation. And API first also is like emphasis on the specification, which is all again, same terms. Easier onboarding. When we have, like I've been part of teams where we've done test-driven development for like really large code bases. And sometimes when I've joined a new project, it is extremely easy compared to if I had to read the code and figure out what it does. Just looking at the tests, because those tests serve as documentation. So it's faster onboarding because of that for a new person who joins the team. For APIs as well, when I joined Postman, at Postman we follow API first. So all of those microservices actually have specifications. So I just look at what a service does. I just see what all it exposes, and I know what the service is useful for. TDD, in addition, increases code quality, maintainability, because we've decided what we want to code for. There is the refactoring step, and we're building only enough as much as is required, which increases my confidence as a developer. In terms of API first, I said that when you have the mock server, like the testing team can go ahead, probably the UI person can start building the interface based on the mock server or the definition, and teams can work in parallel. There are no blockers, like nobody is waiting for each other to start work. And it fosters a product thinking. In that case, API is the product, because the kind of questions that you ask for the stakeholders is how they're going to use it, what parameters will they use, how will the service look, what will it expose. So it does foster product thinking and better design. I've spoken too much. But yes, so if we were in school and if you got to distinguish between API first and TDD, and if you put this there, you wouldn't get marks as much because there isn't a lot of difference. Like if you see each of these points, essentially, they're doing the same thing. It's just slightly different that probably I will have to have the API defined first. And when I'm actually going ahead to write the code, that's when I'll write the test first and then do the implementation, do the development. So if you look at it from a bird's eye view, both of these do not have as much difference. Both of them want us to focus on the interface, the specification, and what you build, and then come up with the implementation. So the topic, and as to why I chose this topic, was to talk about how different the two are. But having examined both of those approaches, they aren't as different. So the idea that I want to put forth and what I'm proposing is a mix of both of them, which is possible. Like we never have to choose between, let's say, I want to use only Python or I want to use only Java. We're able to take the good parts of each of those things and use it for anything that we like. So then each of these approaches have their own good parts, and they can be used together in tandem. Like I could, when I'm doing a service, we're coming up with an API, I could define the API first, create the mock server, like let teams do their job. And when the development team is actually writing code to build that API, that's when I can do TDD, and that's how I can write code. So essentially, it isn't a versus per se, but both of these approaches have their own good parts, and they can actually be used together. So in case you haven't been using API first, but you're using TDD, you might want to look at how to build using specifications and do that, because it just follows the same principle. And that's what I wanted to convey through this talk. So I'm there on YouTube. I'm actually watching all of the speakers. So in case there are any questions, I'd love to answer, or I'll just be there on the chat. And otherwise, thank you so much. It's been a pleasure just being part of like the speaker lineup. It's too big for me. So thank you. Am I alone?
Oh, thank you, Meenakshi. This is brilliant.
Thank you so much.
You had so many comments that I'm overwhelmed. I don't know how to summarize. But overall, I think the big debate is outside in, or top to bottom or bottom up. The testing pyramid and the speed of tests. So I'm just going to quickly throw my angle, and you tell me if you disagree. We are really seriously going into something called service virtualization, and we are using a platform called Mountebank, where you could simulate many dependencies on the network. And there are various advantages to doing that. One is speed, because all these simulated endpoints or APIs, or however you want to call them, are running in local host in memory. And so we could run those integration tests super fast, almost as fast as unit. And the second one is giving us the opportunity to simulate many, edge cases, oddball cases, pathological behavior. You can say, what if, all of a sudden we get back 500,000 responses and stuff like that. Mountebank allows us to do that, to simulate declaratively, so you don't need to write any code. It's all JSON. I don't know if you have ever looked into virtualization or simulating some of these endpoints.
Yeah, so at ThoughtWorks, actually, for one of our clients, we did use Mountebank. So it was a big banking client that we had to simulate a lot of scenarios for, and mocking. We use Mountebank for mocking, and not just to free up the other teams. Like that was one of the reasons, but also like from a testing perspective, there were so many scenarios which we were able to simulate through Mountebank. So I spoke about mock servers a bit. So the state at which like the Postman mock servers is as of now, I think, and the fact that I've used Mountebank before is one is that you won't be able to locally spin it up with Postman, but that's something that you can do with Mountebank. And the other is the state at which it's right now. If it's a quick thing, or if it's not too complex a scenario, that's something that Postman can help with at the moment. But if it's a really complex scenario, that's something that we're building towards, and that's part of the roadmap. So, yes.
Okay, Ken, and I'm sorry, maybe you mentioned that, but I'm trying to organize things. And then, Ken, Postman, can you hit the endpoint and record everything that happens and then replay in Postman?
So what you could do is so if you create the mock server, and if you share the link to the mock server, and whoever hits the mock server, there is a space where you can see all of the logs that happened. So what was the payload and all of that on the console, you can actually see what happened, but we may not be able to replay it, but you will be able to see a history of what all are the interactions with the mock server.
Mm-hmm. Yeah, because as you mentioned, some of the more hairier scenarios in Mountebank, we have to actually inject JavaScript.
Yes. So in fact, like for Mountebank, we had to write a separate microservice and have a lot of code, because it was so complex, the scenarios that we wanted to simulate. So at the moment, Postman can simulate like very simple scenarios, but it's something that we want the Postman mock server to be able to do, to be able to configure it for complex scenarios. And that's something that we're working on.
So David here asks, how do you test failure scenarios?
Okay. So in what context actually? Are we talking about the tests, like the API tests, like the contract tests that we do, or?
Well, let me give you an example. A lot of the companies I work on projects have this big question mark over, like, what happens when December 31st rolls over into January 1st, and they cannot test it because they don't have the environment set up. And so, we can simulate some failures. We can pretend as if the calendar, the turning of the clock, didn't work as we expected, so that we can, using that kind of simulation, we can now teach our code how to roll with the punches and what to do in case things don't happen the way we hope they would happen. Right?
Yeah. So testing for failed scenarios. So I'm not sure. One is like, I think in case of mock servers, again, we can test for. So what we could do is we can configure how a response should return, like based on the status code that I expect. So I wanted to return a certain failed response when I hit the mock server. That's possible as of now. And that's something that we can use to test fail scenarios, or even like when I'm building the UI, I need to get a 500 so that I can build for that and I can get that bit tested. So that's something that we're able to do through mock servers. And I'll share some resources on the YouTube
Great.
chat actually.
Thank you. And just quickly, Jeff says here, likes to write all mocks by hand. The reason we avoid the writing by hand, it's a bit overhead, right? And you have to maintain the code and all the other sound and dance. With declarative JSON, it's much less of an overhead. So I think we're running out of time.
Yes.
This is a fantastic talk. Thank you so much for joining the conference and for taking the time to prepare this brilliant talk and presentation. We learned a lot. I learned a lot. And now we have to move over, and I will basically give the reins over to Dave to announce our next speaker. Dave, can you jump in, please? Or are you available? Hey, all righty.
Sure. I just keep the camera off while I was not speaking because I was eating lunch. And those of you with access to the backstage cameras don't want to see me eating lunch, I don't think. So we are actually running a little bit ahead of schedule, but our next speaker is in the backstage studio. Give me a thumbs up if you're ready to roll. All right, I see 2 thumbs up. She's really, really ready to roll. Okay, our next speaker has experience in full stack programming, testing, requirements gathering, and conducting trainings in corporations, startups, and pro bono in various industries and countries. She also involves solving problems and writing meaningful code. Since 2019, she has been advocating quality among programmers, and this year she published a book on software quality that made it to the top of the technical bestsellers. When she's offline, she rides 2 wheels, walks her dog, or practices yoga. Presenting from Poland, let's welcome Ola Kunish.
Hello everyone. Good morning, good afternoon, good evening. In Poland, it's already 7 p.m. So thank you for having me, and thank you for allowing me talk this early, because in the middle of the night, it would be a challenge for me. So I hope you're ready for the presentation. Everyone today will show you the benefits of TDD, the benefits of tests, and I'm here today to discourage you. I'm just kidding. I'm here to show you some challenges and how to like break the rules and do it anyway. I need my presentation. I think I already shared the screen. So, oh, thank you very much. You could probably see my slides now. So I will be talking about the reasons why you can just stop using TDD at some point, especially when you start, why you might think it's hard, why you might not like it from the very first moment, and how to overcome that. So test-driven development is a great technique. For me, it was life-changing as a programmer. It changes the way you test. Your tests don't show the implementation anymore. They show the requirements. So you think about writing tests in a different way. They change the way you code, because your code becomes more readable. It's simpler. We've been talking about simple steps, baby steps today. And it's really important in software development to have these baby steps, to introduce little, just very simple changes, because otherwise we can get lost. So TDD helps with that as well. And it changes the way you think about programming, about like software development overall, because you come back to requirements, especially for programmers. Working with requirements, it's not so simple. We usually have Jira tasks or other system to track our work, and we very rarely speak to clients. We just rely on what project managers or product owners tell us. we don't very often work with requirements, and TDD forces you to work with these requirements, so it changes the way you think. But it's not so so easy. There are some disadvantages from the very first moment you try to master that skill. There is a couple of but, and this is my topic for today. As Dave said, my name is Ola Kunish. I'm a programmer. I've been working in IT for last 14 years, and I see myself as test evangelist. I published a book. It's in Polish, but maybe I will translate that and publish that internationally. Follow me on Twitter if you want to be the first person to know about that. Let's start with the first but, with the difficulty number one, which is the fact that TDD is hard to start, actually. You know the process is simple. There is only 3 steps, right? You need to write red test, you need to write some implementation, not too much, and you need to refactor both. You can commit in the middle, but the base is just these 3 steps. Simple, right? But simple doesn't mean it's easy. You know what to do. You know the process. You have the recipe, and it was created by people who've written thousands of code, and it was tested all around the world. But you sit at your keyboard, and you actually have no idea where to start. You have the steps, but what does it mean to write test? Which test should I write? What should I test first? And then I have this red test. It it's not satisfied. The test is red. What should I do next? What does it mean, the simplest possible solution? And then when I have some code and I want to do refactoring, should I refactor big chunk already, or should I refactor only this one test and this piece of code that I've just written? It's not so intuitive, so it can be tricky from the very first moment. And red tests is a topic that is very uncomfortable for programmers. This is what I see from my experience, from my students that I teach TDD, that programmers don't really write tests to check anything. We write tests to prove that we are right. So the tests are the perfect, we can show the perfect report, and we say, I'm right. I delivered the feature that works, right? And if I see red tests, it means that something broke, something's broken, something doesn't compile. We don't really feel comfortable with the red color, and TDD helps with that as well. Because if you start writing red tests from the scratch, and you get used to this red report, then at some point you realize that the tests that are always green are not trustful. You cannot tell if they are green because they work, or they are green because they don't test anything, because there is assert true, for example, in the middle. So you start thinking about red test as your help and not your enemy, because this is what you feel from the very first moment. You write the red test and you don't feel comfortable with that. It's uneasy to be comfortable with the red test from the first moment you try. So these red tests, they are hard at the beginning, damn hard, but then you realize that they are the best help that you can have. And I'm sorry for very experienced devs, sorry folks, but the more experience you have, the more difficult it is. If you are a senior, you have some habits. You probably write implementation, you write production code before tests, or you've never written tests at all. And starting with tests is it doesn't feel right. It sounds like something is broken. You don't know if it's a good idea or not. And for juniors, it's a little bit simpler because they just don't feel like they are sure about anything. So they get used to like learning new things, and mastering new skills is just natural for them. And for seniors, this can feel a little bit uncomfortable. So I'm sorry, folks, but this is how it looks from the very first moment. And my advice here, not only for the experienced devs, but also from for everyone who is just starting with TDD, starting mastering this tool, is to watch live coding. And why live coding and not reading a book or watching some tutorial? Because during live coding, there are some mistakes. There are some decision-making processes. There is there are some thoughts that pop up, and you can use them. You can follow these steps that the person who is conducting live coding doing, or you can disagree. You can say, no, it doesn't make sense. It's against the rules. I won't follow that. But at least you have something to start with. You have the initial thesis, and then you go from this point, and you say, all right, so this is how it looks. This is which test should I write first, or this is the piece of implementation that I need at this point. And live coding is especially valuable if you can ask questions, for example. If you can ask why this step now? Why you write this test and not test something else? So this can help you go through this very beginning with something that feels a little bit more familiar. As I said, you can totally disagree with the speaker, with the person who is conducting live coding, but at least you know where to start. It doesn't feel so mysterious. So it's not only the recipe, but it's something more like useful for you after the live coding. Let's move to difficulty number 2, which is that it's hard to follow the process. TDD process is fairly simple. The steps are very small. They are so small that it's tempting to skip them at some point. So let's maybe not write tests for that. Instead, write some extra implementation, because I already know what to write here, or I already know how to implement the whole feature. So why bother and write this baby steps if I can already fix the whole thing? So it's counterintuitive at sometimes, because like I said, you already know the solution. So let's skip this test. Let's jump right into the implementation. Let's skip the refactoring, because I already have the plan for the big chunk refactoring. So let's leave it here. And the more you do it, the more lost you are, the less TDD there is. You feel that there is a place for this small adjustment, and you skip the test, then you skip the refactoring, then you make this satisfying test, not only satisfying test, but writing the whole feature, and then you're lost. And it happens, usually it happens with the kata game of life. If you've ever practiced TDD, this is the one that is actually the hardest from them all, because people go these baby steps at the beginning, and then they want to write the whole thing at one and commit it at once. So it shows that they don't know what they are doing, or they haven't mastered the process yet. Because if you start doing these small adjustments, TDD is disappearing. It's something TDD-ish. So you have test first maybe approach. Maybe you have something from TDD, but it's not TDD anymore. And the problem here is that you don't see the benefits from TDD, from using TDD from the very first moment. Remember when you started programming years ago? For me, it was Logo, which is the general purpose programming language that is famous from this little turtle that moves around. And it took me minutes to move the turtle. Of course, it was not some meaningful feature, but just writing code and seeing the benefits of that, which is turtle moving around, was minutes. So it was a very short period from mastering the skill. I mean, it was not mastered yet, but at least I started, and then I saw the benefits immediately. So I had this dopamine shot, and it was very helpful to follow the process, to learn other things, to master the process of programming. Then, if you ever try to master machine learning, you have the script differentiating cats from dogs, and it takes you around an hour or two to have this ready and working. And with TDD, it doesn't happen. You won't see benefits in 2 hours or minutes. You need days, sometimes weeks, and then you have these aha moments, and you see the code which is becoming better. You see the tests that are more readable. You see the whole process being very useful for you and useful for your production code. But it won't happen overnight. And that's why many people just don't feel like TDD is like any beneficial for them, because they give up too early before seeing any benefits. So my advice here is just to follow the process without any judging. And I think this judgment is the hardest part, because in IT, we love judging. We have this idea that anything is either black or white, and there is no grayscale. So either I love it or I hate it. It's a piece of trash. It's dead, and I won't use it in my project. It happens to us with the tools, with the techniques, with libraries, frameworks, anything, new skills that we master, new knowledge. If we don't see the benefits right away, it's just piece of trash. So this part about lack of judging is the hardest part, actually, of this mastering of TDD, because being humble and following the process without judging is especially hard for seniors. But from my experience, most of folks in IT have problem with being humble, with staying humble on the way, and with just accepting things the way they are. And it doesn't mean that we should like take it all for granted and not ask any questions, but just have this time to build our own opinion before we start like being part of the discussion, because otherwise we just share some other people's ideas, and we don't really know what we are talking about. So if we try one kata, or we just solve one problem using TDD, and we start talking about disadvantages, it means that we are not really prepared for that kind of discussion. We need to like make our hands dirty with code using TDD, and then we can start judging. Because if we judge too early, probably before we see any benefits, it will be a big no for most of us. It happens all the time. I hear people all the time saying that TDD is trash because they don't really have this skill mastered, and they just gave up on the way. And I will talk about that in our last difficulty, which is that TDD is hard to level up. It's hard to start, but it's even harder when you move on to real life projects and you want to apply that in your production code. So katas are simple. Katas are the very simple business problems that you can solve mastering TDD. You can search for Coding Dojo or Kata in the internet. There is plenty of them. I recommend starting with the simplest possible ones, because TDD is hard enough to start with. But if you want to implement TDD already in your project, you might feel a little bit overwhelmed, because if you don't practice enough with these kata problems, with this simple business that doesn't change, then it will be very hard for you to level up. Because in real projects, we have tools changing, we have requirements changing all the time, clients that change their minds, we have processes that are unstable or they change, we have people that change or people who disagree with us. There was a question about the team. Should we force people to use TDD? I would never recommend forcing anyone to anything, because if people don't feel like something is good for them, they won't like put their heart in that, and they won't succeed at the end. So this will be just, you know, the waste of their time. So in this real projects, you have this changing environment, and if you master the skill, you should focus on this skill and this skill only. Because otherwise, if you move to the real life projects too early, you have so many dimensions that if it doesn't work, you don't really know if it didn't work because TDD is a piece of crap, or because the requirements were unstable, or the whole process was unstable. And even if you write the production code first, it won't work anyway. So it's very hard to judge, or very hard to measure that, because you didn't spend enough time in your sandbox, because in this sandbox you probably hit the wall. But because it's sandbox, you can overcome these challenges, you can work around and somehow find a solution. But if you jump right into the real battlefield of everyday work in the real project, you can get overwhelmed, you can get lost, and you can feel that it doesn't help you. It's just a waste of time, and it's not true. Because I've used TDD in like academia, but also in production code, in everyday projects, and it worked just fine. But before that, I spent a lot of time practicing that, so I had only one dimension of like mastering the skill. So hold your horses. I know it's not easy, especially if you're experienced and you already know what to do, and you know how to fix that bug, or you know how to deliver this feature. And you want to skip some tests or skip some baby steps in TDD process. But if you do that, if you do these small adjustments to your process, if you jump straight into the project before mastering the TDD on simple solutions, then it might be hard for you to believe that there are these benefits of TDD, because you will get lost and overwhelmed on the way. So practice, 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 and then move to real life problems. And this is what I always recommend my students, because one of the assignments in my online courses is practicing TDD. And most of the students fall in love with the process immediately. So they want to use it every day with their production code. But usually I recommend them 2 or more katas to practice with, to practice this alone, maybe to record something, because if you record and you tell the story about what's your decision-making process, it helps you to learn yourself and to help you to grow. Then practice, for example, pair programming, invite someone to share the process, to learn together. Then organize Coding Dojo, which is the practice of like working as a group. So we can always organize that in your project. or in your group of friends, or whatever. It doesn't matter what's involved in that. It matters that these are the people who can write some code and can write tests. You can invite testers as well. I said at the beginning that programmers don't write tests to check anything, but to prove that they are right. Testers have different opinions. They have different point of view, so they can introduce some new knowledge to the process. So so it would be useful for the Coding Dojo, for example, to invite testers, so you can have not only like per programming but per testing as a group. So it's very enlightening for programmers to have this discussion with testers, because this is the different points of view, and it works very well for both sides. So to sum up, test-driven development is a great technique. It can be life-changing. It changes the way you code, the way you write tests, the way you think about features. But it's hard to start. You can feel overwhelmed. You might not know what to do. It's hard to follow the process. Even though it's simple, it's not easy. It's hard to level up. So even if you practice with katas at the beginning, then it can be hard at some point to jump into real life problems, to real life projects. So yeah, it can be overwhelming and very hard to level up. So what do you need here before you start, or if you are at the beginning of mastering the skill of TDD process, is watching live coding. So you see the decision-making process, so you can hopefully ask some questions, so you can like feel how it should go, get the feeling of the right process. Follow the process without judging. And this is very important, that you shouldn't be judging TDD before you master that, because otherwise it's just that it's like with many other skills or tools, we judge too early. And we should be judging only when we know what we are talking about. And practice, 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 because it will help you master the skill. And I believe you can do it. And I believe it's time for questions. So Dave, if you have any good questions from the audience, I believe we have some couple of minutes to answer them. Or Alex.
Hi, Ola.
Thank you.
Thank you very much. This is amazing because, it's like drinking from a fire hose. While you were talking, we had millions of questions just streaming through, and it's just like punch in the face. It's very hard for me to, coming from all over the place, but everybody 100% agrees with everything you said here. I haven't seen anyone say, no, all is wrong. No, it's super easy. It's not. We've all, you've been doing it forever. I've been doing it forever. As James and GPaw said, after 20 years, I'm still learning. I used to think I'm a good programmer, but now I realize I'm not so good. So I better be careful how I proceed. A lot of these comments are basically on what you were talking about: practice, practice, practice. Almost
Exactly.
gain muscle memory, right? Katas, same as in martial arts. Katas, you repeat same. And I do that. I can tell you from my personal experience, I do a lot of things over and over and over, and for years. The same thing. And it's like, I'm a guitar player, so it's like if you're learning an instrument, you have to do your scales. It's not like, okay, I learn my scales, never again. Every day, a little bit of, you go through your kata, you go through your regular motions, and it becomes part of your muscle memory or inbuilt habit.
Yeah.
And like you said, that helps appease the anxieties. Because like you rightly put, this is a brilliant presentation, and I'm going to go back and rewatch it a few times. You tend to skip if you're not ingrained, right? You're like, oh, I'm going to actually, I know what I'm going to do next, so why should I bother failing the test, blah, blah, blah. So I really don't. I'm sorry. Maybe Dave can jump in and with the specific questions. But everybody was like bang on. Everybody's in full agreement, and it's our challenge, like you said, not to coerce anyone or not to try and corner somebody, but to really build this enthusiasm. In my personal experience, I teach TDD dojos. That's my part of my job. So we have dojos and we have graduation path. I don't want to create student teacher codependency. That's ugly. Everybody should graduate and become better than me. If you're not better than me, then I suck as a teacher. And we are doing a lot of mob programming. And in a mob, we rotate up for about 4 minutes each. The navigator and the intelligent input device. After 4 minutes, the alarm rings. You get up, and when we were back in the office, and that creates this energy. And then I feel like everybody in the room picks up this confidence and this energy. So I would recommend to people to try mob programming.
Yeah, and it's very helpful also when you sit in the audience and you see everything as obvious, and then you sit at the keyboard and you feel like your thinking slows down and you don't have all these brilliant ideas that you used to have sitting in the audience. So this is also a very interesting experience. Yeah, I recommend that as well.
And also, you may not have access to a real software engineering master such as James and Jeepaul and Kent Beck, but watch their videos. Watch Kent Beck's videos. See how often he messes up and all that. You realize what's going on. Anyway, we are out of time. I thank you so much. This was absolutely fantastic. I'm going to hand over to Dave and announce the next speaker.
Thank you very much.
Mr. Announcer, you're on mute. We can't hear you.
There we go.
All right.
Yes, you'd think I'd learn that by now. Anyway, we are back almost on schedule. So rather than take a 5-minute break as the schedule indicates, I think we're going to take a 4-minute break, and then I'll be back to announce our next speaker. I'm sure many of us are quite ready for a little break. And we're back. Let me just make sure. Yes, I am unmuted. Good. So our next speaker is a full stack developer at the Adecco Group, or Adecco, or however they pronounce it. She is a frequent conference speaker with appearances coming up soon at Kansas City Developers Conference, Code.Talk, Serverless Architecture Conference, and many, many more. So presenting from Berlin, let's have Olena Borzenko.
Hi.
Hi.
You pronounced my name correctly. Thanks. Yeah, mission accomplished. Yes, thanks a lot for having me today. I'm really happy to be part of the first TDD International Conference. And today's talk, TDD Misconceptions, is going to be based on basically my experience and my misconceptions, my misunderstanding I've had on the real life projects. And I want to show what basically made me reconsider my attitude regarding the TDD. And once again, my name is Olena Borzenko, and you can find me on Twitter. If you have any questions or comments, please feel free, don't hesitate to reach out. I will be happy to chat. So also, I want to say a couple of words actually about my experience and who I am. I originally from Ukraine, and currently, as was already mentioned, I live in Berlin, in Germany. I started my career in IT in Ukraine in a company called Alex. It was a service company. And I'm mentioning this because exactly in this company, I had an opportunity to work on many, many different projects, on startup projects, or enterprise applications, and much more. And basically, there I learned a lot about TDD, BDD, and other practices and approaches. After that, when I moved to Berlin, I started to work in Dus Express, which is a German beverages delivery service. And after this, I started my journey at the Adecco Group. It's for now it's been like only 2 weeks, so I actually also knew this company. And not wasting time. So what is actually the deal with TDD? Why I want to talk about this? I cannot say that I use TDD on every single project I've had in my experience, but there were a couple of them. And I cannot say that every experience I've had was a successful, completely the opposite. At some point in my career, I was actually against TDD, and I was genuinely afraid because many times when I was working with kind of TDD, it was overcomplicated and very, very time consuming. So I want to share what exactly was happening and what kind of lessons I've learned from this experience. So everything basically started to go in a wrong way from the very, very beginning. I was working as a junior developer, and I don't know, maybe 6 months of my career, and I was working on a project, and we were supposed to use TDD. And I was told that TDD is when you write all the tests before implementing the business logic. Not saying too much, that was kind of my reaction. I was not able to understand why and how is it possible. And I was not alone in this reaction. We had a team where it was like a couple of junior developers and maybe 1 or 2 senior people. And everyone of my level had exactly the same reaction. So why not? Why we were scared? Why we didn't want to use this? Besides natural reasons that we had not enough understanding and we were not experienced enough, there were a bit more. The first of all, it was a small startup project where we were rushing and we had very, very tight deadlines. So sometimes customers were giving us requirements and user stories, and on the next day, mood changed, and then they want something else. So in my hand, when I was thinking like how it's going to work, if you would start writing tests before, and all tests, not only single tests, but all tests before trying to implement any business logic, we will be just stuck in the endless loop of rewriting tests over and over again. Without tests, of course, we were also rewriting code because the customers were changing their opinions and requirements, but at least we were able to move slowly forward, trying to deliver at least small pieces of functionality, and at least it was working somehow. And again, confusion in the team was growing with every second after this announcement about TDD. Especially the reason for this was that not only we had no understanding of those processes and different practices and how to work with this, we also not very experienced with the test itself, whether it's integration, functional, or unit tests. Of course, some of us, we learned what is this. We had a bit of practice and we tried a couple of times to write tests, but to really write useful tests, it does require, after all, some time and some investment to learn how to do this. And
Olena, I've been getting some messages that says you do have some slides for this. You need to share your screen so I can add them to the stream. Okay.
Oh, I'm sorry. Yes, of course I do. I'm perfectly showing the presentation all this time. So
there we go. Okay.
Yes.
But you know what, Olena, you're doing fine without slides. Perfectly follow.
Yeah, I'm perfectly going on the slides, and I'm absolutely convinced that everything's good. I just have two screens, and the browser was hidden. So thanks a lot for.
I was enjoying your talk. I don't think you need slides, basically.
Thanks a lot. Thanks a lot. I guess I will just keep from this point. It's basically the first slide when there is some text on it. Before it was just some pictures. Yes. So. We had no idea actually how to write tests properly as well. And the last thing, besides lack of knowledge and experience, we also were not able to understand why someone would use TDD and why someone would develop the project in this way. Because now, with experience, I do understand. Given a bit of spoiler, that of course it's helping you to improve your design. It's maybe time consuming from the beginning, but after all, in the long term, it can save you a lot of time. It can help you to keep your code clean and have a documentation basically in your code. But back then, I had absolutely no vision and not a single reason in my head why I should consider it. The next time when I met TDD, I made it in the form of found the bug, fix it, write a test to prove it was fixed. It was quite an interesting statement of TDD, and the basically first thought in my head when I heard about this, that if no one found the bug, it means that it does not exist at your code at all, because we had no test, no consistent test, I would say, in the code. We were not covering the business logic. And it means that the only way to actually find a defect if it was missed during the development process is if the customer or the users will go and write in support that something doesn't work. So did it work? Of course, it's not. But it was helping at some point that at least we were sure that we would not have the same defects again. But it did not work in the long term, and especially from the quality perspective of the product itself. The code coverage was very inconsistent. When we were writing complicated features, and well, not we, there was senior developers, they were writing complicated features, they were covering them with tests. So we junior developers would not break them. But all the other features, especially the small ones, because again, we were working on the project with the deadlines, where we're supposed to deliver as fast as possible. If there is a way to avoid writing tests, we were doing this. So we give feature and testing. Okay, we have a defect. We wrote one test to cover this defect, and we are moving forward. In the end, when new developers were joining the team, they were very confused because it was very inconsistent. Where's the rest of the tests? What is happening? And so on and so on. So also those tests which we were writing for our defects were usually written to ensure code quality. if our implementation is correct. Because most of the times we had quite good user descriptions, user story descriptions, and most of the problems were the wrong exception message or something, the null was accepted and not validated and not needed, and so on, so on. So that kind of details, which actually implementation details. So we were writing tests to be sure that our code implemented correctly and not that actually business logic works. So as a result, no guarantee that application in our product was actually working as it should work. And the last one, before I actually learned about TDD more and actually started to understand how to use it, the last drop in the ocean was 100% coverage. And I'm sure that everyone who is watching and who is practicing TDD would say, but that's correct. That's how it should be. When you're using TDD, you have 100% code coverage ideally, because you first write tests and only then you implement your functionality. The problem in this case was that we were not writing tests first. We were writing code, and then we were trying to cover it with tests. This case was also could be. There is another kind of common misconception about TDD that everything needs unit tests. So with this 100% code coverage, besides this number, we were also trying to cover everything with unit tests. So as a result, we had very interesting tests. They were most of the times useless, and they were written just to ensure that the line was green during the code coverage inspection, and it was not actually helpful, and completely the opposite actually. So something went wrong again on the project, and besides that, it was really, really hard and complicated to keep that coverage because we had a lot of functionality and product was quite big and complicated. We had a lot of mocks. We were mocking everything, and we were trying to write tests for every single combination of what can happen with those mocks. It became obvious that not everything needs to be tested only when we realized how much time and energy we invest in this process. But the main problem, that the critical defects were still there. Every time when we were given features, when we got given code for testing, we were surprised from the amount of how many defects we were receiving back, how many defects were reported. And of course, again, the same thing. Tests were about code quality, about the actual implementation, and it was quite rarely that test was actually representing what is happening in the code. So, as I mentioned before, I would say it again because it was really, really a huge deal. The development time was significantly increased because of this. If you spent on your feature, for example, 1 day, you needed 2 more days to actually cover all this with tests and ensure that everything, the 100% code coverage. The same situation was if you have changes in requirements and you go and fix the all functionality, again, you have to spend twice as much time to go and fix all the tests which are related to this feature. And it's not because something really, really changed, not always because something really changed in behavior, in how your code works. Sometimes you just move things around and all the tests failed. Luckily, during this period, I had an opportunity to work within the same customer in the same company, but I had another project and another approach. It was also test first, but it was not test-driven development, it was behavior-driven development. We were using BDD. So when we were receiving a story we need to implement, the description of the story was written as a scenarios. So we were taking those scenarios and we were implementing tests exactly the same as a description. And of course, after this, we were doing one test is a scenario, then we were implementing code, and basically red-green refactor process going in cycles. So the main difference between those 2 projects, as I said already before, we were first writing tests. And not all the tests, only one. As I said already, one scenario, we were taking the scenario and we were writing tests. The difference was that because everything was clear and we had those scenarios was very structured, and it was easy to write tests first. Sometimes I, as a developer, was not writing any tests. I was sharing this responsibility with some other developers or maybe QA guys. They were taking the user story, they were writing tests, and they were giving them to me when they were failing, and I was implementing the business logic. So I was writing only code which is actually needed. I was not trying to write code before any test. I was not trying to make everything work from the very beginning and then like fix defects. I had the red tests, I wrote code, done. And also the difference was when we had 100% code coverage rule, we were writing, as I already mentioned, all the different possible combinations of mocks. We were writing a lot of tests which were completely useless just to cover all the lines. In this case, we were writing only the tests which were representing scenarios in the user stories. And basically, that was, I would say, the great moment that when I finally realized, and well, this cute squirrel added only for dramatic effect, when I finally realized that everything what I knew before about TDD was not actually wrong. It was, all the statements were kind of correct. The problem was that when we were trying to adopt TDD process, like practice, try to use it, we were trying to use separate statements. So like either 100% code coverage or maybe write tests first. And the problem was that we needed to use all this together and just follow the step by step without jumping back and forth. So my conclusions, basically based on my experience, what I did after going through this process, that the first of all, the TDDs, when you write a single test, we already know this. We watch it fail, and only after that we implement the code. I knew this already. I knew this from the very, very beginning when I was just trying to understand what is TDD. But it was really hard to understand how does it work in practice. And when I had this opportunity to work with BDD, it just showed me how could it work, because we were practicing pair programming as well. So one person is writing test and I'm implementing the business logic, I'm implementing the code. We were trying to move with like step by step without taking too much work in the meantime. So one test and implementation, one test and implementation. And that was that gave me understanding and actually practice. We were practicing quite a lot with this approach. How does it actually works? And I realized that this approach is actually, it sounds a bit scary. Like, how could you write tests before? Like you don't know anything. How could it work? What could be a design? But on the practice, when you try it over and over again, it's becoming very, very easy, because you're starting to think like in your test, you are also putting a bit of like design basis for the better design, basically. And that was the second item I wanted to say, that it's not forcing you to create a best design ever, or like perfect code, perfect test, perfect whatever. It just assists you in better software design, and it's helping you to have those like small modules and small pieces, small logical pieces of your code, because otherwise you cannot write your tests ahead. And again, that was something I knew and something we all read about in books, and there is tons of articles about this. But that was exactly what I saw when I was writing those tests after I already tried BDD, and then I was working on the projects when we actually were using TDD, and that was successful projects. And I had a couple of projects when we had really, really positive experience. And that when I realized, when I was looking at my tests, that they actually implicitly like forced me to like design my code in a much better way, in a much more like clear understanding, and better implementation afterwards. And easier to refactor and hand over your code. This was the first moment when I realized that it's very, very easy to hand over your code. Again, when I had this changing moment when I was working with BDD, and I saw we were using Cucumber framework, and we had those tests written as a scenarios, like given when then, and so on. And I was working, the project was 20 years old with quite a lot of legacy parts and legacies. Quite a lot of legacy parts, basically. But even then, it was quite easy for me when I had a defect, or maybe I needed to change something. It was quite easy for me to go find the test or find the piece of code and actually read what it's doing. And especially if I was able to find the test which is responsible for this on another feature, it was very easy to understand what is happening there, because it was really written like a documentation. And of course, with TDD, it's like we don't usually use Cucumber framework for TDD approach. But I'm just saying that it was the first moment when I saw that tests actually can be readable and can be a documentation in your code. So after this, I already knew how it's supposed to be, and it was much, much easier to then work with TDD approach. And the refactoring, of course, easier, as I mentioned before, because the design is kind of improving, and we implicitly forced to write better code, it's becoming much easier to refactor and make any changes in your code. And just a few more things. If all the previous statements I said, they were basically, I knew them, but I understood actually how to properly use them from my own experience. There are a couple more which I just really like, and I want to mention as a part of this presentation. The first thing is TDD is very time consuming. And as I said, when I had no understanding of what TDD is, I had exactly the same opinion and the same vision. For me, it was very complicated, very hard. Like, you have to put your mind, like, to first write tests, you have to think of all the possible things, you have to think how to design it, you have to write it. And for me, it was like, it's just too complicated. Can I just sit and write code immediately? Like, it will be much easier. Like, why should I suffer and do this thing? Like, I was not able to understand it. I thought that it will just, with time, make it more and more harder as the code will grow, the code base will grow. And this is basically not true, because the big companies like Microsoft and IBM, they were adopting the TDD practice, and they proved that it's actually not true. And pre-release defects density of the 4 products decreased between 40 and 90%. This is just a quote I really liked, when they basically from their experience, they finding they actually really proved in a real life, on a real project, that TDD can improve and can make the product better, the implementation phase. And the next thing also, red, green, and always refactor. This is also another misconception and misunderstanding I hear quite often. And this is not true. Especially if you are working on a project which is like quite big, and as I said before, I was working sometimes on with the legacy systems. There already, most of the functionality are there, and sometimes for me implementing a feature was like a plain Lego. I was just taking bricks and just putting them together, calling the function which is already there, or calling some methods and saving some data, getting some data. It was just the way how I basically implement the step-by-step feature which is described. And there was no refactor was needed at this moment. Sometimes I was just writing from the first time feature and it was done. It was working. No refactor was applied. And I also like this quote, which is related to this misconception that perfect is the enemy of good. It's also it's not only about old and big projects or like stable projects where you don't really need to refactor something. It's also about that sometimes you are getting lost and going in this like state when you're trying to make it perfect, and you do this again and again and refactoring and moving, and then you're just wasting a lot of times, when in the end, 1 week after, you will come and look in this code and you will have exactly the same opinion as before, that this code is ugly and you want to rewrite it again. So it doesn't really worth it to just refactor for refactoring and just do this to make it perfect, because perfect software not exist, and better to do something good, which is works, easy to understand, which is high quality without defects. And then if you want to refactor, maybe do this later when you really have time and mood for this. And the other thing, a simple code need no tests. This is also like I hear quite often, and even not about TDD or like it's just if you just have unit tests, if you just have like integration tests, I hear it quite often that's just simple function, that's just simple story. Like I don't need tests. This is obvious that it works. Like there is no way that it would not work, and that's not true, because our tests are also the specification on what the code is actually should do, and the implementation is how the problem is solved itself. So regardless if it's small, if it's simple, if it's obvious it works or not, it's good to have tests, especially when some new developer might join, or maybe you would forget 1 year after what you did and you would start making changes. It doesn't matter how simple it is, you can just forget about something and you will break some functionality. So with tests, you will have documentation and specification of actually what is going on in there, and you will have kind of insurance that, okay, it's gonna work, and if something will break, the test will show me that something's actually wrong. And at this point, I would say thanks everyone for attention, and this is the end of my presentation. I hope you enjoy, and if you have any questions, as already mentioned, feel free to write me, and that's all. Maybe if there is any comments or questions from the audience, I'll be happy.
Okay, well, thank you so much. Again, it was such a challenge for me to follow your presentation and to follow the incredible stream of comments that you generated. We all love this. This is amazing. And thank you. I personally really appreciate how you took us through your personal journey. Many of us all of us have been there, and we really rush to forget and to repress all these years of but you really painted the picture, and I'm sure it's going to come very handy to people who are still struggling, to grappling with TDD. Few streams of comments here that I just want to point at. One is there's been a little bit of debate on coverage, and as you rightly pointed out, perfect is the enemy of good. Shooting for 100% is suicidal on most missions, I think. Mm-hmm. And so now people are saying, okay, so what is the reasonable percentage to shoot for? And maybe you can give us your comfort zone.
Yeah, as a actually just a bit of comment about also was said previously during the previous session. Because I'm also learning, like those things doesn't mean that I know everything about this. Every day there is a new thing, a new aspects of TDD and other practices I'm learning. So I cannot say that there is a comfort or the number I'm following. I'm trying not to follow any percentage things. 100% it's kind of ideal world, which is kind of not exist. What I'm trying to do, I'm trying to usually ensure that all the scenarios are basically covered. So it could be sometimes the implementation itself, the amount of code you need much more than how the actual scenario look like. The scenario could be simple when you read it, but the implementation you need to do for this quite big. So you write one scenario, it covers quite a lot of the code, but some of the lines, you would not test getters and setters, right? This is absolutely unnecessary. So I'm just trying to make sure that all the code is clear, like easy to understand and easy to follow, like what is happening there. I don't really have numbers because, as I said, that I'm trying not to follow any numbers.
And I think that's brilliant, and that's the best advice. I just want to quickly, because we have some time for more questions, point back at what G-Paul was talking about. He calls it GAC, or geek at keyboard. And he also calls something the lump of coding fallacy, which means that from the people observing from the outside, we are banging on keyboard and everybody thinks we are writing code all the time, but we're not. As I mentioned in my opening talk, I realized at one point that I'm barely spending 10% of my time on the job being productive. The rest is I'm debugging, I'm messing with the environment, I'm manually configuring, and I'm running. Everything is manual, and which is really bizarre when you think about it, because we sell our ability to automate things, and yet we don't automate our own workflow. Mm-hmm. And I was like, what's up with that? Why don't we, first of all, and then discovering TDD, I realized, oh, this is actually automating my workflow. Because if I'm doing TDD, I never run the app, I never configure anything, I never debug anything, I never enter any test data. All I'm doing is I'm making a diff and I'm watching my tests either fail or pass, right? Yeah. So there's a huge time saver. In my case, it was 90%, up to 90%. And so you rightly pointed that TDD does not slow us down. Actually, the misconception and speeding us up. Another thing I want to ask here, and I don't know, maybe you're not, somebody in the comments mentioned mutation testing. And I'm doing a lot of mutation testing, and I really prefer that to any coverage metric. To me, coverage metric doesn't mean anything. But I don't know if you ever did any mutation testing, if you have any comments on that.
Yeah, unfortunately, I was not working with this, but it sounds very interesting. I definitely should check it out, mutation testing.
Yeah. If you stay on my finishing talk, I will do a bit of mutation testing. So maybe you can
of course, I would definitely join. It's very interesting.
What I'm talking about, it's a very useful tool. I use it all the time. Some people think it, but anyway, there's so many questions. I really don't know what to pick.
That's right. Hey, you also said before that about slowing down, the test will slow us down and so on. I've heard so many times from customers, especially, like there was many times I was working on projects when customers were approving many things, especially when the customers are technical. This is even like harder story. So when they really kind of understand what is happening on the project from the tech side, and they want to approve like what kind of framework, language, and practice and whatever you're using, the customers many times when we were trying to use TDD, they were like, no, it's gonna slow us down, and everything's not gonna work, because they want to see result immediately, because they're paying money and they think that if they're paying, they want to get something as soon as possible. And that's always the problem, because they don't understand sometimes that in the longer term, it will start saving them money, and not like they really don't want to make this trade-off of just waiting. No one likes waiting. So for me, it was always the case. I was trying to, actually a couple of times I really convinced that this can be a better approach. Yeah.
I'm more in favor of demonstrating that we're saving time right now, not in the long run. Long run is hypothetical. It's Yagni, and most people don't buy it. They say, yeah, okay, I know you're giving me hypotheticals, I'm not buying it. But I can show you right now, how is it saving time and saving you money right now, this minute. And Uncle Bob said that if you're a real pro and you are developing software, somebody approaches your desk, you should be able, and asks what are you working on, you should be able to show it right now. Not saying, oh, give me a few hours, I have to tie some loose ends, and then I can show what I'm working on. So I think it's more beneficial, in my experience, to demonstrate how we're saving time right now.
That's definitely, yes. If it's possible to show, that's definitely, you have to be highly skilled. Of course, I have no doubt you can show it amazingly, and everyone.
Olena, you can tell your technical bosses, you can say, well, how come we have time for debugging? And debugging is an open-ended session, right? And sometimes I've seen people debug for days and just cannot move forward.
Debugging is not
only that. As James said, suddenly when we're going into debugging, we are prepared for tiny little steps and we can take our time, and nobody has a problem with that. But if we're going to do it beforehand, everybody's like, no, we don't have time for that. So it's a tricky skill to develop itself. But your presentation really helps. I'm pretty sure a lot of people will benefit from it. It's going to be recorded and people can watch it back. And I thank you so much. This was amazing. I'm now going to switch over to Dave, our MC, our showbiz guy, and enjoy the rest of the day. Thank you, Olena, very much.
Thank you for having me again.
Thank you.
Okay, once again, we have enough time for a nice little break. Our next speaker is slated to start at 20 minutes after the hour, at least for those of you in a time zone that's an exact integer number of hours off of mine, where it is now 12 minutes after the hour. So if I can cue up the jingle. Anybody? Let me... There we go. Leave in about 8 minutes. Okay, it is now 20 after the hour and time to resume the conference. Our next speaker is a telecommunications engineer with over 16 years of experience developing electronics products, both the hardware and the software. 6 years ago, he discovered TDD, which led him to XP, Agile, and Craftsmanship. It was a revealing moment that changed his professional and personal life. As an eternal learner, he occasionally helps teams and organizations improve their development processes as part of his long road to software craftsmanship. So now from Alicante, Spain, let's welcome Fran Clement.
Thank you very much, Dave, for your presentation. And hello to everyone. It's an honor for me to be here together with such brilliant people that I admire so much. I humbly hope that I can contribute with my little grain of sand to this wonderful event. During the majority of my career, I barely managed to survive. Things drastically changed when I discovered, nearly by accident, TDD 6 years ago, as Dave has pointed out, when I found that awesome book from one of our speakers, the Master James Greening. If I will have to give any simple recommendation and end this presentation just right now, will be to go for it. So let's begin. What's an embedded system? It's a computer system with a dedicated function inside a larger and customized electronic system. It's composed of one or several microcontrollers, which are the brain of the system, as well as peripherals divided in sensors which sense the environment and actuators which respond to the environment in an autonomous manner or upon external commands. So an embedded system is made of hardware, firmware, and hopefully some piece of software. But what is really hardware? We all will agree that the yellow shaded area is hardware. But what about the microcontroller itself? It's a piece of silicon, isn't it? Well, from the point of view of embedded code, the special function registers are hardware, as long as each microcontroller unit has its own implementation. Special function registers are a simple way of having the hardware mapped into a set of memory addresses, in which each single bit has a special meaning. They are the gateway interface to the real world, the world that our embedded system senses and tries to actuate accordingly. And that point is extremely important for us, as long as from the point of view of the embedded code, absolutely nothing happens in the real world if it doesn't change a special function register. So we have now clearly delimited where the embedded code ends and where the hardware begins. But that embedded code, is it firmware or is it software? I love the following definition from James Greening in Clean Architecture book from Robert Cecil Martin. He states that the software is this thing that can have a long, useful life, but firmware will become obsolete as hardware evolves. He also states that the firmware is firmware because of what it depends on and how hard it is to change those dependencies. When some dependencies are hard to change, we will indicate it by using this icon in this presentation. Another piece of gold from James is when he explained that non-embedded developers are also write firmware whenever they spread libraries or platform dependencies throughout their business logic code. This is a great advice. If you are an embedded developer, be aware that the special function registers are not the only thing that you can end up being firmly tied to. Your operative system, real-time, or vendor libraries, for example, are also excellent candidates to end firmly depending on. Let's move now to the three well-known and desirable steps of software development that we know as make it work, make it right, and make it fast. During the make it work phase, we are focused in understanding how to solve the problem, not about engineering the code right. In the make it right phase, we are supposed to be engineering and crafting the code right to make it easy to understand, maintain, and evolve. These two differentiated steps should exist because barely no human being, and therefore no software developer, is able to do both things properly at once. And the last step is make it fast. That means that fulfill the system requirements, if any. Let me now introduce or opening a section in this talk that I named Fallacies and Mantras. And here comes the very first and the biggest lie ever. And it states that the fact that you are not going to obtain the right solution at your first iteration. It's impossible both in the embedded and non-embedded world. But if there's something that is a major difference between embedded and non-embedded world, in my opinion, is that making a simple thing to work is orders of magnitude harder in the embedded world. And this is because we have to manage lots of little low-level details at once in order to accomplish a simple task. Additionally, there are other problems because the underlying running hardware platform is scarce, non-existent, or even faulty. In my opinion, starting from our academic studies, continued by naively following most of the examples and application notes coming from the manufacturers themselves, and finally perpetuated by the lack of really senior embedded developers out there, some of us, like me, have faced the situation illustrated in this slide, which is known as the main God. This is an example of how it looks like in code. It can clearly see how the single main module is in charge of everything, including interacting with the hardware. That has a direct consequence. The code is firmly tied to the specific running microcontroller unit, and additionally to the target cross-compiler. The reason for that, the last sentence, is because the cross-compiler offers some kind of aids in order to safely interact with the special function registers. So why are not we going to naively use them, right? Moreover, the code knows exactly which integrated circuits are being used in the current solution, that is, the current hardware or printed circuit board. So it's firmly tied to use these components in order to perform its higher level duties. And the hard-to-change dependencies do not end here. The code is also fully aware about how the microcontroller unit is connected to the integrated circuits in the current PCB layout. For these reasons, we can safely affirm that this code is firmware. It's firmly tied both to the running microcontroller unit and to the underlying hardware platform. If we attend to design principles like SOLID, for example, we can say that it violates all of them. But I am quite sure, however, that many of you will have been lucky enough not to have had to deal with the main God like I had to do, because you have used layers. Specifically, what we commonly know as the drivers IC layer. In this layer, we put all the modules aimed to command specific IC peripherals accordingly to their datasheets. In order to do that, the EC driver modules use the special function registers to drive or communicate with the chip, which again makes these drivers strongly dependent on the running microcontroller unit. That means that it's not possible to execute them by another microcontroller, or in other words, they are not portable. This is a clear violation of dependency inversion principle because a higher level entity, like the driver in this case, depends on low level details like are the running microcontroller unit. And what about the code that uses the drivers layer, that is the application layer? Well, it knows which integrated circuits are currently used, as long as it's directly calling its public APIs. So that supposes a clear violation of the dependency inversion principle. The application is supposed to be a higher level entity, but it depends on low level details. And also a clear violation of the open close principle, because we are not open to substitute, for example, an IC for another one that extends functionalities without having to change the application code itself. As a resume, we have improved a little bit the cohesivity of our solution if we compare with the main God, but the underlying problems are still there. Some of the problems of the main God are common to embedded and non-embedded world. Like, for example, we have no long-life software in charge of capturing domain or business logic. Nothing is modular or reusable. It's impossible to test any part in isolation. We are forced to perform manual testing and debugging, which leads to an expensive and hardly repeatable process. Additionally, due to being embedded, the main goal, this code is only to be able to be compiled by the selected cross compiler. It's only executable under a specific microcontroller unit, and it runs only under a specific hardware platform or PCB assembly. As a result, expensive and scarce powering, input generation, and output measurement equipment is needed. All these problems materialized in a huge bottleneck for our development process, known as the hardware bottleneck. And this is how the hardware bottleneck usually materializes in an embedded software developer workplace. And hardware bottleneck presents lots of issues. When we are forced to debug the code directly on the hardware, we are exposed not only to the bugs coming from the software or the code, but also to the errors coming from the hardware itself. If we try new code directly on the hardware and it doesn't work as expected, where is the problem located? Is it hardware? Is it firmware? Is it both? This situation commonly leads to a lack of trust, preventing us from behaving like a real embedded team. The aforementioned problems tend to lead to the sensation of apotheosis when we finally manage to bring up the system. We tell to ourselves, yeah, it was complicated, but we finally made it work, without realizing that the vast majority of this complication was not essential, was accidental. Which are the reasons that have led us to this discouraging situation? In my opinion, in the embedded world, and also non-embedded, but we have more problems in the embedded world, and I call it traps. Let's go to the first one. This trap is typical for the embedded world. I call it the vendor's trap. Basically, what this says is that the vendor IDEs, frameworks, utilities, tool chains, libraries must be low-level details, properly hidden from your application. Or in other words, the vendor is not your partner. At the end, the running processor should be a low-level detail. Another trap that is more well spread in the embedded world is the compliance mindset trap. First, let me define the quality in 4 quadrants. One axis represents what is visible to the client. The other axis represents the kind of value, positive or negative, both to the client and to the organization. On the left side, we have 2 quadrants visible to the client, which conform what is known as external quality. While providing new functionality and features has a positive value, delivering products with defects or bugs has a negative impact. Most of us became interested in testing to prevent or mitigate the number of bugs delivered to our clients. In the better world, we have some epic and historical failures in our mind. Like, for example, the 42nd flight of the Ariane 5 originated due to an overflow when converting a 64-bit floating point number to a 16-bit signal integer. Or the Dirac-25 linear accelerator, which killed at least 6 patients after receiving 100 times overdoses due to race conditions in its deficient software. Or the 89 deaths originated by the unintended acceleration of some Toyota models, as James has already pointed out, due to an overflow problem on the real-time operating system stack. To prevent these situations, safety quality standards are considered the crown jewel of preventing bugs inside the embedded world. Most of their recommendations are followed consciously or unconsciously by the vast majority of embedded developers. For 6.15.08 standard, dynamic testing is considered the primary functional validation technique. For these reasons, and accordingly to each safety integrity level, it points a clear focus on code coverage. 100% code coverage is highly recommended, which means somehow mandatory, for those systems with the highest safety integrity levels. Let me make a little introduction to a powerful technique that is still not required, as far as I know, in any safety standard, and it's called mutation testing. It's an automated fault injection, a technique aimed to find counterexamples to this conjecture. Our test suite is comprehensive because it has 100% code coverage. So it is aimed to automatically measure the quality of our test, or also known as our self-checking specifications. Here you can see a code example from the kata we developed during my embedding embedded systems course, a temperature controller. You can see that it reads the temperature on line 19, and it compares to a configured threshold. Depending on the situation, sends a temperature control action to certain actuator. As you can see on line 21 and 22, lines 21 and 22 are not exercised by the test suite, so they are not covered. The 20 mutants of these two lines pass the tests, which is known as they are alive. What it means is that our test suite is not comprehensive or semantic stable, as long as these two lines could be completely removed and the test suites will not notice it at all. So even if a 90% code coverage could look like a great number, it isn't. And now I am starting another section of in the presentation that is, I call it fallacies and mantras. One of the fallacies that I have from time to time is that code coverage is an useless metric. And sometimes it adopts other forms, like, for example, we have 100% code coverage and we are still having defects, so we can give up on that metric. And that's wrong. We can strongly affirm that any part of the code that has not been executed by the test suite is for sure out of our control. Code coverage metrics helps us to locate and identify these zones. The only valid target for this metric, even being difficult to reach, is 100%. Obviously, if we follow TDD, 100% code coverage is taken for granted. And another way to say it is that 100% code coverage is nothing less than a precondition to have a comprehensive suite of tests. Having this in mind, why does a functional safety standard allow any value below 100%, at least for the lower safety integrity level systems? Not only that, but also why does it open the possibility to accept code coverage below 100% if an appropriate explanation is given, even for the highest level safety critical systems? The only reason I can imagine is to somehow be permissive to accommodate certain test later approaches inabilities. Let's see another example. Now we have 100% code coverage, but there are still 3 mutants alive. The mutants on line 20 and 24 are symmetric. We can go to the alive mutant in line 20. What is this mutant whispering to us? As you can see, what it has done, it has changed this greater for the greater or equal, and our test suite is passing. So what it really is saying is we have not specified which is the expected behavior of our code for the equality. If we add this corner case, in that case you can see that we have 2 tests, one for each of the symmetric cases, we kill the mutants. What it means that we have improved the semantic stability of our tests. So let's see now. Let's take a look to an empirical study of the application of mutation testing in a safety critical system coming from the industry. It's applied to a 60,000 lines of code of C code, which has obviously 100% full code coverage. They pick when the mutation testing was run, it gave to them 27,000 survivor mutants, more than 27,000. And they pick a sample of 200 live mutants, and they analyzed with the engineering team. They found that inside these 200 mutants, there were two faults on the production code. If we extrapolate these numbers, considering a uniform distribution of defects, we will end up with the possibility of having 271 defects in the code awaiting to be executed. Another of the fallacies that related with the code coverage that I heard is that code coverage is a harmful metric. And the underlying reason behind this affirmation is that many developers try to hit 100% code coverage because they were somehow mandated to do it without knowing the real implications. Some of them end up cheating the code to artificially increase the code coverage. That leads me to another section on this presentation that I call it takeaways. And the first takeaways is that this is not a metrics fault. Cheating the metrics is a sign of bigger cultural and professional problem. If you add mutation testing to your workflow, the cheaters will be unmasked. And what about agile and extreme programming inside the safety critical system world? Well, this is in the ISO 26262, which is an adaptation of the AEC 61508 for the automotive industry. Even when the reference software development process is the V model, they are finally opening to accept approaches and methods coming from the agile world. Specifically, as we can see in the example one, it's saying that the trust-driven development can be used to improve quality and testability of requirements. And that's a great news. That are great news because it will unconsciously reach to a larger number of embedded developers out there, more or less like it arrived to me. Well, most of you will be now thinking, okay, but I'm not working in a safety-related environment. Okay. As Diane Bauman, that in her book, The Challenger Long Decision, she says that if non-accidents, that's the cases that do not reach the general public, were investigated, the public will discover that the mess interior of engineering practice is nothing more or less than normal technology. So that is how we proceed in our jobs, more or less. We will be returning to this later. Another of the this is a common trap, is not only from embedded, is the deviated focus. As I said, most of us became interested in testing or even TDD to prevent the number of bugs we were producing. But bugs, and also our inability to deliver new functionality in a sustainable pace, are only the visible effects of another most important aspect that we will see in a moment. Let's take a closer look into the TDD red-green refactor steps. As I said, making a simple thing work is orders of magnitude harder in the embedded world. If we use TDD, we will be trying to bring up new functionality in this phase, in the make it work phase. That is when we go from red to the green. And we will try to do it as fast, as simple as possible. And here, everything is permitted. All the things are allowed. The thing is to touch the green bar as soon as possible. In fact, this is something that is nothing new to us. It's what we have done so far during these years. But it's on the make it right phase when we enter into the refactor phase of the TDD, when we are supposed to engineering and craft the code right. That means that this is the phase where we must engineer our code right. Here's where we apply software engineering practices like simple design, solid design principle, design patterns, and it's here where we take a closer look to our dependencies and try to properly manage them. TDD, do it correctly, it's aimed to improve our internal quality. The two right quadrants, which conform what is called internal quality, even invisible to the client, are more important because when we have a well-engineered code, the number of defects are much more smaller, and so the bugs finally delivered to our customers. As another takeaway, we will say that our internal development and quality standards must be there in order to raise our internal quality high enough to preserve our organization, enabling us to deliver value to our customers in a sustained pace. If we do it properly, fulfilling any other external quality-related standard will be taken by granted. But okay, what about making it fast? We are embedded developers, and we usually have tight timing requirements, even if we are not developing real-time systems. Well, I delayed presenting this development phase consciously, as long as it's related with the very last of the traps common in the embedded world. And I call it the global performance pre-optimization trap. As Ron Jeffries says in the Refactoring's book of Martin Fowler, even if you know exactly what is going on in your system, measure performance, don't speculate, because you will learn that 9 times of 10 won't be that you were right. So it means that 9 times of 10, you will make useless optimizations. So the first question should be, how fast? If we don't have a clear specification, now is the moment to clarify it. Once we have an adjective number, then is when we finally have the timing specification and not before. Once we have it, what we need to do is to translate this timing requirement into a self-checking specification, like the other specs. Your tests, for example, can use the microcontroller unit timers for this purpose. And you will, as another requirement, we will fulfill this requirement as fast as possible, all right? We don't have to engineer anything here. And once we are fulfilling this requirement is when let's make the code clean. Let's manage dependencies and do it while we are fulfilling the timer requirement. So another takeaway comes from Martin Fowler in his book. The secret of fast software is to write tunable software first and then tune it for sufficient speed. The last of the traps that is a common trap, and maybe is the most important one, is the knowledge and skills trap. No human being can escape to the Dunning-Kruger effect. The natural tendency is to think that we know more than we really know, at least until we become really seniors, which does not have necessarily a direct correspondence with years of experience, at least, as I said. High humidity threshold prevents us from continuing learning and continuing improvement. So we better should follow one of the most valuable advices from one of our beloved masters, Dijkstra. Be a humble programmer. So we need to move the quality boundary forward. And moving from making it work and the survival mode into a making it right, so behaving as engineers. So we need a new approach that is outside the usual embedded limits. As James Greening explains in his wonderful book, what we need is an embedded dual target TDD workflow. What we are going to do in the stage 1, we are going to write a test, make it, but we are going to do the red-green refactor cycle in a host-based flow. That means on the machine where we are developing. We will generate the self-checking specifications. We will fulfill the specification as fast as we can. And once we are done, we are in that stage, we will improve our code iteratively every minute, with a cadence of every minute. For sure, the end machine is different from the host, so we need to run all the specifications and also our product in the target microcontroller or a target device. This is what we do. That's what we do in the stage 2 and stage 3. We will cross-compile our solution and we will execute the same tests in the evaluation hardware. Or if we found that it has lengthy loads, delaying the feedback, we could use a microcontroller simulator coming from the vendor. And here is where the vendor should provide the correct tools. So a microcontroller should be one of the things that we will need to have from a vendor when we select them. With a cadence of 5 minutes, maybe, or if we can do it with less time, the better. The fact is that when we run in the target environment, in the target-based flow, the feedback loop is going to be wider. So the main benefits of the embedded TDD is that it will remove the fear, because we will be incrementally developing our solution that is going to be comprehensively tested at least on 2 different platforms by default. The fast feedback loop will encourage us to try new approaches that were very far beyond before that. We will learn fast. That way, maybe we can fail fast, but the objective is to learn fast. Without limits, because we will have new tools finally available, like static analyzers, rule checkers, comprehensive functional and not functional testing, mutation testing. And when I say finally, I mean that they are going to be able to be applied to 99% of our code base. Only the 1% corresponding to the firmware thin layer being able to be processed by some of the tools. This tool set is going to be run automatically by the continuous integration and continuous testing server anytime a code change is sent to our source control server. This is an example of a pipeline that we see in my course, where we run several stages in the host, like static analysis, dynamic analysis, and we extract some metrics like code coverage, mutants coverage, and cyclomatic complexity. The same kind of dynamic analysis is done in the target if everything was fine in the host, because, as I said, it took a little bit more time. We also extract some metrics, and one of the most important is the warnings from the cross-compiler. These warnings that we usually forget, and we have to go to a clean build. This is an example of the information that can be seen for each build. That allow us to give up or put us in a situation of an increased competitiveness, because we will have fewer defects, our developmental lead time will be reduced, we will have better market adaptability through portable solutions, and our code is going to be able to be done by anybody, anywhere, at any moment, and at a sustainable pace. That means, at the end of the road, improving our talent and acquisition and retention. And there will be no more excuses to develop complete embedded portable solutions made of reusable modules while using a common and shared language between development and business. That is, we will finally able to express ourselves in the terms of the domain. Well, if you remember, we led the solution or the code in that stage, but we are going to trying to make it right. So we will move towards reusable drivers. What we need is to put in place an abstraction layer. It's called processor abstraction layer. The PAL is aimed to hide the low-level details that each specific microcontroller internally performs in order to execute one of its possible tasks. For example, one of the modules conforming the PAL will be in charge of reading an analog channel, and as we will see later on. For sure, for each microcontroller unit, we will have to implement the PAL that we want to use. And this PAL is the only, this layer, the PAL implementation, is the only part of the code that is going to be allowed to know and interact with the special function register of the microcontroller, which is the microcontroller hardware gateway. For sure, that means that it's tightly coupled to the microcontroller unit, but it's duty. And also to the cross-compiler, no problems. It's exactly what we want. This is why we call this thin layer the firmware or microcontroller firmware layer. In order to develop the reusable IC drivers, we could use test doubles, which will implement the PAL at our convenience. We don't need to run until the hardware. Of course, once the spec is established, we will exercise the drivers through the public API. The IC driver test suite goals is to capture our integrated circuit datasheet interpretation, allowing us to implement the EC driver accordingly to it without introducing errors, while removing the hardware bottleneck-related uncertainties and delays. And what about doing TDD in firmware? Well, when we are working on a specific MCU PAL implementation, we cannot use any test double. What we need is to assure that we are interacting with the special function registers correctly, which means assuring that the sequence of reading and writing steps are correctly done and in the proper order and with the proper values. In order to do this, we could make use of the decorator pattern, for example, if we were in C++. But if we are in C, the only thing that we can do is to have step-pipe hooks in the code production itself that will be compiled only during testing. We don't have any other option. This is a production code example belonging to the PAL module in charge of reading analog variables. If I manage to communicate its intent, even if you are not an embedded developer, you could understand what it does. It's a statically linked template pattern which executes every of the steps needed to get analog measurement from an analog channel, delegating to each of the microcontroller implementation steps its details. The goals of the microcontroller PAL test suite is to capture our microcontroller unit datasheet interpretation, which allows us to implement its PAL according to the datasheet without introducing errors, making possible to use this microcontroller in our solution while removing the hardware bottleneck related uncertainties and delays. And what about towards embedded business software? What about the application? We let it violating dependency and open close because it was calling directly the EC driver layer. For sure, what we need is to create the proper abstractions related with those entities that only makes sense from the point of view of the system application, which I call system components. Each hardware implementation will implement these abstractions in order to be used by the application. For example, imagine that we have a temp sensor, right? Like a system of a component of the system is a temp sensor. If we have a temp sensor that is made of by the STH11 IC circuit, we will have a module that it will implement that. And it will use, obviously, the EC drivers, the driver of the STH11. That means that this layer, it's tightly coupled to the PCB components, but it's a purpose, no problems. How do we make our application independent of the components of the hardware or the PCB itself? Another pattern to the rescue, factory. We will use a factory that it will read from a configuration file which components are going to be used, and it will create them. Well, so far we have been, now we have been talking a lot about the hardware, but let's go for business application development. What we will do is we will have system asserts. So we will test we will verify the behavior of our system with an abstraction of the system, what the system must done independently of which components or drivers are being used. It will implement, depending on the system, on its components or drivers, which are these assertions. And it will use the test double to check them. For sure, what we will need also is to, in the arrange phase, we will need to have somehow the main instrumented in order to stop it, because if not, we will be running forever. We don't want that. In the array, the same applies to the arranges. We will have a system abstract arranges that each implementation will each components implementation or hardware implementation will implement, and it will instantiate the test doubles. Once done, the application test suite will execute the main directly, and we will be listening or capturing what is going to happen at the very far end of the just reaching the hardware, and with units of functionality, independently of the structure or the architecture that we have, one after another in a slicing mode. The goals of the application test suite is to capture the product specifications. It will allow us to implement them without introducing errors, safely and incrementally, and specify them for different system or product configurations, while reducing or removing the hardware bottleneck related uncertainties and delays. I want to emphasize that these specifications could be functional or not functional. We could do whatever we want here. So what we have done is we have accomplished is to have a plugin architecture, which means that we have drawn a line and we have made that all our business logic, it's a higher level, everything that wants to work with this business level is going to be a plugin. So we have made all the hardware, including the microcontroller unit, a plugin to the business logic. As a final bonus, I'm just ending. Fallacies and mantras. Debugging is part of development. No, debugging is a shame. While debugging, we are not creating anything. We are adding zero value to the organization. So we have to take this into account. Measure your lead time in order to objectively know which are your bottlenecks. You will be surprised. Another of the fallacies is that TDD is a testing technique. No, it isn't. It is a development and design technique. Another of the most common fallacies in the development world is that we can get the same benefits following a test later approach, and that's completely wrong. Test later are testing techniques focused on external quality only. They have nothing to say about the design or the development. Final takeaways. You can't be agile if your code sucks. You can't improve your code if you fear to refactor it. And you can fearless refactor it without a comprehensive suite of tests. So, as a closing advice from the master, Dijkstra, we should raise our quality standard as high as we can live with, because it's the only way to discovering how that boundary should be moved forward. And in my case, the only way I have found so far to do that is to follow TDD. Well, this is the end of my talk. I hope that it has been interesting for some of you. I would have liked to do a little code example, but that will require much more time. If there's someone interested in this or in commenting any other matter, you can contact me through my website, Twitter, or LinkedIn. Thank you all. Gracias. Oh, Alex, I cannot hear you. You are mute.
Oh, sorry.
Now, Alex.
Sorry. Okay. Gracias. This was a great presentation. Thank you for taking us in such a deep dive. And there's a lot of discussion in the channel. Comments, you can read them, please, if you can jump in later and answer some questions. I would just point one thing. There's been some confusion about mutation testing, and thank you for bringing it up. And I just want to mention that people talk about false positives in mutation testing. And I encounter that fallacy a lot when people say, look, if I have something greater than or equal, and the mutation testing framework changes it just to greater than, then the behavior doesn't change. So why is it bothering with that? But you see, mutation testing uncovers problems that may happen in the future. New team takes over, they start making changes, and your rule that something should be greater than or equal may be inadvertently changed to something just being greater. This is where mutation testing comes in and warns you, like, look, are you sure this is because the test didn't fail? You changed the processing logic. You changed how you're comparing values. Tests are not complaining. Therefore, it looks to us that you don't have enough tests. Right?
Exactly.
So that's one fallacy that I often encounter when I'm teaching mutation testing. I don't know if you have any other examples to elucidate.
Well, the example I mentioned is that there was a corner case, missing corner case. So they were whispering to us that there's a corner case missing. There are other situations in which they point to you that the implementation was not correct. So, for example, I have to dig another one. There is another tricky, but maybe it's only for the embedded world. But let me explain. There's something that is called, I think it's called lazy initialization. It's like when you declare a variable, the compiler assigns a value. And imagine that this value is 0. By default, most compilers assign them as 0. If you have a sentence in your logic that puts it to 0, and there is a mutant that will comment out this line, and this mutant will be alive because it's the initialization variable is to 0. So in order to kill that mutant, you have to do not realize on how the compiler initialize your variable. So you will be forced to initialize. So at the end of the road is, I want to see the cause effect, right? So it was initialized to 0 only by that.
Thank you. I think we're out of time. We have Liz, and I will give the reins to our TJ.
Thanks. Bye.
Thank you so much. This was brilliant.
Okay, and it is somewhat appropriate. You refer to me as the DJ, as J is in fact my middle initial. So I could be like DJ Aronson.
Ooh,
Too bad I don't have my little double turntable here. Zoop, 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 zoop.
Sorry, we're out of time, but otherwise we could have a little banter, right?
Yes. So I will take the hint and hurry along to the next speaker, who is a lean and agile consultant, international speaker, methodology agnostic, specializing in, sorry, I'm not sure how to pronounce this, Cynefin. It's Welsh, so even my best attempt to pronounce it would probably be wrong. Anyway, also specializing in BDD and embracing the risks inherent in software delivery, driving collaboration and transparency in teams and improving people's ability to improve themselves. And as you may have seen in the comment stream, one of the creators of the JBehave Java BDD tool. So from London, England, please welcome Liz Keogh.
Hi, everybody. Dave, if you can hear me, please put something in the chat so I know the audio is working. We seem to have had a lot of problems with that today. So I've got a confession to make. This is a TDD conference, and I said I was going to TDD all the things. I don't actually do TDD. I do BDD. I do BDD instead of TDD wherever I possibly can. I actually got to hang out with Dan North back in 2004 when he was teaching BDD at ThoughtWorks. And the whole point was that he was replacing this word test. So you might not hear me use that word so much, but I'm still going to be talking about it's exactly equivalent to TDD. I'm just going to be using slightly different language, and I'm hoping that it will give you a bit of a different perspective on how we do this. Okay. So here's an example of how I do TDD or BDD at a class level. So a lot of you probably associate BDD with the end-to-end scenarios and things which cover your whole application. It actually started at a unit level. So JBehave originally was intended to replace JUnit. And the idea was that you could start your test method with word should instead of test, which is what JUnit 3.x back in the day insisted on. And nowadays we've got annotations instead, so we don't really need to have these specific BDD tools at that level, but I still do BDD. And the way I do it is I think of an example of how the class is going to behave. So I take my class and go, how should this class behave? What should it do? And that becomes my test method, should wait for events to occur. So this little class here, don't worry if you can't see the code. I'll go into it in a bit more detail. It's a class that I use for waiting for things to happen, and it's actually part of a test harness that I am also testing. So this class is called a waiter. So I start by thinking about what the class should do. And I think of an example. So given an automation element, when we cause a slow event on that element and we wait for the event, then we should be notified when the event occurs, right? That's what it should do. And I think of the context in which it should do it. That's the given. The event that should happen, that's the when, and the outcome that we want, that's the then. Okay, you'll notice there are two whens there. It is actually the thing that happens when you have an interaction of two people or time passing. There's no way to get round having two whens. It's okay to have two whens. So when I've done this, those of you who are used to doing arrange, act, assert, by the way, it's the same thing. Arranging the context, acting, performing the event, asserting the outcome, given when then, it's totally equivalent. So given an automation element, then I start filling in the code. Now you'll notice that when I do BDD, I often talk about how the examples should be concrete. The comments are abstract because the concrete example is the code. So we've got the code, we're filling it in. In this instance, I'm finding a combo box and then I'm causing a slow event. So I'm going to wait for this combo box to actually fill in with the carnivorous pet food. I'm testing a pet shop and we wait for the event. So this is the waiter waiting. It's a little bit of a complex thing. This was written some time ago before I knew Kotlin. And then we should be notified when the event occurred. Okay, really, really simple. But I fill in the code afterwards. It's just a really nice, easy way of thinking of how to do TDD. There you go. These days, by the way, end-to-end, I added this slide just because we were having a bit of a chat about it. I tend not to use the English language frameworks. I did help write one. I'm kind of a bit sorry. Back in the day when we did JBehave 1, it was very clunky and nobody actually used it, but they still had all the conversations and they still captured the conversations in that lovely rich given when then format. And I think that's been lost a little bit. So I tend to use DSLs like this and I just knock them up. There's a blog post I wrote there on how I do that. Okay, so we're all familiar with how to do this, right? This is TDD cycle. I'm just talking about it in terms of behavior, but I'm introducing new behavior. I'm writing a failing test. That's that given when then, and then of course I make the test pass and then we refactor it. And you know this, it's a TDD conference. You must have seen this a few times today. Okay, all right, but I said I was going to TDD all the things. This is where it gets interesting. I'm going to show you how those patterns apply to lots of different things and where they fail and where they fail for your code too. So we're going to TDD a person. Okay. Let's TDD a person. So people have existing behavior. They are essentially like legacy code. When you come across legacy code, before you can start doing TDD on the changes, there's usually some stuff that you want to keep around. So you want to start by refactoring it and adding tests over the stuff that already works. When you've done that refactoring and you've added those tests, then you add your failing tests for your new behavior, and then you make it pass. Okay, and this is just a nice way to deal with legacy code. I recommend Michael Feather's book, Working with Legacy Code. Really great book. He talks about seams and where to do the refactoring to start teasing this stuff apart. Statically typed languages are much, much easier to do this with than dynamic ones. I really love statically typed languages because I end up in these spaces as a coach all the time. Okay, so what does that mean for us when we're dealing with people? Well, refactoring and putting things under test is capturing the behavior that we want. It's amplifying that positive behavior that we want to keep. When we're writing a failing test, what we're really doing is we're describing the desired behavior and maybe giving some examples of the behavior we want. And then, of course, we change the behavior. Now, some of you might have heard of the sandwich model of feedback. Pardon my French, it's sometimes referred to as the shit sandwich. And the idea is you say something good before you say something bad that you want to change, and then you say something good again to make them feel better. Don't do that. We're going to do the sandwich the right way. And this is the 3 models of feedback. Okay, so there are 3 models that I use for giving feedback and helping people change their behavior. The first one is you want to amplify and anchor the existing behavior that you care about. If you do nothing else, do that. it's really easy. If you can't find something positive that somebody is doing, find something positive that somebody else is doing. So if you're seeing that, you know, that person never writes their tests before their code, find somebody who does and go, have you seen what this person does? I really love what this person is doing. If they write one test before their code, that was awesome, right? If they do something nice for you, say thank you. It's amazing how we get caught in our own heads. We forget to say thank you to people when they do good things. I've watched people demoing in a showcase for the first time, and the manager kind of goes, right, okay, well, what about this? It's like forgetting that this is the first time they've done that. That was amazing. Well done. That was fantastic, right? Make sure that the behavior you value is anchored. This also creates psychological safety. That's Google's measure. They did a Project Aristotle thing. They found they were looking for what made teams awesome. They found that psychological safety was the #1 indicator of high-performing teams. Okay. So the sandwich model done well. You amplify the positives and then you describe the outcome you want, but you don't have. You don't need to change the code yourself. People will close that gap. You don't actually need the middle of the sandwich. All right. So what's the third model? Sometimes you don't need to do this. Sometimes you can shortcut this. Sometimes you can actually just talk about the behavior you want to change. It's called radical candor. It has to come from a place of care. That means that the people you're talking to have to know what you value about them, and you have to have an idea of where you're trying to get to. You have to have done the sandwich model, well, lots already. That's how you gain enough rapport with people to be able to say, hey, here's a thing you might want to change. I will tell you that even when I do this, I remind them. I say, hey, look, I want to say something to you. Before I say it, let me please remind you, you know what I value about you, right? And you know where we're trying to get to. And I'm going to say something that's going to be difficult for you to hear, but I want you to know it's because I care about your success. And it's within the context of having already taught lots and lots about the awesome things you're doing. Here's a thing you want to change. Okay. So there's the 3 models that I use, and it's the same as TDD, right? Anchoring what you value, describing the behavior that you want, and then the code changes. All right. So there's a nice little model that I use for finding those examples, and it really helps, especially when I find people are new to things. So it helps me look for those positives. I think about, so it's called Dreyfus modeling. And the way I do it is I think about, first of all, how people start picking something up. Okay, so I don't know how to drive a car yet. I started learning, and when I was learning, it was very conscious. And I had to remember the recipes, check your mirrors, do these things. And then as I became an experienced beginner, I became, we call this just enough to be dangerous, right? It starts becoming a bit intuitive, but I still can't be trusted on my own. I still do need the instructor, probably who has the brake, or I'm traveling at low speed with somebody who's watching for danger signals, etc. Right, so I can't quite go on my own yet. The next level we call competent. I've renamed this when I've used this, the practitioner. So practitioner is just because somebody is not yet successful in a particular skill, it doesn't mean they're incompetent in their whole job. So maybe somebody's learning TDD, but they're really good at DevOps and they're great at prototyping, right? So they're learning something for the first time. It doesn't make them incompetent. So I've renamed it to practitioner to avoid this implication of incompetent. As you become more knowledgeable as a practitioner, you start being able to influence people and you start collecting ways this works in different contexts. And then finally, there are the experts. I don't actually coach people towards expertise. I find that people who are knowledgeable do that naturally, usually because they found some niche where they're the only person who knows about a thing, and they're being expected to provide answers about it. And so they gradually learn more and more because they feel a bit like an imposter. Everybody gets imposter syndrome, especially the experts. And then finally, they're recognized for what they do. Okay, so I'll give you a couple of examples. And I use this not just for individuals, but for whole teams and sometimes whole organizations as well. I find examples of the things that people do. So let's say somebody's adopting TDD for the first time. They can copy and modify existing tests and they can write tests after the code. And I see so many people say, that's not TDD, that's really bad. It's better than not having tests. And they're learning. It's awesome that they've started that journey of learning. Okay, so this is still a positive. They've got tests. That's great. I ran across one company where the people have been told if you're not writing them before you code, you're not doing TDD properly. So they didn't do it. They didn't even try. So amplifying the positives, it lets people try things out. Okay. I also thought I'd pick as an example how developers get work, right? So this is pretty typical of teams where they've just started picking up Scrum, they've just started doing Agile. The project manager, they've still got an Agile project manager, or the product owner, sometimes the Scrum Master is giving the work to them. So they're assigning things in the backlog, say these are going to be the things you do this sprint. And they're starting to seek feedback on their work. That's really great. They're like, yeah, is this working? Can we get this live? Can we do smaller increments? Can we ship this yet? Great. An experienced beginner who's doing TDD, they sometimes write tests before the code. Sometimes, maybe most of the time. They can do things like get TDD working from scratch. They don't need to copy other people's anymore. They know how to get TDD up and running. And the developers who are pulling work, they assign work to themselves based on their skills. We start seeing this happening. By the way, if you're in a Scrum team where you're being given the work, this is a game changer, especially if you can leave it unassigned in the backlog so that you can pick up the highest priority of work if you possibly can. It's a first step to getting real autonomy in the team. So I highly stress this. Okay, so what happens when people are practitioners? What kind of things do we see TDDers do? We see the practitioner TDDs, they're generally writing tests before the code. It's a guideline they use all the time. There are sometimes when you won't do that, and I'll get into that a bit more later. Using the tests to drive out the design and thinking about responsibilities, and their tests are readable and meaningful. Okay, and this is not exhaustive, by the way, I'm just picking up some examples. Developers focus on the highest priority items, and they're working on them as a team, and they're having conversations with the testers and the business representatives before they start work. It's not just documents being handed over. That's what I regard as being an independently successful Agile team. But it's not the end. This is always an ongoing journey. What do knowledgeable practitioners look like? They're teaching other people TDD. They know when to use spike and stabilize instead of TDD, and I'll talk a little bit about that too. They refactor code as a habit without even really thinking about it. And the devs that are successful, the teams that are successful, they're collaborating to the point where they've only got one or two big items. They're finishing one off where they're starting another. So they've pretty much got single piece flow working. That's magic if you can get there. But you're successful. The practitioners is perfectly successful. You don't have to get here. There's value just in getting to that previous level. You might decide that it's not the most important change, right? The team are focused on the highest priority problems. And again, this is just examples of the things I see. You might find that in your context, you're doing something different. So I pick these examples and I share them with people. I say, here are some examples of things that I do see people do along their journey. And they can look at it and go, oh, okay, I can roughly see where we are on the journey. And they feel really good because at least they've started it. I always try to make that first level, some first novice stuff, something they're already doing. Okay, so they have some confidence about what they're already able to do. And there we go. I don't coach experts. They'll get them there themselves. So there we go. Novice, experienced, beginner, practitioners, knowledgeable practitioners, and experts. It's always phrased positively. If you're thinking, you're not writing your test before your code yet, flip it. and move it down a level, move it to the next level. Okay, so practitioners write their tests before their code. So you're always thinking, okay, I can see that person, they've got some of their journey to go. What's the next stage in that journey? How can I describe this in a way that's positive? And that's your 2 slices of the bread. All right, there's a problem. People are weird. They don't always do what you think they're going to do. They might choose not to listen to your feedback. They might go off and do some tangential thing you didn't think of. There might be side effects as a result of them adopting a behavior that you want them to. Guess what? Your code is weird too. And I'm going to show you why, and I'm going to show you what to do about it. To do that, I'm going to use the Cynefin model. It's pronounced like Kevin with an N in it. And it really is the hardest thing about that model is the pronunciation. Oh, sorry, it skipped on. Okay, so this is going to be the shortest introduction in the world ever. There are 4 domains in Cynefin plus 1 in the middle, disorder, where we don't know which applies. It's a framework for making sense of different situations depending on how predictable or unpredictable things are. So clear problems, you can categorize them. It's one of those. Dull, I know what to do, right? Complicated problems require expertise. They've still got a predictable outcome, so you can close the gap between what you have and what you want. Analysis works. Chaos is a domain we don't really like. It's transient. It resolves itself really quickly, not necessarily in your favor. It's urgent. It's urgent production bugs is usually what we encounter. The clear stuff we usually encounter is things like login. It's just boring. And the complicated stuff is often things where you need an expert. The example I've used before is GPS libraries, right? There's a function which calculates the distance from 2 GPS coordinates. And it's not changing, but I don't know how it works. I just copy it, or I go find an expert who can explain to me how it works. But then we have complexity. And the complexity thinkers use those words complex and complicated in 2 different ways. So complexity thinkers, when we're in complexity, stuff emerges. It's not like chaos. We've got time to try things out. But the outcome isn't predictable. You can tell how you got there in retrospect. So we have to do what's called probe, which means to try something out that's safe to fail. In software, that means a spike or a prototype. It means we're not necessarily sure what the outcome's going to be. If you're not sure what the outcome's going to be, you can't write the assertions. You might not know all the scenarios. You might not be able to write all the tests for a class if you're not quite sure how that class should behave, what it should be doing. It's going to emerge. So how do you tell what kind of thing you're looking at? There's a little scale that I use, which I find really helps me. I ask, who in the world's ever done this before? 5, nobody in the world's ever done this before. It's totally new, might not work at all. 4, somebody's done it, but not in our organization. So we have no way of knowing what they discovered when they did it. We don't know what systems they had in place that let them do it. 3, somebody in the organization's done it before, or we have access to expertise a different way. We can learn it from books, learn it from YouTube. 2, someone in the team's done it before. 1, we all know how to do it. Okay? And this is just a guideline. The thing is that when we're doing software development, there's always some aspect of it that's new. We're providing new capabilities to the business, new behavior that they never had before, new things that they're going to be able to do that they couldn't, or that a system is going to be able to do, or a customer is going to be able to do, a staff member is going to be able to do. Or it might be doing it in a new context. It works in Chinese, or it might be with a new quality, same, only faster. But there's always something new that's driving what we're doing. There's always a 5 or 4. Those 5 or 4s are where the value is, but they're also where the discoveries are. They're unknown unknowns. They're risky. We don't know what the risk is because we've never done it before. We have no experience of the risk. But we know that the risk is in those 5s and 4s. You won't find it in a risk matrix written down, because that only applies to stuff you've experienced. It's unknown unknowns. but we're going to make those discoveries. We're going to learn by doing. We need to spike, and then once we understand the problem and it's moved into that complicated space, then we can refactor it. Or if you don't have people like me that really, really love refactoring for fun, rewrite it with your tests up front. So there's a couple of different ways I use this. Complex, spike and stabilize, do BDD around the predictable bits. Sorry, my slide deck is misbehaving. We always discover things when we do it for the first time. Complicated stuff, that's where you want to learn from the experts. Perfect place to do BDD, TDD, document what you're learning by writing tests. Tests are living documentation, right? Those lovely living examples. For the clear stuff, if you're doing BDD, I find it enough to name the scenarios and don't write them out. But ideally, you're using libraries and off-the-shelf stuff anyway. As you get down into the clearer stuff, into the more obvious stuff, Dan North's got a great pattern he calls ginger cake. It's exactly like the chocolate cake, only with ginger. You know, wrap some examples around what ginger is like. Don't worry too much about the rest of the cake because it's boring. We've done it before. Okay, so focusing your efforts where the risk really is. If you're in chaos, then you probably aren't even at this conference because you're busy fixing all those urgent production bugs. Don't be going through that 5, 4, 3, 2, 1. Just, you know, get your war room together. People drill for chaos, by the way. That's what they do in chaos. So there you go. Different ways to use to approach TDD depending on how predictable or unpredictable things are. Okay, so the one thing I haven't really talked about is refactoring. What do we get from refactoring code? We get things like the lovely single responsibility principle. We divide things up, we extract methods out and extract classes out. We get good design, we can trust what the code does. The code emerges, it always needs cleaning up. So be forgiving when you find messy code. Be forgiving of yourself when you find it 3 months later and you're cursing the person who wrote it. Aim for better, not perfect. At some point, refactoring that code will not be the most important thing to do. Okay, so what do we do when we're refactoring people? What does it even mean to refactor a person or a team or an organization? It means we're playing to our strengths. We're playing to our differentiators. We're playing to the things that make us unique as people or as an organization. We're playing to the things the team does well. We're letting others help us with the stuff that we don't do well. Maybe we call on a DevOps expert from another team and ask, can you please come and help us with this? Maybe we get somebody else to teach us TDD. Or maybe we actually just go do all the really spiky and prototyping stuff and let somebody else clean it up because they love that and they're really good at it. Simon Wardley, when he does Wardley mapping, talks about pioneers, settlers and town planners. Your hacky, spiky, prototyping people like me who love refactoring and getting things stable, and then the people who have the big picture, the architects. People change. They always make mistakes. They're always trying new things for the first time. There's a saying, we get promoted to the level of our incompetence, the Peter principle, but it's because we've never done that role before. So of course we're not practitioners in that role. So be forgiving when you see that, you know, be kind, call out the positives, give them a place to anchor what they do well. There's a reason that promotion happened. Aim for better, not perfect. There is an exception to this. Somebody once asked me, what would you do? How would you apply these principles to dismantling nuclear power stations? That was his job. I said, I don't know. If we have an explosion in the code base, we just roll it back. So unless it isn't safe to fail. If it's not safe to fail, you probably want to be testing it very rigorously indeed. And make sure you prototype it thoroughly. Okay, so that's it. I'm just going to summarize what I've said in this session. First of all, amplify the positives. Anchor the code that's valuable when you're working with legacy systems. Eventually, all systems do become legacy. Simon Wardley says they always move to the right, you know, but they also become more complex over time as well. In complexity, tests and descriptions of behavior are just examples of what might happen. And you want to spike and stabilize those examples. Don't bite off too many of them when you're spiking. Just 1 or 2 is probably enough. I like to have about 7 scenarios or 7 tests in my head before I move on to the next thing. Change code, but help people change themselves. You don't need to address the problem. Describe where you want to get to. Okay, describe what the outcome that you're after looks like. Keep it positive. Unless you've got that rapport and you're saving a lot of time, saving a lot of pain by introducing that radical candor. Amplify your own positives too. We are so cruel to ourselves. We feel like failures so much of the time. We focus on the things we do wrong, on the things we got wrong, the things we don't know how to do yet. Think about what you do know how to do. Think about where you've already come in your journey. Remind yourself of that. Write it down. Stick it on a post-it on your monitor. Give yourself the psychological safety to try out the new stuff. And then your behavior will change for better too. That's it. Thank you very much.
Thank you, Liz. This is a sensational session. I was so curious thinking ahead when I read your synopsis. I'm like, what is this going to talk about? And this really, drives the point home. As G-Paul said in a comment, it's kind of the opposite for how he works. He starts from code, driving towards people. You start from people, driving towards code. The lessons learned here are timeless and amazing. I can tell you from my experience, I'm really fighting this uphill battle. And I already mentioned that in my opening talk, how, when I entered the organization and everybody, yes, we want to be more agile. Yes, we want to be more quality, security. TDD, interesting. Yeah, sure. Maybe when kids grow up and, move out, we'll try this TDD. So what I did, Liz, out of frustration, because, I'm bringing TDD in. Everybody's like, oh my God, the sky's falling. The business side is like, what is this guy doing? Did we hire the right consultant? Why are we burning money on this? So I had a lunch and learn session, which I called TDD for non-techies. And I gathered all these business people and I walked them through writing a short story. First of all, what I did is I built a little framework where I can create on one side tests for the short story, like must have a title, must have 4 subtitles, etc. So you write your expectations as you go. And on the other side, you write a little bit of a story, you run the test, and it's showing you whether it passes or not, and how it creates the safety net for later on when we are refactoring the story, or we're writing a second draft or a third draft. And indeed, it really rang the bell. And people are like, oh, I see what it means. It means we are proceeding with being clear on the expectations, one expectation at a time, make it happen, and rinse, repeat. It really made an impact. So that's something I can also recommend for others if you are encountering resistance and viscosity in your environment. That I like to reach out to the other side of the fence and to explain what is it we are doing and how are we guaranteeing quality. But really, I think from my perspective, your message, playing to people's strengths, will never fail. Will never betray you. If we're trying to hunt down some discrepancies or some delinquent behavior, it's not going to work. People are just going to become defensive, and you encounter this, and it's not going to happen.
Right. Yeah.
So,
I've encountered that backfire effect several times. My coaching advice is always never push.
Yeah.
There's always things in the context that you can change, and as long as something is changing for the better, eventually people will get there. It's Dave Snowden, who created the Cynefin framework, talks about fitness landscapes and finding the low energy gradients. So to give you an example, I had one group I was teaching BDD to, and they were like, yeah, but it wasn't happening. So instead of going after BDD, we put a monitor up at the end of their table that showed their status of their build. And it was red on green. In fact, it wasn't even my idea. It was another lady I was coaching. She put this thing up, and within a couple of days, it had 4 builds on it, and one of them was red. And then the builds were green, and then they briefly went red again, then they went green, and then they started caring about the quality of their codes, and then they were interested in TDD and BDD and started to, you know, look at what they could do to increase the quality, and make the build stable as well. So having stable end-to-end tests, and it's whatever you pick up, whatever you can change, it provides those pillars, those foundations for people to fill in the gaps. And
yeah,
they'll all get better. They'll all get better. It's also just such a positive way to live and a positive way to coach people. I'm very, very glad that, you know, yelling at people doesn't actually produce good change, because otherwise I'd be yelling at people all day. I get to be positive because it works.
Yeah, and something's happening in the world. I had a chat with GPA earlier, and we both kind of agree that we are getting to a better place, hopefully. And there's always a chance we mess up. But people like you, GPA, I'm very enthused about what you're doing, because I think we can create this better world, more gentle, diversify. You cannot get out of the expert beginner state if you don't diversify. There's no way. Because if you're stuck in this pattern and everybody thinks you're an expert and you think you're an expert, you have no idea that you're pretty at a low level of expertise. Another thing I'm reading here in comments from people who have been burned and who have a lot of experience, never mention the word refactor. Well, I know what you mean, but I would rather expose everything I'm doing, full transparency. I want my bosses to understand exactly what I'm doing. Why am I doing it? How is that benefiting them and the organization? So I think we need to work on socializing those concepts, like I did try to socialize TDD. I want to also try to socialize refactoring, the Boy Scout principle, all these things that they trust. They need to trust us. They need to say, these guys are very passionate about their work and they're doing their absolute best. And we should give them autonomy and agency to organize themselves, to diversify. And we'd like to bring people like you, Liz, to teach us that, right? And we are open to that. And that's the amazing transformation that I'm seeing. And by the way, I'm working on a really old-fashioned government organization project, and I'm seeing people opening up and want to learn about these things and how do we get better? How do we improve? So there's so many questions. I don't know what else to summarize. I don't know if you have any comments.
I want to say just one thing, because I will feel bad if I don't. You mentioned that, you know, you think we're going to make a better world and get out of it. The climate crisis is not safe to fail. That is not safe to fail. Just wanted to put that in there because it's important to me.
So here I just have this comment that says, Alex, there's a golden reason to refactor. You want less retention, you need more refactoring and code coverage. Selling points. We need to not hide what we are doing and act all secretively, because then the trust is a bit compromised. And at the end of the day, you know, if you can't build trust, then it's not going anywhere. You get big turnover and things are.
I've had people who put metrics on the board around, you know, how long it takes to do a bug that ought to be half an hour. And they actually measure how long it takes, and that, you know, that's including getting it through the build and getting it approved, how long it takes for that half-hour bug fix to hit production, from the moment you find it to the moment you hit production. And managers, when they see like 5 days, why 5 days? Well, because the code's a mess, because tests are flaky, because our build is too slow, because blah, 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 because you only let us release after we've had the conversation with the CAB board, etc. And that can really help bring those conversations. I'm a big fan of calling out the problem. You know, put it on a wall somewhere. I say amplify the positives, but if you do it anonymously, not it's so and so's fault, but this thing exists. Here is a piece of information. That can often get a lot of attention on it.
Yeah, and I've recently learned a powerful phrase which I'm trying to apply. Not calling it a problem. I like to call it a drag area. We have a drag area over here, and that's a bottleneck. And that way we expose it, and now everybody's aware, and now we may get sponsorship to really attack it and to get rid of it. Instead of calling it a problem, oh, you guys are full of problems, I know life is tough, blah, blah, blah. Positive verbiage, I think, helps. And that's why I appreciate your work and what you shared with us today, because it's all on amplifying the positive. I think this is the ticket. you and of course GPA and James. It's such a positive vibe, right? We are here in the comments. We are just like in love with what you're talking about.
I'm going to have to scroll back and read them after.
Yeah,
I wish I could keep those tabs open, but your voice echoes when I do that, and I can't.
Of course. Go back, please. If you have some time, maybe reply to some of the questions here. Thank you so much, and I hope we can continue to collaborate and to communicate and make it a better world. Awesome.
I'd love to. Take care, all. Thank you very much for being here. Bye.
And have a pleasant evening. All right, maybe I can play some more music and we can go. Oh, actually, why don't I take over to Dave? Oh, what's going on here? Dave,
Okay.
go ahead with your magic.
Well, I have no particular magic to do at the moment because our next speaker is not scheduled to start for quite some time, and I'm not the one who's got the jingle on the computer. I thought you were the one who's been playing that, aren't you? So yeah, there we go.
Okay, no worries.
And if I understand rightly, my emceeing is pretty much done, and the next speaker would actually be introduced by Maxi, right?
Okay, Dave, thank you. Send us your invoice. And before you go, I just want to quickly mention, because we are buying some time and the radio silence.
Sure. I'll help you fill it.
Yeah, I know you can do it. No problem. You did mention, I think, in one of the chats here that you have some mutation testing presentations and talks.
Mm-hmm.
Can you tell us a little bit about that? I'm curious.
Okay, what do you mean about mutation testing or about my presentations on it?
Whatever you think is relevant at this juncture.
Okay, well, mutation testing is still rare enough that I'm guessing a lot of our audience hasn't heard of it, or, well, now they've obviously heard of it since it's been mentioned, but they might not know a lot about it, like just what it is, how it works. The strange thing about mutation testing is that most other forms of software testing are trying to see whether or not our code is correct. Mutation testing isn't looking for that. In fact, mutation testing assumes that our code is already correct in the sense of passing all its unit tests and what other tests we choose to subject to mutation testing. I suppose one could include some integration or end-to-end tests. But anyway, the mutation testing assumes that the code is already correct and that there are tests to confirm that. So if we're starting with legacy code, especially up by, I think it's Michael Feather's definition, that it has no tests, well, okay, we can actually use mutation testing to try to build it, but it's not as useful. So what mutation testing does is it looks at mainly the quality of the unit test suite. And the way it works is it makes copies of your code with a tiny little change in it. So for instance, as somebody mentioned in a talk, it could change a not equals sign to an equals, or a less than or equals to a strictly less than, or whatever. And it will then run the tests. And if any given one of those changed versions, which are what we call mutants, does not make at least one test fail, then that implies some problems. The problems usually fall into two categories. There are gaps in the test suite, and especially if you haven't been doing mutation testing very much, that's probably going to be the majority of your flaws that mutation testing will uncover. The other category is dead code, whether it's just plain unreachable or redundant with some other code, or just not really have any real effect. I'm not sure why somebody's highlighting one of my comments, but whatever.
Sorry, that's me. Sorry.
No biggie. Yeah, I don't mind the extra fame. Whatever.
Exactly.
Now, where was I? Oh, yes. It can find either gaps in your test suite or code that can just go away because unreachable, redundant, or whatever. Now, there are tools for this for quite a large number of languages. Somebody in the comments was asking for tools for Java, PyT or PyTest. That's with an I, not PY test, is the main one for that. But I've used a few different ones for JavaScript, Elixir, and my main language these days, Ruby. So lots of other things there. Anything else you're particularly wondering about mutation testing? I mean, I could ramble on for an hour, and in some of my talks I do.
Thank you, Dave. Let me see if anything is in the comments. Jeff said, dead code, delete this code and no test fail. Is it really dead or just bad tests?
Could be either one. What I think is the hard part of mutation testing is trying to figure out what a mutant is, as I put it, trying to tell you. Kind of similar to listening to what your tests are trying to tell you when you're doing TDD, to drag it back to the topic of the conference. I have a couple examples in some of my talks where it may not be immediately obvious what the problem actually is. But the root of the cause, the root cause of the problem is these mutants are surviving, meaning they are not making at least one test fail. So you have to ask yourself, how is that happening? And usually that is because the mutant is giving the same return value, or it's having the same side effect, assuming you're not doing pure functional programming, as the original code. And then you can take a look at, okay, here's the original code, here's the mutant, and what's the difference between them? Why are they both returning the same value? And how can we give it inputs such that both those versions will return different values? The example I like to use is testing a fairly trivial function that's basically just a wrapper around raising a number to the power of another number. In most modern languages, that's a built-in operator, usually either a caret or two asterisks or whatever. And wrap that in a function, call it pow of x and y. Now, if you only have a test that tests that pow of 2 and 2 is 4, well, that's a really bad test for several reasons, and it'll give you a number of surviving mutants, primarily 2 plus 2 and 2 times 2, and, or rather I should say, x plus y and x times y, and y to the power of x rather than the intended x to the power of y. So you can take a look at each of those mutants versus the original x to the power of y and figure, okay, what inputs can I give it that will make it return something different? So you can do like 2 to the 3rd power. Well, let me rewind a bit. You can do 2 to the 4th power, and that'll kill the plus and times mutants, because then you'll get 6 and yeah, whatever.
Yeah, I know.
Again.
I just want to quickly mention George.
But the others will survive.
Yeah. George here had an interesting comment, which I like. He says, I would say mutation testing checks the tests for sensitivity to change, not for correctness. Bang on, right?
Yes, that is a good way to put it, but it takes a little more thinking about, okay, so it's sensitive to change. What does that really mean in practical terms? Well, that probably usually means that it's wrong.
Yeah, fat fingers.
Yeah.
Another developer jumps in, wants to make some refactoring, by accident changes something like you described. Bam! The test. If the tests don't fail, we have a mutant.
Right, and that actually gets to one of the academic underpinnings of the concept, which is the competent programmer hypothesis. The idea that when we make a mistake, it's usually a small mistake. So if the mutator can turn the current code into what we actually meant, then we can take a look at it and say, oh, you're right, we actually did mean y to the x or whatever.
Thank you, Dave.
And according to the banner, it's time for me to shut up.
Well, thank you so much for all your DJing, DJ. And now we are moving. We have a new DJ, Maxi. Hello, Maxi.
Hi, everyone. I'm not a DJ, sadly. I can only present people. Just don't ask me for anything else. Okay. Hi, everyone. We're having great talks. We have the event. We are introducing now to JobMeet. JobMeet is with us, but he's having technical problems. Everyone here has pre-recorded the talk in order to avoid these technical problems. So I think we are going to present his talk in his recorded talk. I'm going to introduce him. Job is from Netherlands. He works in TDD. He's been working a lot of time, and in his talk, he's going to tell us how to start with our test, but without all the problems that the breakthrough you need to have when you see. I don't know how to tell his talk. Everyone says TDD is difficult, and Job is going to tell us how to make it not so difficult and how to avoid the common pitfalls of it. So I think that's enough introduction. So if we can play his talk, I think it's there.
Friends, welcome to my talk. This is a rather introductory talk on TDD, though it's going to cover some important details that will make the adoption of TDD easier on your side. So let's get started. My name is Jov. I'm very passionate about extreme programming practices and software craftsmanship in general. Hence, I tweet about those things, and I also blog about those things. I also co-organized the Divternity conference in that regard, so if you Google it, you will find out more about it. So let's do a little theory about TDD. As we all know, TDD stands for Test-Driven Development. So it is definitely not a testing strategy. It has nothing to do with the traditional quality assurance as we know it. Is TDD a tool? Well, we couldn't buy TDD or subscribe to TDD and then point it out to our code base and expect it to do some magic. However, the test suite that will come afterwards can be seen as a tool because it helps us to maintain the behavior or the functionality of the software that we've written. The way I see TDD is as a skill. To me, TDD is a very specific way of writing software. There are different ways of writing software. TDD is just one of them. So I can describe TDD to you in some 5 minutes or maybe less, but it takes lots of time to master TDD. So it takes lots of practice and discipline and dedication. So because, as I said, it is a specific way of writing software, in that sense, it establishes a workflow. And that workflow goes like this. We start from the red phase, which means we have a failing test. And important point here is that if the test that we are writing is not compiling, that's also a failure. So we are working towards making it compile in order to be able to run it. Once we have the test able to run and it's failing, we are trying to make it green. And our aim is to get it to green as soon as possible. Once we have a green test, we can focus on refactoring in order to make the code better. And of course, once we are done, once we are satisfied with what we've done at that point of time, we can go back and write another test and so on. So of course, this is what you will find everywhere on the internet. However, there are lots of little details in between these steps, and that's the goal of this presentation, to go to some of them and explain them. But first, let's see why folks are doing test-driven development. So the first thing is the customers. I've seen a tweet recently where somebody was claiming that they don't write tests because their customers don't care about the tests. And that's absolutely right. Our customers couldn't care less whether we are writing tests or not. However, the hell they care about the behavior or the functionality of the software that we are writing, especially over time. So nobody really wants a broken software after, like, a release that we are making. So we have to take care of the functionality. In that regard, we are maintaining the behavior of the thing that we are shipping to our customers. Because when we do TDD, we write not a single behavior without writing a failing test for that behavior first. And in that sense, it's impossible to alter or break a functionality that was covered with a test, because the test will fail and we will have a clear indication that something has changed that shouldn't have changed. So in long run, we are fighting regressions and we are bringing it down to zero. What about test after? Some people do test after, maybe that works for them. But I'm gonna ask, how many times you've been in a situation where you have a bunch of hundreds lines of code and one or maybe two tests, even worse with some vague names like test 1, test 2. I don't know about you, but I've been in that situation more than a handful of times. And guess what? I've trusted those tests and I went into refactoring and broke significant functionality. Of course, that's how we learn. So to me, test after is pure guesswork, because there is always some behavior that we couldn't imagine after the software is written. We couldn't really think about, and we wouldn't catch that. And of course, when refactoring happens, we'll hit that spot that is not covered with a test, and everything goes downhill. There are basically two test-driven development styles known today in the world. The first one is the Chicago School. You can also meet that somewhere as a Detroit School of TDD as well. And on the other hand, we have the London School. One important thing is that those are not mutually exclusive. And when you're working on a particular solution, you can do both of them simultaneously. That's something that you can do. Let's take a look at the Chicago School. It is also known as classicist and inside out. And here inside out means the way of designing the software. So we are starting from the core of the thing that we are building, and we are working outwards. So while we are refactoring, we are emerging some design, and that design emerges from inside outwards. That's why inside out. One specific thing about this test-driven development style is that we are always designing in the green. What I mean by that is once we have a green test, to get it to green, there is a thing in TDD known as fake it till you make it. So in order to make a failing test pass, you do anything that comes to your mind. That's why we say fake it till you make it. So you can hard code values, do those kind of things. Once the test is green, you go to the refactoring in order to make it nice, and most of the time there are some designs emerging from there. But this refactoring, while we are doing the refactoring steps, we always aim to be always in the green. So all the time during these steps, the tests are still passing. On the other hand, we have the London School. It is also known as mockist or the outside in. And here again, outside in means on the way of designing the things. So it's more suitable when you have some insights or like some core basic idea on how do you want to structure the things. So you are going from the outside of the system and then you work inwards. One important aspect of this TDD style is that the design happens in the red. So as I said, it's known as mockist because it involves some mocks. So the mocks are used in order to distribute responsibilities across suitable collaborators. And that happens while we are in the red phase, while we are having a failing test. In that sense, there is way less work that you have to do in the refactoring step. So that's also something that is specific about this TDD style. As I said, it involves some mocking, and mocks are always controversial. So when this TDD style uses the mocks in order to describe and satisfy relations between different collaborators. Of course, as with everything, people can abuse the mocks and end up with some brittle tests that are basically checking some how something is written, like some implementation details rather than real functionality. So they end up fighting the tests, and maintaining the test is a nightmare. So that's why mocks are not very popular, because they abuse them. But of course, as I said, if we leverage the mocks in order to design the things, it's not that bad. And for the rest of this presentation, I would like to go through a working example, which is basically a search functionality. So we are gonna be working on, there is some criteria that we wanna satisfy. So we are gonna be doing a cities lookup for a given query. And the query has to have at least 3 characters. That's the criteria. So let's list first the criteria that we wanna show. Then the query should be case insensitive. We don't care whether the query is camel case or capital case or whatever. And of course, we have a match when the query is contained in the name of the city. The question is, where do we start? One good tip, especially if you are a beginner in TDD, is to just scratch out some tests that are coming to your mind initially on some piece of paper, and then stress over think about all the possible situations. Just write whatever comes to your mind first, and then as you go, most probably you'll figure out some other things, and then you'll cover them as well. Another thing is that we can start with the zombies. And of course, zombies is an acronym that I think James Graining came up with. So the first 3 stands for 0, 1, many, and here we refer to sort of 0, 1, and many as an output of the system that we are building. And while focusing on these 3 sort of outputs, we define the boundary behaviors, interface definitions, and exceptional behavior. So let me give you an example. Imagine you are working on some sort of catalog, and you are searching for products by barcode. So with the 0 case, you are clearly defining a boundary behavior, because you have, let's say, an empty catalog. So what happens when you have an empty catalog? You have 0 output, you have a boundary behavior. And of course, while you're working on 0, 1, many, you are defining the public interface of the thing that you are building. And of course, you have to think about exceptional situations. What happens when, let's say, for example, you have you are searching for a barcode that is not included in the catalog at that moment. So maybe that's going to be an exceptional behavior that you have to take care of. Ultimately, by applying the zombies, you will end up with simple scenarios and simple solutions. So your tests are going to be simple scenarios that will describe the thing, and on the other hand, you have a simple solutions, meaning that the code that you came up with will be simple. So let's get started with a searching exercise. We are starting off by writing our first test. What happens when you have no cities found? It's an always great idea to start from the assertion. That's the tip number 1. Why? Because whenever we start, when we are starting from the assertions and working upwards, we are gonna end up with a very minimal thing that is required in order to get to the point that we want. When we start from the arrangements, there is always possibility, and most of the time happens, to end up with things that are not very relevant for the given test, and then end up with things that are not necessary. So what we're gonna do, we are gonna start from the assertion, and the goal here is to reflect the expectations, to reflect the behavior that we care about. And that's the ultimate goal. So we start with the assertion, and at this point, as we spoke about, we have a failing test because it does not compile. So our aim at this moment is to get it to compile first in order to be able to run it and then watch it fail. So let's make it compile. This result that we are expecting here should come from somewhere, and they should equal to an empty list. So the result's gonna come from something that I'm imagining at night right now as like sort of searcher that will expose a function search that will take the query as an argument. And that searcher, I'm just gonna instantiate it here, though it is nowhere to be found. It's not existent. So I'm just gonna emerge it. I'll create a class for it. And now, because it's this class is empty, it doesn't have anything, back to my test, what I have is it is still not compiling because the search function is not exposed from that searcher. It does not contain any functions. So again, just the aim is to get it to working. We are gonna extract this function. We are gonna emerge this function in the searcher. So now we have this function, and because this is Kotlin, by default it adds this to do, which essentially is gonna throw an exception. If this was Java, it would be sort of something that like throw new, I don't know, not implemented, whatever exception, that kind of things. And now, because my test at this moment compiles, I can just run it and watch it fail. And that's what I'm gonna do. So I'm running the test, and it says that the operation is not implemented. It's very important. I couldn't stress enough how important it is to watch the test fail. And make sure it fails for the right reason. Because if the test does not fail for the reason that you're expecting it to fail, later on, it will not tell you when some behavior is being changed and this test is not failing. So that's the idea. Now, back to our code. How do we make this test pass? As we said before, fake it till you make it is an option. So the easiest thing that comes to our mind to make that test pass is just return an empty list. And now I run the tests, and as I can see, the tests are working well. Now I have a green test. And now I can just declare a win. I can declare a victory on this, because looking at the test, if there are no cities, if I have no cities at all, regardless of the query that I'm passing, I'm gonna have an empty list. So in that sense, I could be done. And that's why it is important, as I said before, to scratch out some tests that you are thinking about, that you have in your head initially. And then you will know how to continue afterwards. So another thing that I am thinking of is like, what happens when I have a city found? So I've started with 0, now I'm going to 1. What happens when I have a city found? So again, I'm gonna start from the assertion. I'm gonna expect is a list of Rotterdam, let's say the city where I live, as a result. And again, the result's gonna be the searcher.search passing their ERD as a query, because ERD is contained in the city of Rotterdam, in the name of the city. And of course, I'm gonna just create new instance of the searcher. And here we have a compiling test that I can go ahead and run. And of course, we are gonna run all the tests. And as we can see, the old one is still passing. This one is failing, the new one. And it's failing for the right reason. We are expecting Rotterdam. We got empty list. And now back to our code. How do we make this work? Again, fake it till you make it. The easiest thing that comes into mind is just to add an if and say if the keyword is ERD, then return a list of Rotterdam. And that would make the test pass, and it does. And now back in our function, in our production code, what we can do here is like, we can just sort of sense how this algorithm is going to evolve. But one of the worst things in software is to make assumptions. So what we can do better is to have more evidence on the things that we want to do. Like, for example, here we don't have evidence how this algorithm will evolve. And in order to get more evidence, we can write more tests. So which tests do we write to get that more evidence? So we can write, there is a thing called triangulation. So the terminology comes from fixing a point in multi-dimensional space. And in terms of software, it means when we have 0-dimensional algorithm, we're gonna return a constant. And to cover that behavior, one test is enough. If you have 1-dimensional algorithm, we need at least 2 tests, and so on and so forth. So that's the triangulation. So we can triangulate now in order to get more sense of how this algorithm will evolve. So let's go ahead back in our tests and write new test and see what happens when you have another city found. So we are gonna start again from the assertion. This time we are expecting a list of Bitola, the city where I was born, as a result, and then again the results gonna be coming from the searcher.search, and at this moment I am passing the query BIT. And one important point is that part of the criteria was that the query should be case insensitive, and that's something that we are gonna catch here. So I'm passing on purpose query that is case insensitive and it should match the city that starts with capital case. So that's gonna be, again, I'm gonna create instance of the searcher, and now I have the test compiling and working fine, so I can run it, and of course I'm gonna run and watch it fail. That's very important. Does it fail for the right reason? Yes, it does. I expect something, and I got an empty list in reply. So how do I make that work? Again, fake it till you make it. I'm gonna just add another else if, and here I would say if the keyword is BIT, just return list of Bitola. That will make the test pass. Now I can focus on refactoring this code, and definitely this is a time when I can start refactoring. But I don't have an evidence what happens when I have more than one city being replied for a given query. So when I have more than one match. But also in interest of time of this presentation, I'll just go ahead and write one more test to get proof of that one. In software, especially in TDD, procrastination is probably the only place where it makes sense. So the more you delay your decisions on like extracting things, making abstractions, that kind of things, the better you are. Sometimes, especially here, is easier to come up with just a little bit more duplication and then fix it, rather than come up with an abstraction that will be maybe wrong. It's gonna be cheaper to address the duplication. What's the duplication that I'm talking about? This else if that I'm adding, because here it is pretty much clear how this algorithm will evolve, just adding else if. So as I said back in the tests, let's write the test what happens when you have multiple cities found. Again, from the assertion, we are gonna expect list of, let's say, Newark and Newport as a result. And when that's gonna be happening, we are expecting that to happen when we search for keyword new on the searcher, and of course instantiate the searcher. Now the test is ready to be run. We run it, we watch it fail. Does it fail for the right reason? Absolutely. How do we make it work? Fake it till you make it. Just add an else if there, keyword is new, and then return list of Newark and Newport. Run the test. They are working fine. All four of them are passing. So now we can reflect to the code, and what do we see here is definitely a point that we can start refactoring. What do we refactor actually? How do we know what to refactor, what to do? The ultimate goal is to push the data up the call stack. And when I say up the call stack, I mean more towards the entry point of the program. At this point, the tests are exercising my program, so they are my entry point. So I want to push the data up the call stack towards the tests, and I want to keep abstractions in my shipping code. That's something that we learned in the pragmatic programmer. I think I'm not mistaken. So the first step towards pushing the data up the call stack is to group the data together and separate the data from the abstractions, and it's gonna be easier to move it around. You can take any approach to do that. The way I prefer to do it is take as little as possible small steps, like baby steps, and keep the tests running all the time during those little steps. I wanna make sure that I'm not breaking anything, and I'm constantly running the tests. So first of all, let's take a look at all the replies that I'm getting. So this is the responses that I'm getting as a reply from this search function. So what I can do, the ultimate idea is to group these together because they want to stay together, because they are part of the results. So the first thing that I can do is I can focus on the first result, let's say on the Rotterdam. And what I can do first, I can put it into a collection, and I can assign this collection into a variable. And of course, I wrote some code that is not being taken in consideration anywhere. It is not being used. But just in case, I make sure that I didn't break anything. So I'm just going to run the tests because I might have compilation issue and that kind of things. So as I said, this code is unused at all. So it does not affect anything. And now inside the if, what I can do, I can try to replace the hard-coded Rotterdam by abstraction, like try to get it from the cities. So how am I going to do that? I'll just take the first that contains ERD. And I'm gonna assign that into a variable. In this case, I name it match. And now here, so I'm just gonna run the test to make sure this new line is not breaking anything. Of course it shouldn't, because again, it is not being used, just in case I make sure. And here is the match. So I can now replace the Rotterdam, the hard-coded value, with a match that I found from the collection. And of course, run the test, make sure I didn't break anything. So as you see, I take as little as possible steps and run the tests in between. So now, if we take a look, we replaced one of the hard-coded things with an abstraction, and we have one to go, which is the ERD. But basically, this ERD is equal to the keyword. So if we just replace ERD with a keyword, we're going to remove all the hard-coded data inside this if. So that's one step forward. That's a good step. And of course, we make sure we didn't break anything. And we didn't. Next, we can focus on the following if, like the next if. And in this case, the result is Bitola. So what you can do, we can pull it in the initial cities collection that we came up with. So we are going towards grouping the data together. So we move this value in the initial collection. We run, make sure we didn't break anything. Then what I can do, the condition inside that if, I can pull it in the initial if, in the primary, the first one, and then I can say or that condition. And in that case, whenever I have the keyword bit, it will get into the first if. For sure. But here the thing is that I have to also keep in mind that bit is lowercase and the city name is starting with a capital case. So what I have to do, I also say that I'm gonna ignore the case. Of course, this is a language feature that comes with Kotlin. I'm just gonna leverage that one. I make sure I didn't break anything, so the tests are still working well. And what I can do now with the else if, I can absolutely eliminate it altogether. And of course, I removed it and I make sure the tests are still working. Now, if we reflect back to the match that we had before, one thing to notice here is that we are getting the first from the cities. But what we can do is, because we are essentially we are returning a collection of things, we can use another operator. We can use filter, and the filter is going to return a list of all the things that are containing the keyword and ignoring the case. In that sense, we are going to rename the match with matches, then we are going to return the matches. Again, run the tests, make sure we didn't break anything. And of course here, if we reflect, we have now a duplication that we can address. Not only that the matches are appearing twice, but also we have logical duplication. Basically, we are creating new variable all the time, assigning something to the variable and then returning the variable. Instead, what we can do, we can inline this, and we can directly say return cities filter and then whatever contains the keyword by ignoring the case. And of course, we run the tests to make sure we didn't break anything. There are basically 3 steps that you have to remember in this case. First step, come up with a new thing. Make sure you didn't break anything. Replace the old thing that you want to replace. Again, run the test, make sure you didn't break anything. Then delete the old thing. And again, run the test, make sure you didn't break anything. So just 3 simple steps that you follow and everything's going to be fine. So now, as I said, I make sure I didn't break anything. As you can notice, I'm running the test way too often. And that's good because at any point of time after each step, I want to make sure I didn't break stuff. And if I have like 2 or 3 steps in advance that I'm thinking that I want to take, that's fine. I can take 1, 2, 3 steps and then run the tests. It will be easier to revert for me if I reduce the time between running the tests. But the point here is that the tests are running very fast. Like at this moment on this machine is 48 milliseconds. It's like nothing. So that allows me to actually, it gives me the privilege to be able to run these tests. If I have flaky tests, if I have slow tests, no, people just don't want to run such tests, and that's a problem. Let's continue. Now we can focus on the last if condition, and basically we can also take a look at this result, which is the Newark and the Newport cities. We can pull them up in the initial collection again. And now what we want to do, we want to get into the first if condition. So now we have these 2 keywords that are like we have this or, but how do we make sure that we are going to enter this if? Well, we can just put true there. If true, we'll make sure that we are going to get into that if. Now we run the tests. We make sure that we are still green. And what we can do with the else if, of course, we can eliminate it. Again, make sure we didn't break anything. And now what we can do here, we have if true. Basically, the entire if condition is unused. I mean, doesn't make much sense. We can just eliminate that one. Again, run the tests, make sure we didn't break the things. If you reflect back to the function itself, what we have done, we have separated the data from the abstraction. Now it's easier to work with this. We can move the data if you want. We can do stuff like that. However, back in our code, in the tests, there was one condition left that we didn't take care of yet, which is the short query. What happens when we have short query? We don't want to make a search at all. So let's go ahead and write the test for that. What happens when you have a short query? Again, we start from the assertion. We are going to expect an empty list as a result whenever we search for RO. So RO is not long enough. And we are going to instantiate the searcher. Now we can run the test because it does compile. We run. We have out of 5 tests, 1 is failing. And does it fail for the right reason? Yes, it does. We are expecting an empty array, however, an empty list. However, we got Rotterdam back because RO is included in Rotterdam. So how do we fix this? Well, we can wrap the return into an if, and we can say if the keyword length is greater or equal to 3, only then perform the search or do the filtering. Otherwise, just return an empty list, and that makes the test pass. So now we're done with the test. That's fine. Back into our shipping code. One thing to notice, and you should always look for this thing in your code, is to move the variables or whatever you have, move it closer to its usage. So whatever you have, like call to a function, whatever, move it closer to its usage. That's going to allow you to spot things that can be, I don't know, emerged somewhere. Maybe they're asking you to create an abstraction, that kind of thing. So just move them and then watch what happens. So here, what I can do, I can move this collection of cities inside the if because it's only place where it is being used. Of course, I'm going to run the test to make sure I'm not breaking the things. And if you take a look into entire if inside, this is something that wants to live together, so we can extract a function out of this. So we are creating cities containing keyword function, and inside we have this collection and the algorithm. And we are going to keep this as a private function here in the searcher for now. We run the test, we make sure we didn't break anything. And back into initial search function, what we can notice here, we are mixing levels of abstraction basically. So we are working with functions like cities containing and empty list. However, we are also checking length on a keyword, which is way lower level of abstraction compared to the other things happening in this function. So what we can do, we can also extract a function out of it, just a little check function. So this is it's just gonna check if the length is greater than 3. So it's sort of validation point. Run the tests to make sure everything is working fine. Now, if we reflect back to the entire to the initial function, the search, we can see that actually it looks kind of okay. However, what's wrong here is we are violating the single responsibility principle. Why do we do that? Because in this class, what we do is we are making the validation of the query, and we are also performing the search. So there are at least 2 reasons to change this class. If you want to change, let's say, the length of the query, if you want to change the way we are filtering out the cities, let's say now it is containing, what if we want to do it with like starts with, there is another reason. So we have at least 2 reasons to change this. So what we want to do, we will continue refactoring towards getting rid of the single responsibility principle violation. So the first thing that we can do is this is sufficient length. We want to push it out from this class. So how do we do this? First, we are going to create a class here internally inside this initial class in the searcher. At this point, it is unused, and we can just paste the function is sufficient length inside. And of course, this is unused, like nothing is used. So adding this thing is of no consequence. Still, we just make sure by running the tests. And now, inside the initial function, what we can do, instead of calling this sufficient length that is part of the searcher, the function, we can create an instance of the keyword check and call the function in there, inside. We also make sure we didn't break the things, make sure everything still works. And now what we can do with the class that we came up with, we can extract it outside of this. So it's gonna live into its own, into a standalone file. That's good. We'll come back to this a little bit later. But now if we go back to the searcher, the function is sufficient length is not being called, so it's unused. What we can do, we can delete it. And again, make sure it doesn't break anything. But back to our search function, what we've introduced here is a logical duplication, because anytime we call the search, we're gonna make new instance of the keyword check. That's a logical duplication. That's not very like performance-wise okay. We want to address that. So what we can do? Well, we can inject it as a constructor argument. You may say, why? Why I'm not, let's say, making an instance inside the searcher. So whenever I make a instance of the searcher, it will make new instance of the keyword check. The thing is that now I'm working alone, so I'm making the decisions alone. If I was pairing with you, we would have made that decision together. The point here is that given a chance, do pair programming, do mob programming. These are some things that you are gonna do together, and those are important things. So that's the moral of the story. So now I'm injecting the keyword check. I'm calling the keyword check as a collaborator. And of course, to do this, I am using the automated refactorings from the studio that I'm using. Whenever you have a chance to use automated refactorings, leverage that. That's a lot of work done for you by the studio. If you don't have it, then you can consult always the book from Martin Fowler, which is the refactoring book. But yeah, as I said, if you have a chance, use the studio itself. Make sure everything's still working. And as I said, we're gonna get back to the keyword check. Basically, the problem here is that still we want to push the data up the call stack. So this tree hard-coded here is a configuration. So what we wanna do, we want to configure this class on instantiation level. Like whenever we are making new instance of the keyword check, we want to be able to configure it properly. So what we can do, we can push this also as a constructor argument. And whenever we are instantiating keyword check, we can pass that configuration as an argument. What's going to be the minimum required length? We make sure everything is still working. And if we go back to our searcher, now we have the initial search function, and inside we have the cities containing. But more importantly, if we go back to our tests, now I'm showing one because it's gonna be too much if I show all of them in one slide. What I wanna show here is this keyword check tree being passed as a constructor argument for like instantiating the searcher, and that's reflected in all the tests. The point is that because I'm using automated refactorings, all this work is done for me. That's what I wanted to say. Now, in the searcher, the cities containing is also a function that, first of all, we want to push that data that we have inside the collection. We want to push it up the call stack, but also we want to align the levels of abstraction inside the searcher itself, so we can do, again, the same steps that we've done with a keyword check to push this into another collaborator. But in interest of time, I'm going to skip all the baby steps. I can just assure you that I've done all the steps, but basically what I came up with is a class that I named city catalog. It takes the cities on a creation level because the cities are sort of the configuration of the class. And then the algorithm is just the cities containing inside is the algorithm to filter out the things. And as you can imagine, out of this class, what we can do, basically we can extract an interface and then we can have different implementations, that kind of things. That's something that we don't have approved, we don't have a need now. That's just a class. All fine. In the searcher, I'm injecting both collaborators, and what I have in my initial search is very simple, very basic condition flow here, if else, like control flow, and I'm just consulting the two collaborators that I'm injecting. More importantly, back in my tests, again, the city catalog and the configuration for the city catalog has been emerged. Like you see, we pushed all the data towards the tests, and that was done mostly by the studio itself. One thing that I want to point out here, let's take a look at the multiple cities found, is we have the arrange, act, assert. So if we go part by part, what we are doing, we are constructing a searcher by passing a keyword check that mandates at least 3 characters as a query length. Then we have some city catalog that takes some cities, and 2 of them are Newark and Newport. When we search by passing keyword new, we should get back list of Newark and Newport. And what I'm trying to point out here is that the relation between the data that we have in the arrangement and in the assertion makes total sense given the act here. And that this test, in that sense, is very sort of clear. When you take a look, it's super easy for you to understand what's going on. You have some arrangement of, like, from the arrangement and the assertion, it's easy to understand what's the API of the system and how does it work. And that's the essence. That's the point of like having small tests that are gonna reveal their intent and be clear what they're testing. So to recap, as we saw, TDD was never meant to be hard. It should be an easy thing. But of course, in order to get to that point, you need a lot of practice, and you have to have a good knowledge and understanding about design and design principles, architectural principles, if you will. So the more you learn, the more you know about the architecture in general, the easier it will be for you to work with TDD on a TDD way. And when they say about advanced TDD, when people talk about advanced TDD, there is no such thing as advanced TDD. The advance in the test-driven development is like your ability to listen to your tests when they're telling that, okay, this thing that you are testing is hard to test because like when you see something hard to test means that something in your structure is wrong, some API is wrong. So when the more you learn to listen to those signals from inside your test, that's sort of the advanced in the TDD. There is not such thing other than that as advanced TDD. Of course, I want to share some resources with you. The first one is the comparative case study. It was recorded by Uncle Bob and Sandro Mancuso. And the objective of this one is to make a comparison between the London School of TDD and the Chicago School of TDD. It's very interesting. I can recommend that one. Then the other one is the world's best intro to TDD, and this one really is the best intro to TDD in the world. It is by JBrains, and good portion of it is for free. Just go ahead, check it out. You won't regret any money that you're gonna spend here. I couldn't recommend this one enough. And of course, my own test-driven development screencast. I share a lot of these kind of things on YouTube. I am trying to publish weekly episodes, so you'll find a lot of things that we spoke about today and some more in there. So go ahead and check it out. Everything is for free in there. Of course, there are some books on TDD. The first one is the Test-Driven Development by Example, written by Kent Beck. The other one is the Growing Object-Oriented Software Guided by Tests. And those two are the best, for me, the best books on test-driven development. Probably there are more. These two are just my favorite ones. And as I said before, books are great, resources like that are great, but practice makes it perfect. So the more you practice yourself, the more you're gonna learn. So that's gonna be about it. Thank you so much for the time and attention. Find me on the internet. My DMs are open. Please shoot me any questions that you might have. I'm gonna be more than happy to answer them. Thank you.
Well, amazing talk by Job. Job is here with us, but he's having his children jumping over him. So he's not going to answer QA right now, but of course you can write him. I suggest you to follow his episodes on YouTube. He has an amazing channel with episodes talking about TDD, and that's what Job. Should we move on, Alex, with Mario?
I just want to make one comment that really resonated with me in Job's presentation. This is something I call viscosity, which is the opposite of agility. And rightly so, he points that TDD helps us detect viscosity, because he says, okay, I have to test something with this. It's really, I'm like walking through molasses, right? That right there is a signal that you need to go back and refine your design. Something is off in your system. You cannot proceed quickly with the new test. That's a really takeaway for me from Job's amazing presentation here. There's so much to unpack here. I'm sure we'll be going back and rewatching and following his steps. Thank you, Job. Over to you, and take it away, Maxi.
Okay, well, next speaker, I hope he's going to talk about viscosity, because Mario is a software engineer from Spain. He's been working a lot on TDD. If you follow him on Twitter, you will see that he writes a lot about clean code and has a lot of wonderful comments there. And in his talk, he's going to talk us about our worst enemy. I think it's coupling. And hopefully he will also talk about viscosity and the problems we have when we deal with a big system. I don't want to spoil. I hope he goes that way. So Mario, come in.
Hello everyone. Thank you, Maxi, for your kind words. I hope I can live up to the expectations. I feel really honored to be here. I really hope everyone can at least learn a couple of things from my talk. Let's see if I can share my screen, because I still didn't do that. Let's see. I think it's okay, if I am not mistaken. Okay. Let's see. You cannot see me, I think. Well, anyway, can I have some feedback in the chat? Okay, yeah. Is everything fine, Alex? You can all hear me? Yeah, okay. I am reading it in the.
Sorry, Mario. Would you like to have the full screen of your slides, or you want yourself on the side?
Actually, I don't mind if it's fine just the slides, but I can, if my face is shown, I don't care. Both things is I don't need a really big screen, so I can display myself. It's okay. Thank you very much. Well, hello everyone. I am. He already presented me. I am Mario Cervera, and the first thing that I wanted to do in my presentation is very quickly go over the title, because being honest, I think that the title is maybe a little bit academic. It reads like an academic paper, right? So very quickly, I wanted to walk you through some of the keywords of the title so you can get an idea what this talk is going to be about. The first keyword, the first word that I wanted to highlight is the word robust. This talk is going to be about how TDD can help us write robust tests, or in other words, tests that are not fragile. I will use these two terms interchangeably, fragility and robustness, to mean exactly the opposite thing. Okay. So this talk is about how TDD can help us write tests that are not fragile, which means very quickly, because later I will go in more detail, which are fragile tests are tests that break when they should not break. So they start causing us more trouble than help. So we definitely want to avoid fragile tests. And in this talk, I will also talk about the notion of unit, which is the same concept. I mean, the word unit from the concept of the notion of unit testing, okay? And also the concept of coupling, which is the same coupling that we can have between, classes, functions, modules, any kind of code structure. Because these two terms, we will see in the presentation that they interrelate, they are related, and they impact the fragility of the test. So this talk is about how understanding this concept will help us write tests that are not fragile. Okay. Very quickly, just a little bit of information about me. I am a software engineer I've been roughly 15 years in the software industry, working in different private companies. And the last 4 years doing quite a lot of TDD, which is not very long time, but I think it's enough to get the idea of the pros and cons of TDD. Currently, I am mainly developing real-time software, desktop applications in C++, but I've developed other kinds of applications in other languages such as Java, Python, JavaScript, etc. I have a PhD in computer science, and I am also currently teaching software engineering classes in a private university. So this is quite nice because I have the possibility to see how testing applies in both contexts and see the difficulties that students and people in industry, the difficulties that they experience both with automated testing in general or TDD in particular. If after this presentation you want to contact me and ask any question about the presentation or discuss anything about TDD or other software engineering related topics such as clean code, software design, and all the design principles and so on, I will be very, very happy to discuss with you. My DMs are always open, so you can I invite you to write to me and discuss anything we want, because I always love to talk about software engineering. So I will be really happy to talk with you. My handle is Matherup. I think it's the easiest way to find me online, because I am quite active user in Twitter. Okay, let's delve into the details of the presentation. The first thing that I wanted to do is detail what are robust tests, or what are fragile tests in this case. Robust tests would be the opposite. A fragile test is basically a test that is not robust. Okay, it's a test that fails when it shouldn't fail. Okay, tests sometimes fail, but that's normal. I mean, tests are a specification of behavior. So when this behavior changes, whether it is intentional or it is not intentional, but when the behavior changes, we want the test to warn us. We want the test that specify that behavior, that enforce, that assert that behavior to fail, because that's a very good way to prevent bugs. If we modify the code and behavior changes, but we didn't want to change it, if a test warns, if a test fails, the test is preventing a bug, because we are seeing that we're changing some behavior that we didn't want to change. But what happens when a test fails and it shouldn't fail? When we are intentionally modifying the code to improve its structure, its internal structure, when we are refactoring the code, we are adding classes, deleting classes, renaming variables, defining functions, all these kind of things, but we are not changing the external of the observable behavior of the software. And the test still fail. That's bad because they are making refactoring harder while they should be making refactoring easier. So the promise that test will make refactoring easier is not being met. They are making it harder. So we want to avoid at all costs fragile tests that fail when they shouldn't fail. So fragility is a very important thing to avoid. We will always want to have tests that are robust, tests that fail when they should fail, not all the time, because that forces us to continuously update the test when we should be saving that work and not wasting time updating the test when behavior is not changing, okay? And here is the first time that we see in this presentation, aside from the title, the word coupling. And I am highlighting it here because coupling is the main cause of fragile test, okay? So here I am going to explain a short, let's hide this. I am going to show here a very quick example to illustrate the concept of coupling, okay? Let's imagine that we have three classes, A, B, and C, which are A is associated to B and C, and we have some test or one test that is going to test this code that we have here split in these three classes, okay? This is a test that we could very reasonably write. It's a good test, a test with three parts: the arrange, the act, and the assert, which are the three classical parts of tests. And let's suppose that the arrange part accepts the following expectations: that when A is called, a method from A is called, we expect that B is called twice without parameters and C is called once with X as a parameter, okay? When a method from A is called, if the expectations are met, the test will pass, and if the expectations are not met, the test will fail. That's a reasonable test to write. It can be a very good test, but what are the implications of this test? The implications are that the test is highly coupled to the system under test, in this case, the three classes. Why is that? Because if you pay attention to the test, you will see that the test is aware of the existence of the three classes. Okay, in this case, B and C will probably be mocks. So here the unit under test, this concept will also be important in this presentation. The unit under test here is only the code in A, okay, because B and C are mocked. But this doesn't change the fact that the test is aware of the existence of B and C, which means that there is a high coupling between the test and the system under test because the test knows all the details, okay, all the implementation details. And this is called in the literature in some books, for example, in the XUnit test pattern book, which I will talk more about this book later in the presentation. This book explains a testing smell that is called overspecified software, which is exactly what is happening here, because what test is a specification of behavior, and in this case, the test is specifying.
Mary, we're getting some scraping noises. I'm thinking it might be the microphone on your earbuds rubbing against your shirt when you move. Can you try holding it away or something?
Perfect.
Okay.
That's fine.
See if that fixes it. Okay.
Thank you.
Back to you.
Sorry for the inconvenience. I hope you all this could understand what I was saying. In any case, what I was saying is that overspecified software, what it means is that the test specifies so much. For example, in this case, the test is specifying the exact algorithm in A, because the test is specifying that when a method in A is invoked, B will be called twice, C will be called once with the exact parameter. I mean, the test is specifying how A should behave, not what it should do of the results that it should obtain. Okay, so here, this is why it's called overspecified software and why the coupling is high, because the test knows a lot of the implementation details of the system under test. But this is not the only possibility. We could also have this other kind of testing. We could have a test that simply invokes A and doesn't know anything about B and C. In this case, the unit under test would be bigger because the code invoked here would be A, B, and C. When the test is invoked, we will end up executing code from A, B, and C because here we don't have mocks, and here the unit is bigger. But this is the very notion of encapsulation. The test only knows B. only knows A, sorry. B and C are implementation details. So here the coupling is lower, and we can change, we can delete B, C, add new classes inside of the unit, and the test need not be updated. And this is a good property of this is robustness. Okay. So here we are starting to see that the notion of unit can be important, because before we have a smaller unit, just A, and the coupling was higher. And here is the opposite thing. Okay. So this leads to the question, what is the right size of a unit? Okay. This cannot be answered just in this example because it's very abstract, but I watched once a talk by Sandro Mancuso, which I recommend to all of you because very, very illuminating, that is called Does TDD Really Lead to Good Design?, where Sandro Mancuso explains a good way to answer this question. I am going to reproduce it here. Basically, what he says, imagine that we have the same 3 classes as before. Okay, we have different possibilities. We can have 3 units, but we could also have only 1 unit. So how we made the decision? Okay, this will all, of course, depend on the context. But we could, for example, do the following analysis. Let's imagine that the associations that we have here between A and B and A and C are the type aggregation. If you know some UML, okay, you will remember that this implies that B and C are not part of A. They are separate. For example, imagine that A implements the code from a checkout process in an e-commerce application. Okay, the checkout process is a complex process that has several steps. One of them can be, for example, the sending a notification to the user, and another one can be the payment process, which is quite complex in itself because it has to, the payment method, Visa, credit card, PayPal. It's important the country you are in, this kind of things. So we can put this logic in different classes. Class B can be the helper that deals with payment, and B and C can be an email service, for example. But here, if we incorporated the code of B and C into A would not be cohesive because it would have all kinds of different unrelated logic. So in this case, it makes sense to think that we will want to test A in isolation and mock the ML service and mock the helper that implements the payment, the process of payment. Okay. But we will also have a composition relationship, which is kind of the opposite when B and C are more part of A. For example, imagine that we have an algorithm for calculating taxes, for instance. In this case, the algorithm will have to take into consideration your marital status, your sources of income, the total income per year, whether you have children or you don't, all these kind of things. These checks, this logic can go in different classes. But if you didn't do that and you put everything into A would be reasonably cohesive because all of the code would be working towards the same goal. All of the code would have the same responsibilities, so to speak. So in this case, it might make sense to consider everything as a unit. Okay, I am making everything up. It's just an abstract example, but the important point here is not the specific example, just that we are making an analysis, a reasoning, thinking exclusively about the structure of the code. We are not thinking about we are thinking about behavior, but the main driver of our decision is the structure of the code. We have 3 classes. Each class has these responsibilities. We mock some of them. We don't mock them. This decision is based on the code structure. And this is a very common way of thinking in outside-in TDD, which I will explain in a moment if you don't know what that is, so don't worry. This kind of thinking about the code structure is very common when you are following outside-in TDD, okay? Outside-in TDD basically is an approach where you start writing your test. Here is represented from up to down, and you start in the outer layers of the system. Okay, you write here, you write a test, you write the class that makes the test pass, but the dependencies of this class you don't have them yet because you will write them when you in a test that is not written yet, that you will write a bit later. So you have to mock this dependency with a test double or a mock or however you want to call it. So in this approach, you mock all the way towards the inner layers of the system. That's what is called also a mockist approach. But the important point here is that in this approach, in this step of the way, you think about the responsibilities of the classes, and you use the test doubles, the mocks, as a design tool to design the interfaces of the classes that you are going to write. But you are always thinking about the structure of the code in this sense, because you write a class, you think about its needs, you write the other classes, you think whether you mock them or you don't mock them, and that's the way you think about the development of the system. Okay, but this is a very good way to work, but it has some problems that I come across several times in my career during TDD. Okay, and a common problem that I've seen is the following problem. These classes here sound perfectly, and they are perfectly reasonable, but have a look at this fact. In this code base, every class has an associated test class. Okay, the implication of this is that the structure of the code and the structure of the test are parallel, which means that we cannot refactor the code. We can refactor it, but if the refactoring implies changing classes, adding classes or removing classes, we will have, by definition, we will be forced to update the test. And this is not the ideal situation, because we will want to be able to refactor without updating the test. And here this cannot happen, because you will have to keep the structure of the test at the structure of the code parallel. So this is very common when you are thinking about the structure of the code. When you add a new class and you consider that the sufficient reason to write a new test, or you add a new function and you write a new test, that's not the way to think about testing, okay, as we will see in a moment. Another problem that I came across recently, due to developers thinking about the structure of the code, is, for example, this example, which is C++ code. But if you don't know what this directive means, basically what this is doing is changing the private words. They are changing them for public words before compilation. This is because the developer wanted to test the private functions and wanted to make them public. And that's bad, because private functions are implementation details. So if you test those, your test will be coupled to the system under test, and implementation details change a lot, so your test will be fragile by definition. So you don't want to do this. You don't want to test private information, and these kind of mistakes are a consequence of thinking too much about the structure of the code. Okay. The last thing that I'm going to say about the structure of the code is that the XUnit test pattern itself, which talks about outside in TDD, recommends that when you can always go back when you have these classes implemented, you can always go back and remove some test doubles, some mocks, to make your units bigger and make your test more robust. It doesn't mean that you will always do that. It's just that you you can consider that as a possibility to try to improve or to reduce the fragility of your test. Because if you follow a purely mockist approach, you might end up making an intensive use of mocking, and if you use mocks too much, your test will be fragile because they will be coupled to implementation details, as we saw in our example. Okay, so there is another way to think about TDD, which is a behavior-centric view, which doesn't focus on the structure of the code, but rather focuses on behavior. I learned this from this awesome talk by Ian Cooper, which has a very beautiful quote that I love that illustrates this problem very well. He says that adding a new class is not the trigger for writing a new test. When you add a new class, add a new function, that's not the reason to add a test. The reason to add a test is because you have a behavior that you want in your system, that you want to implement. You have a requirement, so you write a test for that requirement. Okay, that's important. And this is the point in classic TDD from the beginning. In the canonical TDD by example book by Ken Beck never uses the term unit testing in the book, other than one time, just to refer to say that the tests in classic TDD are not unit unit test, okay? Because a unit test is a test that by definition you have to isolate from other units of code, and you have to use mocks for that. So your test will be to some extent coupled to the implementation's details, and this is not the ethos of TDD, okay? The way to think in classic TDD is to think about behavior, not about units of code. In TDD, you think about units. When you think about units, you think about units of behavior, which are the test. You are the test to run in isolation from other tests, not units of code in isolation from other units of code, okay? This is an important distinction and a mindset change that is really, really relevant. And if you read this text that I am showing when I have the image of a book is because it's text extracted from the book, okay? So in this case, Ken Beck illustrates this very well because he always uses the word behavior, and when he writes about tests in the book, they are tests focused on behavior. He writes, we need to be able to add amounts in 2 different currencies and convert the result given a set of exchange rates. He doesn't say we need to invoke an add method in a money calculator class. He doesn't say that. There is no requirement that gave you that. That is the way that you have to access the behavior, but the behavior is at a higher level of abstraction, okay? And the TDD cycle, as explained in this book, matches this idea, because the idea is to write a test thinking about behavior, and when you do that, then is the moment afterwards, after thinking about behavior, to invent the interface that you wish you have, an interface that will make the behavior readable and very expressive in the test. The test will be a specification on behavior, very intent revealing, because the behavior, the implementation of the test will be focused, and your interface will be focused on behavior, which is the important point here. Okay. For example, this idea gave rise to some notations, such as the famous given, when, then, where we can write tests, for example, behavior-oriented tests, for example, in this way. Given 2 positive integer numbers, when we multiply the numbers, then we time the correct multiplication as a result. That's a very reasonable way to test. We don't write a test full of implementation detail, such as 32-bit integer numbers. We invoke a multiply method on a calculator class and obtain the result as a 32-bit integer. We don't write that because that has a lot of implementation detail. By definition, implementation details change a lot. Behavior is more stable. So if we write our tests in terms of behavior, they will be more stable. And this is what led to the emergence of the term behavior-driven development, which is basically nowadays have this connotation of these tools like Cucumber, when we have a domain-specific language for specifying a certain criteria and all of this. But originally, behavior-driven development was trying to emphasize this behavior-driven approach in TDD, which it has from the beginning. So in some sense, BDD can be considered the same as TDD. TDD don't write, basically. Okay, so I am finishing my presentation, but this is all good and fine, but you can reasonably say that, okay, I think about behavior, but I still have classes and I'm going to code, and I cannot avoid thinking about the structure of the code, and my tests always end up being fragile because I cannot, have this mindset change. So I wanted to illustrate here how the TDD flow goes and how the design and the classes emerge from this flow to be less coupled to the test. Okay, let's imagine that we are in the red phase of TDD. This means that we are a test. We are thinking about some behavior that we want to implement, starting from the basic behavior, because we believe that in this with this behavior I can make the test pass easily because it's an easy one. Okay, so in the green phase I write I need an element of code structure to access the behavior, so I add a new class A with a public method. Okay, in the refactoring phase I am just starting, the code is still not messy, so I don't do anything. New red phase, I add another test, which I can make it pass in the green phase, for example, adding some conditional to to the public method, for example. Now the code has more is bigger, is messier. So I want to refactor it a little bit. So I extract some private methods, for example. I add a new test, I make it pass, adding more code to A, for example, and now in the refactoring phase, I say, okay, A is starting to get a bit more messy, so I am going to refactor and extract, for example, classes B and C. This point is important. We don't write new tests for these classes. These classes are implementation detail that the test need not know. They didn't know about this code when it was in A, so they don't need to know now that they are in different classes. So now we see a unit of code emerging here. This is where the emergent design comes in. Okay. New red phase, I add a new test T4. In the green phase, for example, I add a new class D with a public method. And in the refactoring phase, I can, for example, refactor the code and extract another private method, for example. Red phase, I add a new test. In the green phase, I make it pass, writing some code in D. And now in the refactoring phase, I say, okay, the code in D can be refactored a little bit. And I realize that I can create a new class E and also make use of class C, which in turn might make me realize that C can further be refactored into another helper F, for example. So now we see how the units get bigger and how we have different units of code. But this code is emerging in the refactoring step, okay? So these classes are really implementation details. The tests do not know about these classes. The tests are units of behavior that are decoupled from the system under test. Okay, this is how the TDD is more complex. This is just an abstract example, but the gist of the idea is the thing that I am going to try to show here. Okay. And just to finish my presentation very quickly, some key points about the presentation. First of all, I wanted to highlight here that, as I said several times in the presentation, high coupling leads to fragile tests that impede refactoring. This is super important because I've been in many teams that have tried it, and I have spoken with many people that have tried to adopt TDD or to write tests, and in the beginning it's everything fine, but after some time tests become a burden because they are hard to maintain, and this is always high coupling. This is always fragile test that we need to avoid because in my opinion, is the most common reason to abandon testing. And it's a shame because tests, when they are done, when they are decoupled and when they are useful, test is what allow us to refactor. This is what they allow us to improve quality over time and maintain quality. So tests are a key part of the system. It's code that is even more important than production code, if you ask me. So we cannot let them rot. We cannot let them be highly coupled. Tests need to be designed in the same way that the production code. And design implies following design principles, low coupling, solid principles, and so on. Okay, so very important point. Whenever possible, we should try to avoid focusing on code structure, which we will not always be able to do because outside in TDD, sometimes is appropriate, of course, but as remember what we said, you can focus on code structure when you are doing outside in TDD, but that doesn't mean that you cannot go back, delete some tests, update some tests to make them less coupled by deleting mocks and make your units bigger. But whenever possible, you can switch to classicist TDD, which is the way the classic TDD is the TDD that is explained in the book by Ken Beck. And when you are doing classic TDD, you will want to focus on behavior. And the test and the behaviors are the true units of isolation in your development process. Okay. And finally, the last point to highlight very important point that refactoring is the key. In my opinion, refactoring is the key step in TDD. Is when design emerges, is where we improve quality or we maintain quality, and especially is where we identify the code that is public API, that is the stable contract of our system, that makes our test readable, and on the other hand, the tests that are implementation details that the test need not know, because they are implementation details of the system under test. So this is very important. In the refactoring step is where we identify which code is, we extract the classes and the functions and all the code that will be implementation details. So it's a key point in TDD, it's a key step in TDD. And as I said, this is the way that we obtain tests that are decoupled from the system under test. So well, this is it in my presentation. I just want to add that thank you for your attention, and I of course can answer any question that you have either here or in Twitter. You can contact me, and I will be very happy to talk with you and answer any question that you have.
Gracias, Mario.
De nada.
De nada. Awesome talk.
Thank you.
There's been a lot of comments, of course, and I was having trouble keeping track of your talk and other comments. But basically, what you drive home, the point you drive home, is very important, because I can say from my experience, I'm teaching TDD dojos and TDD, that inexperienced people always like to map one-to-one. Here's a block of code, a structure. It needs to have a test. And this mapping is fragility, brittleness, and all the other problems that we have. Now here we had a little bit of discussion back and forth, and I think you managed to clear it up, but just in case, about what is a unit. And again, we had that discussion before, and then there were some light bulbs and some epiphanies with unit of expected behavior. Right. But again, I think on the testing pyramid, it could be interpreted differently. We also had a few chats here Dave Nicolette pointed back to GPAW's micro tests. And personally, I kind of I gravitate towards micro test, because I don't have to wrangle with what is a unit. What do you mean unit? Is it, it's a micro test. It just has to be done with quickly. Increase the speed of feedback. Do you have any preferences, or is it okay if we leave it like that?
Yeah, I think one thing that I didn't say in the presentation, I am happy that you bring the topic, is that unit, I tend to avoid the term unit because it's very confusing. Of course, if you are thinking about the structure of the code, for me, a unit can be actually anything, a class, a function, a set of classes. So it's actually a subjective term. So in classic TDD, the unit is for me the unit of behavior, right? And to make that distinction, I have seen different terms used. For example, you've said one that JIPA uses the term microtest, for example. In the TDD book, in my presentation, you could read a small scale test, for example, that TDD write that term in the book, or Ian Cooper, the person that did the talk that I referenced in my talk, which is a talk that I love and I recommend to everyone. He always talks about developer tests, and he explicitly says that he avoids the term unit testing because unit test is a test that tests a unit of code, and TDD does not do that. I mean, when you do TDD, your tests end up testing units of code, but just because a unit of code is anything. But when you are doing TDD, the tests that you write are not unit tests, are developer tests, small scale tests, or micro tests, or however you want to call them. But one of the points in my presentation is to try to show to people that common misunderstanding because you tend to focus too much on code structure. And when you do that, you want to test private methods, you want to add a test class per production class, and all these kind of test smells that prevent you from having robust tests, which is one of the points of my presentation.
Thank you. And if we go down the memory lane, if memory serves, the early days we were talking about programmer test and customer test.
Yeah.
And how do you tie that into behavior, unit of behavior? Because customer test is also unit of behavior, right?
Yeah. Customer test, for me, the thing here is that in a software development process, of course, you are going to talk to the customer, and the customer is going to specify the acceptance criteria and all of that. And the acceptance criteria is what you are going to extract the desired behavior from there. And behavior has different levels of abstraction. So for me, a behavior-oriented test can be a low-level test if the behavior is quite internal. But if you go up in the abstraction layer, you will end up having a customer-oriented behavior, so to say. So in this sense, for me, the distinction is just the distinction between when you say customer test is just to say that you are specifying customer behavior that is visible by the customer directly, because sometimes we have behavior that is quite internal and is not so easily mapped outside of maybe these internal layers of the system. So it's all a matter of levels of abstraction for me.
Yeah, and just quickly, Avi has a question, does a micro test require microservice? No.
Does a micro? No. Actually, for me, a microservice is an is a way to implement something. I mean, you can have micro test, developer test, or anything in a monolith application. I mean, a monolithic application can be very well designed internally, and you might have very clear boundaries splitting your architecture. How you physically represent that, whether it's split in microservices or in different. For example, I am nowadays working on a desktop application in C++, and we split the application to make plugins in different dynamic libraries, in DLL files. But that physical representation does not impact my architecture. I actually, within the DDLs, the dynamic libraries, we have different modules and different architectural layers within the libraries. So the library is just some way to deliver the system, but the physical way. So to say some way, but that's the same way I look at microservices. How you implement. You can have microservices and a rubbish architecture. That is not related.
One last thing, and we are a bit over time. Michael Feather says, I don't know what is a unit test, but I know what it isn't. It doesn't access disk, DB, or any other IO.
Yeah, I have a point about that, and I said that in TDD, unit test is a concept that does not match very well TDD, because in TDD you need to use in unit testing you need to use mocks to isolate the units, but there is a very good reason to use a mock in classic TDD, which is perfectly reasonable, perfectly good, which is when some external sources, such a database, are introducing indeterminism or making your test slow. In this context, you use a mock to prevent these problems, not to isolate unit of code. Is an important difference to be made there, because in this case you use mocks in a classic TDD, but that's perfectly fine because your goal is to make your test faster, or maybe the external source is introducing indeterminism in your test or brittleness, things like this. So that's a perfectly valid way to use. So in this sense, the Michael Feather's book says that unit tests are not tests that do not access external, like the file system, but the reason is speed. And I think that is perfectly matching the TDD workflow.
Awesome. Thank you so much, Mario. This is a very impactful presentation. A lot of us learned a lot.
I hope so.
Yeah, and it's going to help people and really makes a crucial difference. Now we need to carry on. Thank you so much. And over to you, Maxi.
Bye-bye.
Bye-bye. Thank you very much. Amazing talk by Mario. I think I'm going to play it back a lot of times. Mario has several layers on anything he says, and we read it and reread it again. And what he says about coupling and behavior is amazing. Next talk will be the last one before we can go to a small break. And I'm introducing Dani Moka from Hungary. Dani is a TDD enthusiast. He writes a lot about software quality. He's been developing .NET applications on the cloud. And if you follow him, you can see that he's always aiming for quality and has very, very small tips to increase your quality and your clean code. And he has a lot of very small advices I like a lot. And I'm not going to tell you what his talk is about because I don't want to spoil it. So, Dani, if you can get in.
Yes, I'm here. Thank you very much. Can you hear me?
Yes, Dani.
Yes, you can.
Yes, we can.
It's clear. Very good. Thank you. So maybe I can get started. Yes.
Yes.
Just a second. Share screen. Okay. And here we are. Can you see the screen or?
Not yet. You can remove me.
Can you add it? Wait. Let's add myself. Yeah, I can add myself. Yeah, I did it many times today. Okay, cool. So here we are. First of all, thank you very much for everyone who is still here at this late time. I'm really happy to be part of this amazing conference. And yeah, my name is Daniel Moka. I'm interested in everything which is related to software testing, software design. Of course, I'm a big fan of TDD, test-driven development. I'm on a sort of mission in my life to raise the software quality standards worldwide, to make best software engineering practices more widespread. And yeah, I do my best to help individuals and companies to produce quality software. And the topic of my talk today is TDD Manifesto. I am the CEO creator of this TDD Manifesto, and yeah, in this presentation, I'm going to show you what it is and yeah, what it is about. Let's go on. Yeah, table of contents. First of all, I'm going to talk about the motivation. Why did we create a manifesto? What are the ideas behind it? What are the reasonings? After that, I'm going to present the sections of the manifesto, because the manifesto consists of several sections. So I'm going to talk about them shortly. After that, I'm going to show a demo about. We will go to the live manifesto. We will see what it contains, how it looks like. And after the demo, I'm going to show you a bot we created called TDD Manifesto bot. After that, short part about let's improve, just to practice continuous improvement. And last but not least, I'm going to talk about the conclusion, and I will sum up my talk. Yes, motivation. So what is the motivation behind this TDD Manifesto? First of all, it is the 20th anniversary of the Agile Manifesto. The Agile Manifesto was published 20 years ago, describing and uncovering better ways to produce quality software. So that's why we thought maybe it is time to come up something similar to the Agile Manifesto, but in the context of test-driven development. Next to that, there are a lot of misunderstandings in the space. I think, yeah, Olena Borzenko had a really amazing talk about this already, so whether we learned a lot from her. But yeah, there are a lot of misunderstanding in this space. So we wanted to make it clear, wanted to clarify the misunderstandings, and also exposing the myths about test-driven development. So it is also one of the reasons we created a manifesto. Next to that, yeah, we haven't found such manifestos so far. We have found some articles on the internet which more or less describing the main values of test-driven development, but we haven't found anything which is compact and which is linked to a website. And also, yeah, we haven't found such a manifesto, but also there were no such thing TDD conference in the history, TDD International TDD conference. So that was also a trigger. We organized this conference. And last but not least, I'm lately surrounded by amazing software professionals who became my friends. I met with them on social media, and so yeah, I just decided they are all amazing people, TDD enthusiasts and amazing professionals. So I decided to group all of them, put them in a Discord channel, and to create something amazing, which is called TDD Manifesto. Yeah, let's see what are the sections. First of all, yeah, the TDD Manifesto contains of 6 different sections. First of all, the values of TDD, describing the main values of TDD, what are the advantages of using them, why we are practicing test-driven development. Next to that, there is a section where we talk about what is not TDD, what is not TDD used for. After that, maybe the most important part of the manifesto is a getting started section. Next to that, a clean test, talking about a bit clean test, how it looks like, what is clean test, how we can ensure to have clean tests, and why we need to strive for writing clean tests. After that, exercises, of course, because practice makes perfect. And last but not least, we have a section about us, a generic section. Next. Yes, demo, it's demo time, right? So I'm going to show you how this TDD manifesto looks like, and also just check it out, the sections, and what is it about. Just a second. So I'm here. It's really straightforward. We just have to write tddmanifesto.com. And here we are. It is a simple website, but compact, containing all the sections I already mentioned. Let's go through them quickly. First of all, values of TDD. Here I'm going to read them out because they are the most important parts of TDD, and those are the reasons why we are practicing TDD. First of all, baby steps instead of large scale changes. Next to that, we practice continuous refactoring instead of late quality improvement. We write automated tests instead of following manual test scripts. We have executable documentation instead of static documents. And last but not least, by practicing or by following TDD, we produce minimalist code instead of a gold-plated solution. So these are the main values of TDD. Of course, there are many other values and good things and advantages of using TDD, but we thought these are the most important ones. Next section, what is not TDD? So as I already mentioned, Olena Borzenko had an amazing talk. So if someone missed it, please check it out. Over there, we had a lot of good information about this, but here we also described some main things. For example, TDD is not a testing strategy, not a design principle, not for imperative shell, etc. Of course, not for user experience tests. Why? Yeah, we believe that TDD cannot be used as, for example, testing strategy, and also, for example, cannot be used, for example, user experience test. But it doesn't mean that maybe in the future we can't use it. We still don't know, of course, but we sincerely hope that the future will bring better tooling to apply TDD in more widespread and in more areas. And after that comes a getting started section, because at the beginning, or the main idea of this manifesto is to put the values of TDD and what is not TDD, just to following the concept of Agile Manifesto. But after that, I realized, okay, everyone would say, okay, it's good, the talking is cheap, show me the money, right? So everyone who hears about TDD, they want to get started. They want to read about how to get started. What are the main concepts behind TDD? How can I start it? What are the first steps I need to take? So that's why we decided, okay, maybe it would be wise to extend this manifesto, and instead of just describing the values, we also have put a getting started section, which is going to be here, where it's also compact and simple. We wanted to make it as simple as possible. Simplicity is king. We all know that. So getting started section consists of different parts. For example, why we write the test in the first, so not afterwards. So basically, because if you want to trust our code, we need to trust our tests, right? And if we want to trust our tests, we need to see them failing. If we don't see our tests failing, then we don't know whether they fail for the right reason, right? So that's why here a short description about this, the essence of TDD, because the TDD forces us to carry out or to practice a set of practices to produce quality software, for example, write tested code, working in short cycle, practicing continuous refactoring, etc. We have heard a lot of amazing things in the talks we had before me. And of course, after that, steps to get started. Of course, if someone wants to get started with TDD, then he or she needs to get familiarize themselves with the 3 laws of TDD. After that, learning the red-green refactor TDD cycle. Of course, here everything is detailed. What are these cycles? And here we created a really good, I think it's one of the best parts of the TDD, because here we have a flow diagram where one cycle of TDD is described, also with the 3 laws of TDD included. And also we wanted to keep it simple, but also detailed enough to get started by any TDD newbie to get started with test-driven development. And of course, after that, practice makes perfect, and the greatness comes from practicing. We encourage everyone, of course, to start writing code with TDD. First of all, one can follow kata exercises. We already heard about kata exercises today. Here we already created the sections I'm going to present you really soon. And of course, applying TDD in project. That's also, of course, that's what we all want, benefiting from TDD and getting the most out of it in real projects. Here we have one section about how to level up our TDD skills. And last but not least, here we have one section called with the title, "Do you need some help? Feel free to ask us on Twitter." I'm not going to describe this because my presentation contains one part where I describe this in more detail. So we will come back to this shortly. So basically that's it, shortly, the description about how to get started with TDD. Clean test, yep. So basically all parts of the software should be written with equal care. The test should be as clean as the production code. And we believe, yeah, of course, the question is, what is clean test? And of course, it can, I think, there can be subjective and objective characteristics of a clean test. Because first of all, what clean test is, it can depend on the framework, it can depend on the language, it can depend on the domain we are solving. But on the other hand, there are objective properties or characteristics of a test, which we think are language agnostic. It means we can, if we follow them, we can follow them in most of the language, most of the framework, and most of the domains. We can follow them in order to produce clean tests, which are maintainable. So yeah, here we just have an example about ugly or non-clean test implementation. As you see, wrong naming, a lot of unnecessary data for the test, also not structured, etc. And after that, here we describe all the objective characteristics of a clean test. For example, descriptive test names, meaningful namings for the variables, functions, how to structure it. For example, the inject assert pattern. I think we already heard about this today. Following the first principle, asserting one behavior, using meaningful test data, etc. And at the end, we have a clean test implementation. Of course, you can check it out and you can see and read the whole section and you will see, but here we think that this is sort of clean test implementation. It is language agnostic. We don't use any language. It's sort of pseudo code, I would say. So as I said, greatness comes from practicing, and also we just, for example, for someone who wants to get started with TDD, he or she will read the getting started section, a clean test, but after that, it's time for them to get their hands dirty with code. And here we collected the most popular and also the most famous and also the kata exercises we think which are good to start with. And here we have all of them. We have 6 different kata exercises with different difficulty levels, starting with the easiest one. For example, FizzBuzz, we all know, but it's a known problem and it can be solved, going through the string calculator, etc. So, and last but not least, we have an about us sections, no names, nothing fancy. We just talk about why we created this and who we are. Okay, I'm going back to this is the TDD manifesto, what we created. I'm going back to the, next the presentation, F5. Yeah, I have to jump a bit. Yes, okay, so TDD manifesto bot, what is it? We created a bot on Twitter, which can be found with the name TDD manifesto bot or with the handle of TDD manifesto bot. And what it does is that if someone creates a tweet on Twitter, and if they include the TDD manifesto hashtag, then after that, the TDD bot will come and will reply to that tweet with the handles of many amazing people who basically created this manifesto, and also most of them, or I would say all of them, are part of the organization group of this conference. Here we can see an example. Here there is a really good question, but it's created by a bot. While practicing TDD, can I add some additional passing tests just to cover some use cases? Yeah, of course we could spend hours of talking about this, whether it's good or not, or in which situation it can be fine. The most important thing that is you see here, the TDD manifesto bot reply to that tweet, of course, automatically. And here we see some handles of some people, so they can jump in and they can help out anyone. So I encourage anyone to try it out. If you have a question about TDD, just feel free to ask us. Of course, you can always direct message us, but maybe would be better to expose it to everyone on the worldwide by using the power of Twitter. You can ask your question and just don't forget to include the TDD Manifesto hashtag, and we will go there right away and we'll answer your question as soon as possible. Yeah, let's improve it together. So I think you already heard this sentence as well, but I have to repeat that there is no such thing done software, right? And also this software is like this. Yeah, it is basically a website, right? But still not done. There are room for improvements. We are planning to improve, for example, adding video exercises for the different katas, and also, for example, if we get some questions from the TDD practitioners, or even improvement points for anyone, any professionals, they point out that maybe we are wrong somewhere, then we are happy to improve, because the most important part of this manifesto is to share the knowledge, of test and development, to make it more widespread, and of course help everyone we can with that. So if you have any remark, please feel free to check it out and let us know. We are happy to improve it as much as we can. Yeah, basically that's it. What I wanted to talk about. The conclusion is that it is live, so you can just go there, tddmanifesto.com. You can check it out. Even you can recommend to your friends or anyone who want to get started with TDD. It's good to be stressed. I mean, the website is stressed is a good thing, so we can learn from it and we can make it as good as possible in order to spread the words. Of course, the reviews and improvements are welcome, as I already said. And yeah, last but not least, don't forget to call us via TDD Manifesto, and we will go there and help you out as much as we can. Yeah, basically that was my presentation. Thank you very much for everyone who was here today for this talk. It's a late time, it's almost midnight today, but things are fine. Basically, that's what I wanted to present to all of you.
Thank you, Daniel. I just want to say, Daniel, I don't want to say recruited us, but solicited. This was his original idea to do the TDD Manifesto, and we worked on and off. And the energy is very high. But I see all of us here, and maybe, I hope I'm not mistaken, kind of all of us here come from this extreme programming mindset that Canback introduced 25 years ago. Most of these things, TDD, etc., are part of the extreme programming practice. And in the spirit of extreme programming, I would like to throw one challenge at Daniel. Daniel, some people claim that you should be able, your tests, your clean tests, should be at that level of quality that you should be able to yank the entire shipping code and you should be able to reconstruct it from your tests. What is your thought on
that? Yeah, based on your test, you can reconstruct, but the tests are, I would say, these are software expectations, right? So they don't tell how to implement the code. So what I would say, yeah, it's possible, but the tests are expectation, and it's up to us how we implement it. But yeah, I mean, if you're talking about that, it means it also we have to assume, right, that we have to have all your tests, and it is not the best practice, right? You have to having all your tests before you don't have anything. First of all, you want to have just only one test, and after that you write the production code. That's all about TDD. So it is, yeah.
I'm asking because there was some discussion while you were presenting on what is more important as far as high quality of standards, shipping code or tests?
I would say both of them. They are all code. Test is also code. So it should be as clean as the production code. We should treat it as the production code. We have to maintain it continuously. So of course, eventually the most important is to have a code which delivers value, right? But we can only deliver value on time and continuously to the customer if we have a solid test suite for the code, which is maintainable. If it is not maintainable, then it becomes a burden, right? So we will discard the test anyway. So that's why it's I would say it's essential point to produce clean tests. That's why we created this section of clean tests to emphasize that the test should be as clean as the production code. Of course, the code what matters, the production code what matters eventually, because that that will be executed right in a runtime and will solve the customer's problem, but still you cannot produce quality software if you don't have quality tests.
Awesome. Thank you very much. I think we're ready for a break.
I do. Thanks. Thank you very much for everyone. Thank you.
All right. Maxi, you want to lead us into the break?
I don't have anything to add after Danny's
Okay.
explanation.
All right.
So let's move on for the break and see you in, I think, 45 minutes or less.
We have a longer break, I would say. I think the next talk will be in, I have to check. I already have an image prepared. Give me just 1 second, please. The next talk will be at, I'm going to put a picture just to see, you see, and maybe you guys go away. If you drop off, you see in the background we already have. Let me remove you guys and we can. And thank you again for everyone. See you soon after the break. We will put it in a picture when we come back shortly. Thank you, everyone.
Thank you.
Hi everyone, welcome back. Alex, how do you do? Hopefully you have some rest for the... Yes, we can. We cannot see you, but we can hear you.
Something is up with my camera. Anyway,
No
you take it away, Maxi.
Okay, thank you. Well, we have the last three talks of the night. Next speaker will be Raghunath. He's from India, and I think it's 4 a.m. there. So we thank him a lot for being awake for us and showing his very interesting presentation. Raghunath has been working in several world-class companies for a decade and has a lot of experience of software engineering. And in his talk, his technical talk, he's going to tell us about the speed and how he introduced TDD as a regular workplace habit. So, welcome, Raghunath.
Hello, Maxi. Hello, Alex. Thank you folks for the introduction.
Take it away. The podium is yours.
Yeah, thank you very much. Hello, everyone. Welcome to my talk on speed as a workplace habit influenced by test-driven development. So before we go ahead, I want to give you a little bit of background behind this talk. So I was introduced to TDD somewhere around 2012 in one of the code retreats organized by Dr. Venkat Subramaniam. So it was a one-day event where we were pairing with different programmers with working on different languages and solving one problem throughout the day. The only constraint for us to solve this problem was to test drive the entire solution. That was the only constraint. But it was not until 2017 I started practicing TDD on my day-to-day work. Right? It came out as a surprise because I and Venkat, we were having a conversation, and then he was asking me if I'm still writing tests. And I was not, and he was a little bit surprised. So when I went back to work, I wanted to give it a try, and then I started trying out TDD, and that's when I realized how valuable it is to my day-to-day work and all the misconceptions that I had about TDD. Like, for instance, writing tests is going to take you a lot more time to ship your code. I understood that was completely untrue. So ever since 2017, TDD has become one of my primary workflows. So most of my code, like maybe 90-95% of my workflow, is based on TDD. And fast forward to today, I have been using TDD for quite some time now. And then as a side effect, I've also noticed the way how I approach problems, both technical and non-technical at work. So this talk is about going and looking at a few examples and case studies and showing you how we can take a closer look at the feedback cycles that TDD gives us, and then apply it into problems that are sort of not necessarily related to typing code. So when we talk about TDD and feedback loops, right? So what does a feedback loop entail? So basically, when we talk about feedback loops, there are a couple of things to think about, right? So the first thing is the system tells you that something is not right. So these are the kind of feedback loops that are the most valuable because they help us catch mistakes early on and help us course correct really quickly, right? And there are also another kind of feedback loops when that's basically telling you your system is clean or like things are working as expected. These kind of feedback loops help, but then they are not as helpful as the feedback loops that tell us things are not working, right? And negative feedback loops are also quite helpful because they help you to experiment much faster and then figure out different solutions in a very short amount of time. So before we go ahead and look into other examples, the first thing that I want to do is like take a look at one of the TDD cycle and then examine a few feedback loops within the cycle before we go ahead and look at other examples, right? So before we go ahead, I just want to give a heads up. Let's just revisit the 3 rules of TDD. So the first rule says write production code only to make a failing unit test pass, right? And the second rule is basically write no more unit tests than it's sufficient to fail, and compilation errors are also treated as failures, right? And the third rule is basically write no more production code than necessary to pass a failing unit test. So these are all the 3 rules for TDD. That we have revisited these rules. Let's go ahead and take a look at how a TDD cycle looks like. So the first thing that we take for granted most of the time is the IDE, because without the IDE, the kind of feedback loop that we get from test-driven development can be completely different. And obviously it differs from platform to platform, but IDE is one of the tools that sort of shortens this feedback loop that we have with, while practicing TDD. So the first thing is we have a test. It's just like a regular test. And what we're going to do is we're going to create a class that is going to help us help this test for us, right? So we're designing a system that is greeting visitors. So we create a class called greeter, and then we invoke the constructor. But then the IDE is telling you, hey, you know what? Like, I'm going to mark this in red because the class does not exist, right? So the next thing that you're going to do is sort of like say, hey, like, how do I fix this? And then the IDE is going to tell you, maybe these are all the things that you can do. Either you can import the class from a different place, or maybe you can create a new class or a new function, right? So these are all the options that the IDE gives you. Then we pick the one that is suitable to our use case. And then we go ahead and create the class. And then now it's all normal, right? So the red is now black. So fast forward. So we end up writing more and more of the unit test by bringing in missing methods and all of that. And then when we complete, this is how it looks like. So we now have an API that has a greet method and then also takes in a username. And we're saying, hey, you know what, like when we call this function with this parameter, this is what we have to get. And the next thing that we do is we attempt to run this thing, the test fails. Then we go back to the production code, write the minimum amount of code necessary to make it pass. And then we run it again, and then the test passes, right? So that's just one TDD cycle. And here are some of the key moments in the cycle itself. So the first key moment is the missing class. So when you reach this point in time, we said, hey, you know what, like there is this class called greeter, and then the IDE tells you, you know what, like the class does not exist, and these are all the things that you can do. So the first thing that we have to take into account is the latency between the time it takes for you to perform an action and then for a consequence to happen. In this case, like the greeter class, missing class turning red, that's it. And the latency is almost immediate, right? A second thing that's happening is how does the system grab your attention? Does it play an active role in getting your attention? Yes, it does. So it actively gets your attention. And the third thing it does is like what are the kind of the response that the system gives you when something like this fails? So here in this case, it's more suggestive. So excellent feedback systems with excellent feedback can suggest you what you have to do to like get out of a failing scenario, right? And let's look at another key moment. In this case, it's a failing unit test. So you have this test, no production code, and then it fails. So what is happening here? So now, if you look at the first criteria, the latency between the action and the time the time taken for the consequence to appear is immediate, right? Which is pretty fast. And the system also plays an active role in getting your attention, which means it's going to show this pop-up, and then it's going to ask you, and it's going to tell you with all the red icons and message telling you something failed. So the system is playing an active role in getting your attention. And the response is informative. In this case, the system tells you something failed, but then it doesn't really tell you what you have to do to fix it, right? So in both these cases, we can take a feedback loop, and then if we break it down, you can see that we have 3 different cases, and each of these have different values. And the third thing is like the passing test itself. So again, now we have a passing test, and then if you look at the latency, it's immediate, attention is active, and then response is informative, right? But in this case, it's a passing test. It's helpful, but again, it's still a good feedback loop, right? So if you look at, if you take any feedback cycle and if you break it down, then you will always have 3 different criteria against which you can evaluate the feedback cycle itself. So the first one is the latency. So how long does it take for the action and the consequence to happen? And then it can be immediate, tolerable, or forever, right? So these are relative metrics, and it really depends on the kind of system that you're working with. And I'm using like relative measures here, but then if you're trying to tune one of these parameters, then you can use absolute values, and then like, you know, you can use units like milliseconds or seconds or hours or days or whatever that is suitable to your use case. The lower the better, because as the feedback cycle increases, which means it's going to be harder for you to go back and fix any mistakes that you have in the system. And systems can play an active role in getting your attention. Sometimes they can be passive, and sometimes there is none, right? And then the response that you get from the system can be suggestive, which is like excellent, and sometimes it can be informative, and sometimes there is no response from the system at all. So if you identify a feedback loop that is very inefficient in one of the processes or like the system that you build, you can sort of look at where these things are and then try to improve one parameter at a time, right? And if you get all greens, that's the best kind of system that you can build. And in some cases, it's not even possible to build a system that has all attributes in green, right? So it's okay to have one or two in orange and sometimes maybe a few in red, but that's completely relative. As we go through more examples, you'll understand how this plays out. So the first thing is, since we're talking about speed as a workplace habit, right? The first thing I want to talk about is like, how do we go learn shortcuts? This is my preferred IDE of choice. I mostly work on the JVM, so I use this IDE. And what I am using here is a plugin called Key Promoter. So Key Promoter is a plugin that helps you learn shortcuts, and let's go take a look at how it does it. So when you click on the build button, Key Promoter sort of shows you this dialog and tells you, hey, you know what, like something is, so this is something that you need to know, right? Let's take a closer look at this. So now when you're looking at this information that's popped up on the screen, you can see it has two pieces of information. The first one is the shortcut, right? So if this is an action that you're constantly using in your workflow, then it's saying, hey, you know what, if you want to build your project, you probably have to use Command F9, right? So which is like suggestive, because the system is telling you what you need to do to prevent this pop-up from showing up, right? And the second thing it does is it shows the name of the action, and it also shows the click count, right? So for example, how often are you doing this, right? Maybe if you have a higher number, then probably you should pay more attention to the shortcut itself and learn it sooner, right? And this is also more helpful because the pop-up, the position of the pop-up is placed very closely to the action that you are performing, right? So it's very hard for you to miss something like this. So let's like break this down, right? So this here, the latency is immediate. The attention is active because like it's on your face kind of pop-up, and sometimes it can get like really annoying. But then again, it's sort of like the system grabs your attention like really actively. And then there is response, and sometimes here the response is both suggestive and informative, which is like quite nice. But then again, we have like all three in green, which is an excellent feedback mechanism. Let's go ahead and compare another kind of learning shortcuts. So this is using a different plugin, and then let's say how this plugin solves the same problem. So again, IntelliJ, and then and if you haven't noticed anything, you probably have to look at the bottom right corner of the screen. There is a notification that tells you what you have to do, right? Let's take a closer look at this. So when we look at this, you still have the same amount of like, it's the same kind of information that you received with the previous plugin, right? So one is the shortcut, which is suggestive, which is excellent. Like, and then the second thing is both the action event and the click count, which is again informative. So the information here is no different from the information that we saw in the earlier scenario. But then the area where this plugin falls short is the notification is sort of always on the bottom right corner of the screen. And then it's placed usually far away from the area where you're performing the action. So for example, if you're clicking an icon on the toolbar, it still places the notification on the bottom right of the screen. So the developer has to play an active role to go and look at the notification to learn the shortcut, right? And that sort of becomes very hard because you're like already focusing on something else. And this kind of sort of is less effective than the plugin that helps you learn shortcut in the first place, right? So here again, the action is immediate, the attention is passive. So the system is not really trying to get your attention actively, right? It's showing this message, but then it's for you to go and look at it and learn the shortcut on your own time. And the response is both suggestive and informative. So if you go back and compare the two different systems, the latency is immediate, the attention varies because one tries to get you actively learn the shortcuts, but the other one is more passive. And personally, and also like within the circle that I've noticed, people tend to learn shortcuts much more faster when they're using the first plugin, which plays an active role in getting their attention. And then the response is the same, right? But then when you notice, we have one parameter that varies, but then that can have a large impact on the efficiency of the system that you're building itself. And this is the only non-technical portion in this talk, writing a blog. And as you've already noticed that I'm a non-native English speaker, and then I've always had difficulty writing longer blog posts, right? Because writing emails is much more easier because the only focus while you're writing an email is to communicate things well, and they're usually short. But then when you're writing a long form blog, then at least I become very self-conscious about my grammar and like the flow of the content, and there's like too many things for me to focus. So it's not like it's not very natural for me. So I still have to put in a lot of effort to write blog posts that looks at least decent. So I've been personally experimenting with a few things. The first thing was I used to write blog posts and then I used to edit them on my own. And more often than not, I used to spend days and sometimes even weeks writing the content and then like even editing and trying to like figure things out on my own, right? And it was like very taxing, and I was not very successful in writing like a lot of blog posts. And most of my blogs were just drafts because I was too embarrassed to publish them, or did not have, and also like did not have the time to go and edit each of these blogs. And then I also considered hiring content editors, but then it wasn't feasible for me because I wrote blogs very infrequently, and then it's also more expensive to hire content writers. And if you hire someone who's really good, they already have a lot of work, and there's quite a bit of back and forth between them before we can settle on something. So that also did not work for me. The other thing that worked for me was to get feedback from friends. So I have a bunch of friends to whom I can share a draft with, and then they give me feedback, and mostly the feedback is around the content and the flow, but it's not really about the grammar and the kind of things that I want them to pay attention to. It's quite helpful feedback, but then it's not the kind of feedback that I want. The other thing is like, go use a tool that can do this for you, right? So if you're not really good at grammar, then find something that is really good at grammar. And that's when I came across this tool. So this is a tool that sort of helps me write like well, and then it also helps me, it has also helped improve confidence in my writing itself. So one of the things that I noticed when using this tool is I had three major problems. One is writing really long sentences. The second problem was to write like a lot of text in passive voice. And the third thing was with punctuations. But at least now, this tool has helped me write shorter sentences, helps me with punctuations, and then I'm also more proactive and then write my text in active voice. So those are the things that have sort of helped me to improve my writing. And nowadays I can finish a blog post in like 2 to 3 hours, which is pretty good. And then I send it out for a 2 to 3 day review with my friends and then just publish it. So it's a quite helpful tool that has reduced feedback and also helped me learn English better. So this is the tool showing me like there is a problem with the text, and then I can go ahead and fix it, right? So, and sometimes if you have very specific goals, you can choose the kind of style of writing that you want, and then the tool will help you to achieve that. So let's break down this feedback loop, right? So here the feedback loop is it's almost immediate, right? Probably depends on the latency of the internet, but then it's still almost immediate. The attention is very active. It underlines text, it highlights things in red or green or blue, like really depending on the context. And then the response can either be suggestive or informative. So there are times where the tool recommends me the right kind of syntax that I need to use, but then sometimes it can go ahead and say, hey, you know what, like maybe this is a sentence you have to rewrite, but I can't really tell you how, right? So it really depends, but then the feedback is somewhere between excellent and very good. Now, working with graphical user interfaces. So this is an example that I'm going to show you on a project where we were building a Git GUI client. And as most of you know, when you're working with GUIs, it's very, very hard to unit test them, right? So UI is one of the things that more often than not requires human intervention. A portion of it can be automated, but most of the time it's very, very manual. So let's say, let's go through an example. So this is a case where most of our logic is driven by tests, but then there are things that you need to work on the UI. So the screen right now shows a very simple layout of the application itself. So I'm not showing the actual screen, only one portion of it. So you have like two different panes, and probably you have a file menu. And when you click on the file menu, then there is an open repository screen. And then when you click on open repository, you are presented with a, what do you call it? A file picker, and then you can go choose a directory where you have a Git repository. And when you click on it, it opens the repository, right? And then from a list of commits that you have, you pick a commit, and the Git client is going to show you the kind of affected files, right? So this is the UI from the actual application itself, right? So now let's say we have problems with the scroll bars or like with the selection. And for us to fix this, this is a very painful flow to go through, right? Despite we have unit and integration tests that can prove the functionality of the UI component, but then problems with the UI component itself is hard to fix. And this is one of the cases where it becomes very inefficient, right? So let's go ahead and look at the feedback cycle that we have here. So the action is running the application, and like how long does it take for you to see the bug, right? That's the time it takes for you to see the consequence for your action. So it's sort of like forever because it's a very painful process, right? It's also not something that's very enjoyable for most of our developers to work with, because you're clicking on too many different places to fix a bug, and can be sometimes very discouraging if the bug is still not fixed. So the attention is there is none. Like, we don't really know if you have fixed it. We have to manually go look at the system and then understand if something is going on, if whatever we did has fixed the system or not. And then the response is none, right? Like, the system does not really give us any feedback. So we still have like sort of a feedback cycle, but then a suboptimal one, right? So how do we do better? So one of the things that we try to do is build the application in such a way that each of these components can be mounted on their own. So here is where you're looking at a portion of a code base where we mount only the component that is that we have to test, right? So on the left side, you have the actual component. On the right side, you have a bunch of controls, right? So the top of these controls are the ones that are the inputs to the component itself, right? The architecture that we have requires you to specify boundaries in terms of values or streams of values. So the things that we need here are the repositories. So the list of repositories are fetched from a directory on the developer's machine, and then you have a file that you can pick, and then there is a list that contains all the list of commits. So that is your input, and then as you vary your input, the thing on your left changes. So and then there's this output, right? So if you're selecting an item on the list, then there's a callback that tells you what happened within the list, right? So this is a tool that can sort of like save you a lot of pain, and then like lift the UI so that you can test UI related bugs or UI development slightly more faster. Let's evaluate this one, right? So still, earlier when we looked at the previous approach, it was forever and there was no attention, there was no response, right? But now it's tolerable because this cycle is like slightly more faster than the previous one, right? So when you're trying to fix a bug, you're still using the UI, but it's not like as painful as the earlier approach. So the next thing, can we improve on this, right? Let's say, for example, hypothetically, we create a control, and since the values are all, the boundary between the component and the tool itself is values, we can sort of save the value, like, the path to the repository, the file, as well as the commit, and then we can automatically select the previous selection when the application starts up. So if we build a feature such as this one, then you can see that the latency between the action and the consequence can become immediate, right? So hypothetically speaking, so for example, if we want to improve on attention, right? So I may be completely wrong here, but then say, for example, we can sample a few frames from the beginning of the file and then save one of those frames to the disk. And then when the application starts up next, we sample again, get another image, and then compare the two. And if there are no changes, then we can, if there are changes, we can flash the UI, right? So if we can have a red border flashing around the component, that means that system is telling us, hey, you know what, whatever you did, there is some change, but then it's for you to go and look at it, right? So when you look at a feedback loop that's very inefficient, you can look into these individual parameters and then tweak them so that they can behave appropriately. The last one I want to talk about is an exploratory problem-solving technique. Let's say, for example, you're building a privacy-focused personal finance application. So you're not like sort of letting other people read your email or having integration with a third-party application with your bank account, but rather using PDF statements that your bank emails you to keep track of your personal finances, right? To write such a system, you need to build something that can parse these documents and sort of derive these values and derive insights for you, right? So the problem with this approach is, one, they're like different banks. So you may have to write like classes that cater to specific banks and specific formats. And then even if you have a PDF that you can successfully parse, if the bank changes the format of the statement, then it's going to be painfully difficult for you to figure out and add it to your new requirements, right? So the class of problem that we're dealing with here is where the requirements is not very clear and can change vastly among banks and even the same bank itself. So how do we deal with a problem like this? So one of the things that you can do is initially test drive a few reference statements and then sort of make sure that your code is able to parse these statements successfully. The next thing that you can do is expose this business logic, the parsing business logic, into a CLI application. And then you can build a CLI application that can take in a PDF and an input and then use a criteria to verify if the parsing was successful or not, right? So typically you can say, hey, you know what, I parsed all the transactions. Now, if I compute the debits and if I calculate the debits and credits, it should match the outstanding amount payable, right? So that's one way to make sure that your parsing logic is working as expected. So now when you have this kind of logic and then you have a CLI tool built in, you can pass this around to QA developers and QAs and other developers so that they can go run this on a set of data that they already have. And whenever there is a failure, you can pick up those sample data and these sample data become your new tests, right? So especially when you're working on a problem that is not well known or is not very what do you call it? The requirements are not clear, or you're in a position where you have constraints like the ones that I described above. You can go ahead and build CLI applications that can sort of like make it faster for your team and others to scale the discovery of your requirements and also discovery of bugs. So again, like these discovered requirements and bugs become your new tests in your system. So again, let's look at the action consequence time. It's almost immediate when you have a tool like this, because you don't really have to write a test or go through the UI to validate if you're parsing a certain PDF successfully. The attention is active and the response is informative. So this can tell you what failed, but then it can also be suggestive depending on how the criteria that you use to, the way how you build the tool, right? The tool can be smart, and if it's smart, then it's going to be suggestive as well. So we looked at a few examples at work and how you can sort of reduce the feedback cycles for the kind of work that you're doing. So excellent feedback cycles, they fail really fast. So if they fail fast, then that means you can course correct much faster. Then they also grab our attention. They play an active role and they grab our attention, and they can also be smart, and then they suggest corrective action. So these are the qualities of an excellent feedback cycle. And if you have a feedback cycle that's not excellent, the first thing that we have to do is to see, maybe can we make this excellent, or is it even worth to make it excellent, right? It's okay to have a few oranges or reds, because that really depends on the kind of system and the environment that you're working on. Closing notes, feedback cycles need not be excellent. It's a gray area, and then it doesn't have to be black or white. So you don't really have to aim for excellent. Having very good or good feedback cycles will do. And then you can apply this to smaller and larger systems. So for example, you can zoom in and then look at a single test or like a single verification of a PDF document, or you can take this and then apply it to your entire software development lifecycle, right? Say, for example, the moment you start from getting requirements till you deliver the product, right? Or even if you have a CI system, you can sort of look at it and then take a closer look at every stage and then identify the feedback cycles, figure out, break them down, and then see which area needs improvement. And again, like, make sure that the kind of time that you're investing in improving the feedback cycle is rational. Don't go about improving the feedback cycle for everything. You don't have to improve everything to the maximum. Improving a little on various fronts can benefit you more than improving just one single thing. And command line interfaces are like excellent tools. They're like part of my standard tooling. So I use that most of the time to expose like a lot of, especially when dealing with problems that are more exploratory. So that's an excellent tool. Learn a CLI framework. It pays off very quickly. I'd like to end this talk with this quote: the only way to go fast is to go well, and fast feedback loops help us go really well. Thank you very much. And if there are queries, I can answer them for you.
Thank you, Raghunath. To me, your presentation is state of the art. I'm really impressed. Thank you so much for doing this. I learned so much, and your emphasis on these three things, you know, how is grabbing our attention and whatnot. This is pure gold. I will definitely have to upgrade my curriculum to add these things to my, with your permission. I mean, if you're
yes,
okay to share, I'm really impressed. I thank you so much. The discussion in the, I think people are getting a bit tired. So the discussion is all over the place, meandering. I could not really see much that people are asking about this other than you saying to do cost analysis. Can you maybe just elaborate a little bit on the cost analysis? I'm curious to hear your thoughts.
So for example, so sometimes certain things can be done manually. So for example, if you're a one-person team, or if you have like only 2 people in your team, then it makes more sense for you to sort of keep doing things manually, right? So for example, we had a very small team, and approval tests was a part of our workflow, right? So it became a part of our strategy. So when we were a small team, we just like used keyboard shortcuts to rename these files and like get things done, right? But then once you see that it's becoming more and more a part of your daily routine, and then as you add more developers, we went ahead and wrote a plugin that can sort of like help you work with the approval test itself, right? So for example, it has an approve action. You can approve a bunch of files in one place. You can look at an approved file or a received file right from the test itself, and your tests have these markers, right? So now this pays off, because when you have more developers, then everyone is spending like a lot of time, and then like a lot of place for error, right? So that's up to you to figure out like, hey, what is our scale? How often do we like come across this problem? Like if it's something that's a one-off, and then if you're going to spend like 8 hours doing a problem that is going to be done once for 2 hours, you might as well do it like manually and not automate it, right? So that's how I say, like, how often are you going to perform this task? How large is your team, so that like you can quantify the amount of time that you're going to save by automating or improving the feedback cycle in your feedback loop in your system.
Excellent, thank you. We have a few comments here. One is that we should learn our shortcuts. It's worth the time it takes to practice them. I think you're helping us with that. I think you bring unique perspective, at least to me, which I really appreciate. Very valuable to me, and I hope to everyone else. So I'm going to be going back tomorrow and reviewing your. I want to learn from that, and I want to see what I can incorporate into my teaching, and I think it's going to help a lot. So
thank you. Thank you very much.
Yeah, this is awesome. This is so good. And I mean, here we are. This conference is amazing. The amount of new information, what has to be learned, is drinking from the fire hose. So I think we now are ready for Maxi to announce the next presenter. Thank you, Raghunath.
Yes, amazing. Raghunath was amazing. Too much to learn and too much to revisit the talk once and again and again and again. Our next guest is Jan Giacomelli from Slovenia. It's too late there too. And Jan couldn't be live, so he recorded a talk for us. We are going to play back his talk. If you follow Jan on Twitter or on his blog, he writes a lot about TDD, especially on Python. He's a Pythonista. And in his talk, he's going to show us why Python is an excellent choice for TDD practitioners.
Hey guys, thank you all for coming to my talk with the title Python, a language made for test-driven development. We'll talk about how to practice test-driven development in Python world, which libraries to choose, which testing frameworks to choose, how to use them, and why Python is really a good fit for test-driven development. We'll take a look on some of the examples with some live coding, and we'll also discuss how to approach machine learning-like solutions with test-driven development, because machine learning solutions are widely implemented in Python. So before we start with our topic, let me introduce myself. So my name is Jan. I'm coming from Slovenia, Europe. I'm tech lead and co-founder at Typeless.com. We are developing algorithms for data extraction from documents such as invoices, and we are mainly using Python. I'm also author of blog posts and courses at testdriven.io, and I'm also present on Twitter. I'm working with Python for the last 6 years, and I'm practicing test-driven development, or at least trying to since the beginning. So let's move to our real topic. So when you're practicing test-driven development, you may face some of the issues, such as a long time to start test suite, writing lots of code for just a simple test case, writing lots of code just to implement a simple thing. You may need to install third-party dependencies just to start writing tests. And when you're in Python world, sooner or later you will hit some machine learning-like solutions, and they may seem untestable at first because of their undeterministic nature, which means that the given input X may not produce the same output through the time. So when using Python, those things can be really minimized, because Python really tries to make things simple, which is great for test-driven development, which is all about small changes and quick feedback loops. And the less code you need to write to implement a simple thing, the better. The faster the test suite runs, the better. It doesn't matter why it's slow, whether because it needs some time to compile, or because you have slow tests. Either way, you want to have it as fast as possible. So let's start at the beginning. Python comes with unit test library that's built in inside its standard library, so you don't need to install anything to start writing your unit tests. It's XUnit implementation in Python. So if you're familiar with JUnit in Java, it may look familiar to you. And it also comes with a rich mock library that can be used to mock the third-party API calls or databases or whatever you need, because Python is dynamically typed, so it's really easy to rely only on the interface, which mocks can easily provide. So to write a simple test for a calculator, you need to create test class, which inherits from unittest.testCase, and to write a test method, you need to prefix its name with test, and then you can use built-in assertions to assert that add method on calculator behaves as expected. So this pattern may be familiar to you from other languages, because, as I said, unit test is XUnit testing framework. You can run the test inside the current directory by running Python -m unit test, or you can discover tests inside the specific directory. In that case, you need to use the discover. Your Python modules containing tests must start with test underscore, but you can override this pattern and use something else if you need to. The test can run really fast. So as soon as you hit enter to run the test, you'll see the results. There is no time to compile, so it's really, really fast to see the results. Although it may seem very simple to use and to write tests with unit test, you can go even simpler with PyTest. It's third-party package which needs to be installed with pip or Poetry or any other Python package manager. It requires even less boilerplate code, which makes your tests more readable. It uses built-in assert statements, so you don't need to remember all the assertions that comes with unit test, which also makes your tests more readable and easier to remember. It's simpler to setting up and tearing down the test state with its feature system. It uses functional approach, and it also has a wide range of available plugins, which can make your life even easier when dealing with automated testing. So as you can see, the test for the same add method on calculator is even simpler. So you just need a simple function that uses built-in assert statement and assert that output of calculator add equals the expected value. So that's it for a test when using PyTest. So you can run your tests by running PyTest. It comes with a binary, and it will run all the tests inside your current directory, the PyTest ones and the unit test ones. So if you are using PyTest, you can run both tests with a single command, and you can also select the specific folder just by providing a command line argument to a PyTest command. Similar as with unit test, the test suite runs really fast. Here, no compile time needed here as well. So you hit enter and you have the results. Among all the things I already mentioned, it allows you to run failed tests from previous run. It allows you to run tests in parallel. So for that case, you must need to use PyTest XDist plugin. You can create JUnit XML report of your tests, and you can also run doc tests, which are tests. These are actually more of examples how to use your function or method inside the doc strings in Python. So yeah, that's basically it about theory. In the next step, we will move to live coding, where I will show how to practice test-driven development in Python using PyTest, how to do really small steps from simple implementation with a function to more complex one with a class, but easier to test. And so yeah, let's move there and see the things in the real world.
Let's say that we are building a community for Python professionals where users can pose their questions or answer them. And if the users misbehave, they are banned from posting for the next 2 weeks. We can model that with creating a new ban each time that user gets banned. And before the user's post is created, we need to check whether the user is banned at the moment, and if the user is banned, the post creation must be rejected, otherwise the new post can be created. So let's start by writing a test for ban repository. So let's say test ban repository. I have an environment with PyTest installed, which I'll be using for running my test. So let's say test save list active bans by user. I can use docstrings to add the given when then notation in order to create the test more readable and to express my intention better for my fellow developers. So let's say given bans and repository when bans are saved, then active bans for a given user can be retrieved. Okay, so let's say username equals John Doe, expires at is date time dot date time dot today plus the ban for 2 weeks, so I need to add 2 weeks here. Okay, and then I can say ban is ban username expires at. So this is my active ban for a given user, so let's say active ban for John Doe. Then I also need repository, so let's say repository ban repository. Okay, and then I add this active ban for John Doe. Then I can add inactive ban for John Doe. So let's say it's still username, but the expires at is date time dot today minus date time dot time delta days on, so it's already expired one, and I can also add another ban which is for Jane Doe instead of John Doe, and it can be an active ban. So today plus date time dot time delta for 2 weeks. Let me fix that. Okay, so when this is sorted out, I need to assert that repository dot list active bans by user, and I provide a username equals a list of active bans, so it's active ban for John Doe. Okay, so that's my test. I'm checking that after all the bans available are being saved, I can retrieve only the active ones for a given user by by its username. So let's run this test. It fails, of course, because the ban and the ban repository are not defined yet. So let's add them. So let's say ban, and I have ban here. I can just pass it for the moment and import it here, and I can do the same for ban repository. And I say class ban repository, and I can pass it just to make it importable. Okay, I can rerun my test. So yeah, ban takes no arguments at this point, so let's change that. Let's implement the init method. So this is username and expires at, let's say self.username equals username and self.expires at equals expires at. Okay, I can rerun. Okay, new error. So one step further, ban repository object has no attribute save. Okay, so I need to implement the save for the ban repository. I'll provide ban, and I'll say at this moment self.bans.append ban, and I also need to add init self.bans is empty list. Okay, let's go further. Okay, save is implemented, no errors there, so I can move to the list active bans by user. Okay, and I'll provide username, and I'll return the filtered bans. So let's do that. It's ban for ban in self.bans if ban.username is equals username and ban pika expires at is equal or is greater or equal to date time dot today. Okay, I can rerun my test, and it's passing now. Okay, great. So at this point I can just simply leave it like this, but let's improve it and let's add type hints. So the users which will be using my repository will have easier job, because the IDs will be able to suggest them autocomplete, and also to verify that they're using my methods correctly. And so this is ban, let's import it. Okay, I can rerun the test. It's still passing, of course it should. And I can also formalize my repository, and I can say I'll create a formal interface, although as you can see I don't need to do that in Python, but I can. So let's say I ban repository. It inherits from abstract base class. Then I add abstract method. So this is save, which has ban, and it's not implemented. And then I have another abstract method, which is list active bans by user, which takes username, of course, and it pass. It's not implemented. I can inherit from here, and the test is passing. Okay, great. So I can move further, and I can implement the actual use case, which will check whether a user is banned or not. So let's add a test. So test user is banned. Okay, let's write it. So test user is banned, no active bans. So I'll add given when then as before. So given user name of user without user without any active bans, when user is banned is called, then false is returned. Okay, so let's do that, and let's say username is John Doe. Assert user is banned for the given username is false. Okay, I can run my test. Oh, it's simple and it's failing because the user is banned is not defined. So let's define it. Let's add a new Python module and let's say user is banned. And I can implement the function. So it will take username and I'll pass for the moment. So I can import it. Okay, let's rerun. And it will say none is not false. Okay, this is failing because by default the functions in Python are returning none if nothing else is specified. So let's implement that. Let's say return false. Okay, the test is green now. Okay, great, but let's implement it for real. So let's say repository is ban repository. So active bans is repository dot list active bans by user, username, and return length of active bans is greater than 0. Okay, so this is the real implementation. My test is passing and that's great. So I can move to a new test case. So let's say test user is banned active bans. So one more time, given when then. So given username of user with active bans, when user is banned is called, then true is returned. Okay, great, but here here we have a problem, because at this point we are initializing the repository here, and because this is in-memory repository, it's empty all the time. So for this test case, we would need a repository with active bans for a user with given username. So at this point, we could use a monkey patch from PyTest and mock the list active bans by user method, but instead we can refactor the user is banned to be a method on a class instead of just simple function, and we can inject the repository, and we will make it much simpler, and we won't need to use any mocks. So let's do that. Let's say we won't import this, but we will say this is now authorizer, so all similar things will go in here. So let's rename the module, so authorizer. Okay, and I'll import authorizer instead of user is banned. I'll put it here and here, and I'll add an empty story here, because here I can use an empty one, and that's perfectly fine. I can rerun the test here. Okay, of course I can't collect because I need to do my work here as well. So I said I need ban repository. I say self.ban repository is ban repository. Okay, and I can move this one to the authorizer. I need to add self here, and then I can use self.ban repository instead of this repository. I can remove this here, I can remove this there, and I can rerun my test. Okay, this one is empty, so it's passing, but let's say username equals John Doe one more time, and let's say assert authorizer ban repository, but I need to add a ban, so let's say repository is like this, and then repository dot save ban. I need to import it, so it's username and it's datetime dot today plus datetime dot time delta days 14. So this user now has an active ban, and I can say user is banned for username is true. I rerun my test and they're still passing because this implementation actually covers it, but I locked it with this test because otherwise, as you were able to see, I could use just hard-coded false response, and that all the tests would be still passing. So yeah, that's basically it. Okay, I can add the type hints here as well. So this one is Ivan repository. As you can see, you can start really simple with Python. You can just implement the stuff and then add type hints to improve your code. You can easily refactor, and you can also see, as I was already mentioning before, the tests are running real fast, so there is no compile step, which makes the process even faster. And yeah, you can start with a simple function, and then when you see that that you need something else, you can just refactor that into a class or into a couple of functions or whatever you need. So one great thing when doing test-driven development with Python is that you really don't need to plan ahead. You can just go with a flow. You can really go, you ain't gonna need it way. So yeah, that's how I do it, and I hope this will help you as well to improve your test-driven development in Python and test-driven development in general. So let's move to the last topic, which is machine learning and test-driven development, because Python and machine learning are really a perfect couple. Okay, so let's move to the Python and machine learning, which are pretty perfect couple. Python is widely used for machine learning applications, as you may know, and there is some idea out there that you cannot apply test-driven development to such solutions because of their undeterministic nature. As I said at the beginning, two consecutive calls with the same input may produce different output. So yeah, it's true when you want to test your machine learning algorithms or models in the same way as you to test a method that calculates discount based on some parameters. But if you take a step back and think about test-driven development and its red-green refactor cycle, you can see a parallel between test-driven development and scientific methods. So in test-driven development, you have a red-green refactor. In scientific method, you have your hypothesis, which needs to be validated, and then at the end you theoretize your hypothesis. So the question here is, what can I measure, or how to approach such things in order to automate the testing of them. So when you are building a machine learning model, or if you're solving something with a genetic algorithm or anything similar, you know when the model or algorithm is production ready, right? Because otherwise you are just creating a random number generator if you don't know that. And you decide, so this model is a good one based on some parameters. So the question is, how I can measure those parameters? There is no one size fits all straightforward answer here, but you can tackle it and you can approach it, because if you're able to write automated tests for your models or solutions, you can easily train, let's say, 1,000 of models in parallel on AWS servers and decide for the best one and just deploy the best one to production. So you can come to a point where you
you're able to experiment almost unlimitedly. So you can do whatever you want. You can tweak your settings for model. You can tweak your data set. You can do whatever you want, as long as you know how to measure this. So, for example, you can claim your hypothesis that the 95% of predictions on test set must be correct after the training is done. This here is just pseudocode, although it looks like a test written in Python with PyTest, but it's just the idea. So you train with train set, and then you compare the results on test set, and you'll see the results, and you assert that the 95% of all predictions must be correct if you are working with classification. On the other hand, if you're working with regression or something similar, you can use, for example, that the difference between the predicted value and an actual value must never be greater than some relative part of predicted value. Or you can completely change that assertion to meet your needs. As you know, if you're working with machine learning, you cannot measure only the accuracy, because you may be in overfitting area, you may be in underfitting area, you may have a too complex model, and a bunch of other stuff that can tell you, okay, this model is actually not that good. So in a similar way, you can assert that your model must not be more complex than some threshold. How to measure that? That's another question. It's hard to answer, but I'm sure that you can find it for your particular use cases. You may assert something about the loss function. So, for example, you may want to prevent spikes in loss function, and you say, okay, the derivative of loss function must be lower than some threshold for all the data points in my loss function. And so similar for other stuff, you can also measure the how quality is your data set, is balanced or unbalanced, and all other things that you need to do with your data and your model. So in such cases, you just need to find something that can be applied to something mathematically. So as I said, derivative of loss function, for example, or difference between the model and the actual value must be always lower than some threshold. You have a bunch of different approaches to do that, but the main idea is, when tackling machine learning, instead of asserting that something must be equal, you are going to an area where you assert that that some error or error rate or derivative is less than epsilon or any other threshold. So instead of looking to a point, you're looking to an area. So my solution must be somewhere here. When you're calculating discount, you can claim my solution must be this. You have a point. But when you have a machine learning, you have an area, and you must lock your model in this area. And when the model is inside this area, you can automatically deploy to production and don't worry about it. So yeah, that's all about Python and test-driven development from me. Here you have some of the resources that will tell you even more about the topics that I cover. So thank you for listening. I hope you've enjoyed it, and I hope we see at some real life event in the future. Bye.
All right. Unfortunately, Jan is not able today to take questions, so I would like to move into the next speaker. We have a privilege to have Maxi Contieri from Argentina. We call him Fragrant Maxi. Can you guess why? Because Maxi is the expert on detecting code smells and fixing them. He is a prolific writer. I follow each and every one of his blog posts. You can learn like a ton of things. It's really in depth. And also, you know, his credentials, he has a PhD in computer science. Awesome. So Maxi has been teaching software engineering and working in industry for 25 years. I'm not going to try it in person. I'm going to try it in person today. He adopted TDD in the mid-2000s and built a financial system from scratch with 25,000 automated tests. Since then, he has been enhancing existing legacy applications by refactoring them with TDD as well. He frequently blogs about software design, code smells, and clean code. And now, for the very important, because let's face it, very few of us have the privilege to daily work on greenfield systems. We get hired, you know the joke, you get hired as a forensic expert, and then you find yourself working in a morgue, right? We're looking at cadavers, and we are trying to figure out what the hell happened. So Maxi is I'm really looking forward to your talk, Maxi, because you know what, I have to wade through a ton of these legacy systems, and any help, please share, brother. We need help. So over to you, Maxi.
Well, I hope I be up to the expectations you showed to me. Okay, so let me see if you can see my presentation. I think you can hear me, so I will move on. Well, as Alex introduced me, my name is Maximiliano Contieri. I'm from Argentina. I'm graduated and teacher on computer science on Universidad de Buenos Aires. I've been teaching and working, as Alex said, in the industry for about 25 years. I'm practicing TDD for at least 15 years. In this talk, I'm going to show you how to practice with TDD on legacy and coupled systems. We're also going to tear down some common myths of the software industry and TDD. This talk is aimed to people with few experience on TDD. I will start with a very brief definition in case you missed all the talks before mine. Okay, this will be our agenda for the next 20 minutes. We're going to explain TDD in just a few words, show a real impact on a real system. There are out there a lot of TDD courses and katas, as one of the presenters showed out there, but many of them show isolated and simple examples and do not teach us how to insert the whole process and continuous integration, continuous deployment on a real legacy system. We will also show all the software roles sharing the process, working together. So this is the definition. I'm going to show the definition just in case you don't know what TDD is about. TDD is a development methodology. I'm tired of saying it's not a testing methodology. It's used for programming, not for testing. The tests are written first, and the solution always have to be super simple, even if it's hard-coded. You know that. We must never anticipate under any circumstances to potential solution. This allows us to avoid very complex and imaginative solutions that do not have contact with client real requirements. And it gives us full coverage on all the cases described. You know that this technique was created by Ken Beck in 2003, and today it's used in many parts of the world, as you might be aware. The cycle, I'm going to tell you this again. I assume you are familiar with XUnit family for running automated tests. First, you add a test solved basically on behavior, important behavior, as Mario said, different implementation decisions such as data structures, algorithms, and so on. Second, you run all the tests. The test created in the previous step should fail, the former not. Third step, you write the simplest solution, always the simplest solution. Do not program more than necessary. Following, keep it simple, keys, and YAGNI, you're not going to need C principles. And optionally, and this is important, optionally, you might refactor the code when it starts to stink, as it has had a lot of code smells. Never do steps 1 and 4 at the same time. Never. This is known as TDD cycle. And the design benefits were shown all the day today, but I'm going to tell you a bit. With TDD, we will get more decoupled system. Coupling is very visible. This is more evident in large and fragile systems and not so much in small exercise or katas. The code is more modular and easier to debug in isolation. We have more coverage. The steps are very small. We listen a lot about baby steps today, very baby steps, and we avoid making premature optimizations ahead of time. This methodology is based on how we learn from childhood, based on examples and not on definitions. We learn when we were told by examples. In this talk, I'm going to destroy a lot of myths. Let's start destroying some of them. TDD does not guarantee good designs. Good designers are the ones that guarantee good designs. So if any one of you is selling TDD, do not sell that the designs are good. Good designers make good designs. Okay, so let's see which are TDD's preconditions or requirements. We need to be in full environmental control. We cannot allow global variables, no global functions, no singletons, no configs, no database, no cache, no external OP calls, no side effects, anything external which is not under our control. TDD will help us detect the coupling sources, and lead us to a cleaner code and focus on solving essential problems, business logic, and encapsulating accidental and implementation problems out there of the code. So another myth, we cannot do TDD on couples. I'm tired of listening from my students this. I have a couple system. This is a myth. This is what this talk is about, and we will try to demolish this and other myths as well today. Okay, let's see an example. Enough talk. Well, this is a real example from a COVID-19 streaming ticket reservation system for online concerts. The user chooses her artist with regular expressions using our user interface. And regular expressions have very poor performance in some relational databases. We need to avoid them as much as possible, given our current database stack. We cannot change, unfortunately, the database stack. This is another myth. We're going to crush the myth that TDD cannot be used to improve the performance of a system. And this is not contradicting some talk before that said TDD should not be used for performance testing. Of course, it should not be used, but it can tackle some performance issues. Okay, this is the example. Our system generates these types of dynamic queries based on user inputs. If you don't know SQL, think of regular expression. Maybe you're familiar with SQL. There are just 5 text pieces. We have 5 different conditions. You can see them on the OR clauses. Patterns in red are redundant and yield unnecessary and costly operation on the database. They do not add value. For example, the second is represented by the third and the fifth by the fourth. Arranging is not very smart to infer or deduce that rules. So we should transform the previous slide into this. This example is more performant and semantically equal than the previous one. This is the whole problem we need to solve. Seems a piece of cake. Well, let's start with TDD. This example is in PHP, but I want you to look at it as if you were pseudocode. I don't care if you know or not TDD. I'm not going to enter into language details. TDD starts the cycle by asking us to create a case. Your first thing you need to do is to create a case. Neither the class nor the function that solves the problem are defined, just the test case. I'm defining a fancy light pattern simplifying class and a simplify method that don't exist yet. They are probably very lousy names. First names are always lousy, no problem. We always have a step 4 and good IDs to make refactor. That's what we should use, good IDs and not text editors. We will always start with the simplest case. In this case, I'm using a methodology called zombies. You might have heard of it a couple of hours before. I think Joe showed you zombies. Zombies guides the order of the cases so that we do not forget any of them. This case is the empty one. The 0 is the Z in zombies, asserting that if there is nothing to simplify, nothing is simplified, the 0. Step 2 of the cycle, we need to write the code. The simplest solution, always return an empty array, no matter the input. The parameters you pass to the function do not matter. Solution is hard-coded, return an empty array. That's the 2 brackets after the return, in case you don't know how arrays are built in PHP. Always return hard-coded. And this is a myth. Hard-coded is not a bad practice. We need to remove this from our heads. Unless we have the crystal ball and know the algorithms for everything, but that would not be doing TDD, but futurology. If you want to make futurology, you can write the algorithms without the tests. Let's feed with more examples. We are on the cycle. This is the loop 2. Step 1, we add another simple test. If there is only one term, the simplification is the same term. Of course, the test does not pass. So in step 2, we modify the implementation. The solution has to work for all pre-existing examples. It was just one. And here we see the test and the solution. We continue to return hard-coded, sending out the input parameter instead of the empty array. With this solution, we cover the first 2 cases, the previous and this one. Okay, but we need to complicate cases gradually. We test 2 independent expressions. To our surprise, the pre-existing code already works. What is it telling us about our solution? We return what we received. This works for 1 or n independent elements. We got ahead of ourselves with the solution. Maybe we will delete this redundant, because it's redundant, test later. For now on, we leave it happy that everything works. Okay, but let's start with the funny cases. One expression that does contain the other. Luckily, the tests do not pass. TDD asks us to fake it till we make it. Okay, we already fake it a lot. Now we need to make it. So, luckily, these tests do not work, of course. So after we skip some TDD steps for short for this talk by hard-coding some elements, but this is a possible solution we came across for related patterns using the substrate compare function and a filter. Substrate compare is a function in PHP that searches for prefixes. You can use similar functions in your language. This solution makes all the previous tests pass, of course, 2 nested loops, insert for redundant patterns. When iterating, we see it is included and we remove it. It's not clean code, it doesn't matter. We don't have confidence enough to refactor yet. We are learning from the domain. However, this solution is ugly, not very declarative, not very performant, and too complex. Okay, let's demolish 2 other myths. We shouldn't write algorithms without test cases. The algorithm that emerged was based on several test cases. The current code can be ugly, can be highly imperative, can be non-declarative. We will improve it once we have confidence with our IDE tools. So code must not be clean all the time. Well, some bees tell us to look for the capitalization axis because most relational databases, engines, ignore capitalization in searches. We write an explicit test that ensures this property. This probably won't work if the user changes the case from uppercase to lowercase. And this is something we have to make sure. So we write the test. Of course, it didn't work, but we need to fix it. We tell the substrate compare function that the comparison has to be case insensitive. This is the true parameter you see at the end of line 4. We could have guessed from the outset, but we are following a coverage map, and everything is documented on the test. Our flow is documented on the number of the tests. Tests are living documentation. The algorithms are documented with tests. They are not documented with comments. Test numbering shows our learning processes. Okay, now we have step 4, please. It screams for a refactor for readability. The simplified function was horrible. We are confident enough to refactor now because we have a battery of automated tests. I'm going to refactor without changing the test. You cannot change test and refactor at the same time. One extract method, refactor, and everything is a bit more declarative. Use IDAs, don't use text editors. All tests keep passing. The refactor, of course, worked because it was an automated refactor. So we test the real scenario, and we are happy it worked. We can simplify what we needed. We are done, and this is the end of the TDD exercise. We just not need to inject the solution into the real system. We need to simplify the collection of texts that are used in the second line. So far, we get them directly. Now we have to simplify them. So we put our code between line 1 and line 2. This is the injected code. We inject the processing and simplification of terms in our system, and we are done with the code. Commit, push, but what happened? The QAs tell us that the pattern to look for could be in the middle of a word, and that was not analyzed. QAs perform the black box testing process and complement TDD job. They are not disposable. So There's another myth that software development is an individual activity and it's just done by the programmers, but QAs are sharing TDD processes by contributing with use cases. We are learning from the domain as we code, so requirements, as you might know, are not frozen, and we are learning. The requirements are not frozen, or we don't know them in depth yet. We have to discover them. The QAs bring us 3 cases that look for patterns in the middle and not just at the beginning of terms. That was their request. This test data is suggested directly by the QAs and therefore not from the music streaming domain, but and of course they are in Spanish because QAs speak Spanish. We validate the proposal with the end user to see if it complies with the business rules. Likely they do, so we write the test and fix the code because it was not working. The code we started using, we changed the auxiliary function that you use it to a stripe pose, which is case sensitive and also searches within a string. The previous functions just searched only at the beginning. We are within our simplifier. We're not changing the injection point. The code from outside does not change. The change goes to production and goes live with the plug changes. Customers are happy. End of the talk. No, well, shit happens. We find errors in production with sentences generated like this. The statement with an empty where clause is not valid for SQL engines, and the optimizer messed up, screwed up, and we didn't see it coming. So we must correct it. The QAs help us see the test case. They also contribute to the TDD process. We were removing the 2 terms if they were the same with different case. The end user just came up just with that case. We had to leave one representing both. We cannot remove both. There's another myth. It's not just programmers who participate in TDD. The QAs continue to contribute actively, and the production technical support team also does TDD with us. We do some pre-processing before we start simplifying, and everything works. We do it in a private method that is called remove duplicates, that does this, removes duplicates, that should only be used by the simplifying internally. That's why it is private if your language supports privacy. And there's a myth that whenever we add a private method, the same question arises, and this question was today on the chat. Should we test it or not? The answer is right there. You can go to the site and find the answer. You input your private method and it tells us if you need to test it or not. So solution goes back to QA. We are on the cycle. We are on the development cycle, but QAs find new bugs. The assertion expects an uppercase, but our preprocessor normalizes it to lowercase. There are 2 ways to fix it. First, we take the error as acceptable in the problem domain. It is acceptable. Second, carry out a solution, a magic solution, making the problem very complex. We don't guess. We don't imagine answers. We involve the customer or the product owner who accepts the first one. The client also participates in TDD and help us define the cases. So we push the code, but the code reviewers provide improvements validated by the end user. They say, hey, wait a minute, something that does not have the word head also does not have the word Radiohead. Could we use this emergent property? We check again with the product owner and she agrees. Code reviewers also contribute to TDD. Everyone is contributing in TDD. So the simplifier isn't change it because we just have to change the function call and model both the positive and negative cases. But we don't need to add tests since the simplifier is not changing. Well, it worked out. Happily, it worked out. We were able to do TDD on an existing system. It was a collective and iterative process. Everyone contributed with cases. We can keep adding new cases without breaking previous ones. We have a battery of tests. The solution were simple, covering the use cases. And in the meantime, we tore down some various preconceptions of the industry and software engineering. So what do we have as a future work? Well, I didn't mention, but we need test doubles to comply with the complete control of the full and main time. We need to be radical on that. We need full control, and that's what test doubles are for. And as a task, you need to start using TDD tomorrow. I hope that after this conference, you will be using it if you were not already. And personally, I advise you to tell everyone to avoid the Hello World tutorials, which are very bad. Hello World is coupled to the console. And change them to assert false. Start your first programming line on college should be this assert false. And I challenge you to dare your students to do so. Thank you very much. You can follow me on Twitter. You can see me there in my blog. As Alex said, I write a lot about TDD, software designs, and code smells. And I'm very happy you stayed with me until now. It's very late here.
Well, thank you, Maxi. Can you hear me?
Yes, of course. I can hear
you. That was a brilliant presentation. You did clear up a lot of ground for my talk. And I'm going to, first of all, after thanking you and how much we enjoyed your talk, I would like to maybe move into my closing presentation. I need to apologize a little bit. I had this second dose of COVID vaccine. I'm kind of losing. At this point, it's been more than 10 hours. So I would like to try and do my presentation without making some terrible mistakes. If that's okay with you.
Yes.
So in summary, I was here 10 hours listening to everything, watching everything, reading the comments, being blown away, both by presenters, by our super energized community. So many pros, so many, basically, to my mind, it is a state-of-the-art event, as we are really pushing it to the max, DJ Max. Busting myths and doing amazing contribution to the community, which I really appreciate. Now, let me see. First of all, what did I want to say? I wanted to say that I really did not expect this much breakthroughs, this many breakthroughs today, because like I said, to me, TDD is old news that did not travel well. We have known this for a long time, for some reason did not really pan out in many situations for various reasons. Let me just check something. And so we need to, again, I'm hoping, we need to try and get it into curriculums, right? Into curricula.
Mm-hmm.
For the, I'm sorry, I just want to see one more thing. Because I'm using two computers. I want to make sure everything is cool and happening. And so, secondly, I'm hoping that this conference will have some impact on job descriptions. I'd like to see, when I'm reading some job descriptions, I'd like to see that TDD is mentioned, because oftentimes people get hired and then they hear about TDD. What's that, right? So what I want to do today, and please don't panic, I won't terrorize you with my guitar playing, but I want to show you one thing. Now, I'm a guitar player, and it's one of my favorite guitars. If I play a simple guitar chord, right? Sounds nice. But look what happens if the guitar, because the guitar is a tempered instrument, and it does not come out of the factory necessarily well tuned. So we need to take care of it, right? So if I now look what happens when I detune it. So it's out of tune, right? We have a saying, guitar players spend half of their lives playing the guitar and the other half tuning the guitar. The guitar is a very finicky instrument and we have to tune it, right? And we do it actually by turning these knobs, right? If I turn it this way, the pitch goes up. That way, slackens, right? So now I'm trying to tune it up to this note that will resonate well with the rest of the chord. Nice. Sounds good. I detune. Bad. Why am I doing this? Am I losing my mind after my second dose of COVID vaccine?
I want to ask you to imagine if anytime we need to tune the guitar, we need to write a program. So we don't have direct access to this. We need to write a program, computer program, that we then have to commit and open the PR, blah, 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 compile and build, and the code review, and PR gets approved, gets merged, the CI pipeline runs, and on it goes until actually the code we wrote reaches that machinery that's going to turn this knob, right? And then only at that point do we hear, is it correct or not? And then we may say, oh, still not good. Go back, modify your program, do the song and dance, run through all the approvals and things and pipelines and whatnot, workflow, change management, blah, blah, blah. Now, if this was the only way to tune the guitar, how many people in the world do you think would be still interested in playing the guitar? Not many, only masochists. And because musicians are not masochists, luckily we have this direct. So, and also imagine if, not only that, but imagine if we had, this is a dev guitar, and then there is a system test guitar, or maybe there's a staging guitar and user acceptance guitar, and it has to go through all of these things until it goes into the real guitar on the stage, and then we learn, oh crap, this is not tuned well. So to me, that's like lunacy, right? But when you think about it, this is how we develop software. And it's just like, to me, unimaginable that we are so super tolerant to this situation. Like, why are we tolerating this? It takes forever. I make a diff. I have no idea how that diff is actually going to pan out once we go live, right? And there's always these unpleasant surprises. And that's why I was impressed by Raghunath's talk, where he drew our attention to that. Like, look, the longer we wait from the moment we make a diff until the moment we realize, did it work? Did it not work? The longer we're staying in dark, and the longer we feel demoralized, and it's not a fun job to be in. And so TDD is one approach how to shorten that, as we've seen today. There's many brilliant examples that we were looking at today that illustrates the importance of shortening the feedback loop. Because if we stay in this state of tolerance, then whatever we deliver is going to be really shoddy, in my opinion. I apologize. I know there are some geniuses, but overall, I'm coaching and training teams and whatnot, and you can see that if from the moment you make a difference until they actually eventually weeks later see whether it's working or not, that energy is gone, and we are kind of trudging through our daily routine, but it's not exciting. And here we saw today, which I think was a state-of-the-art, whole bunch of 13 talks, just blown away, starting from Jeepa and James, and then Elena, Ola, Liz, Meenakshi, and all that. Really opens up the door and the possibility of us raising the bar and going to the breakthrough, and getting to the point where we can really be real pros and start really delivering quality fast instead of going through all the song and dance. Now, of course, people are saying, yeah, well, it's easier said than done. And when you think about it, the real problem boils down to code as text, because text is our second nature. We understand text, and computers have no idea what text is. And so there's this kind of a cognitive dissonance between humans and machines where, yeah, I can roll with text and blah, blah, blah. But then for the computer to actually run it, there's a little bit of a in-between layering. I'm a big fan of Kent Beck. To me, Kent Beck just blows my mind. And he is working on so many things and so many interesting ideas that it's such a fertile mind, right? And I don't know if you guys follow him, but basically what we're trying to do we're trying to get to the point where each keystroke is deployed to production. Now, some people say, "Oh, that's madness," blah, blah, blah. Have you ever worked in Google Docs, like collaborating? That's it. You have a document or a spreadsheet or whatever, and you can have few people, and they are actually making it. Each keystroke is going live, right? So it's possible, right? What's stopping us right now is, document is one thing, but computer, the syntax, abstract syntax tree that needs to be translated into machine code. And CAN-BACK has these rules like you should be able to make a diff and not harming anyone on your team, right? So that's a topic for another conversation today. And I'm going to put this guitar away. Thank you very much for indulging me. I apologize for my lousy playing. I'm going to try and walk you through how I do these things. I have been experimenting a lot, and of course, I'm teaching a lot. So I'm not a tool jockey, right? I'm not just hands-on cranking code. I'm doing a lot of research and teaching and coaching teams, and a lot of them are like novices or kind of trying these things out. So I like to keep things really bare bones simple, because sometimes if we do some fancy tools and they're doing a lot of magic for us behind the scenes, then people stop thinking, "Oh, I'm just going to push this button, everything is arranged for me." And that is sometimes counterproductive. So I'm going to try and share my screen here, if you don't mind. And all righty. And let me go here. Now, if somebody can ping me on WhatsApp whether my screen is showing, I would appreciate that, because I don't have a way of knowing. But hopefully you can see it. And if you remember, when I was doing my opening talk this morning, I was explaining how when I was a young programmer, I was doing a lot of just straight down coding, heads down. I was so cocky and brash, and I'm like, I know what I'm doing. And thinking back, that felt like this picture. This is a picture of a boy flying a kite. The kite, it's exhilarating experience, but it's very hard to control. And you're up in the air, and it's going every which and every way. It's blowing by the wind. Only, very hard to control it, and also very hard to figure out where to land it, right? And so I was very rarely trying to land my code. I would just be writing and entering and writing, and then later I tried to compile, etc. And after a while, I realized that this is getting me into trouble, because I was pushing a lot of bugs into production and people were screaming at me. And so, to cut long story short again, eventually bumped into extreme programming and TDD. So I switched my practice to TDD. And to me, can you see my screen? One sec. Yes, thank you. Okay, I don't want to talk into darkness. So see, this picture here is riding a galloping horse. This is how TDD feels to me. You're going fast. You are every now and then you're touching the ground, and then you are in flight. And when my thing about TDD, when I'm in flight, I cannot steer. The horse jumps, is flying through the air. It's like a straight arrow. I cannot change its direction. I only have a chance to change the direction when the horse temporarily touches the ground, and I can steer it. And so while this is fast and all that, something was not feeling completely satisfactory to me. And so, following CAN-BACK and doing research and whatnot, I came to this point where I'm preferring to proceed like this. If you can see this picture of a tank. So why am I making things difficult? With experience and on the job software engineering, I grew to like steady state. I'm a big fan of steady state, which means I like status quo. I have aversion to change. As an engineer, I like my system to always be working. I don't like to see whatever I'm working on, I don't like to see it in a busted state. To me, that's very upsetting. So I kind of became the opposite of my younger self. And I value steady state. I know how brittle and difficult and fragile it is to build a good solid system. And as the saying goes, any resilient large system basically started as a very sturdy small system, and then step by step grew into that. It doesn't happen haphazardly. So in here, what I'm trying to do is I'm always grounded. Whatever happens, I'm on the ground. And so for that, I would like to have a system that heals itself. So I can go in and I'm stupid and I don't know what I'm doing. As James said rightly, you think you're a good programmer, but you're not. And definitely I'm not, right? I'm doing all kinds of stupid things. When I break something, I want my system to automatically heals itself. You go back into, no, everything's cool. We are still working. And again, I point back to Ron Jeffries. The trick is never to let the code not be working. The code must be working at all times. I don't like the situation, and Jupa talked about it a lot, where the system is busted and we are wasting hours messing around and the system is not up and running. And then somebody approaches you and says, what you're working on, can you show me? And we're like, oh, give me like half a day. I just have to put some, connect some dots and put some things together and I'll show you. No, you should be able to show them right away. Okay, here's how far we got on this at this point. Okay, so I hope this makes sense. I like this steady state, and I'm going to try and show how I now like to work. And for that, I came up with a very Mickey Mouse, super simplistic toy example, because we don't have much time and I don't want to bore you, and something that hopefully may illustrate this point. So I came up with a user story, and I'm calling it tip calculator because that's super simple. And I know these things exist, but just pretend we are going to build a brand new tip calculator, which story goes like, as a patron, I want to calculate the total bill, which is total plus the tip, because I want to compliment the restaurant for the service. So it happens all the time. Go to a restaurant, here's the bill, I want to give them a tip, and I have to calculate in my head, or maybe the machine, if the machine doesn't have the capability. And this user story, I broke it into about 5 scenarios, and let's just start with the first one, which goes like this. Scenario 1. Patron calculates the total for terrible service. There's such thing as terrible service. Somebody spilled the soup on your brand new suit. They didn't apologize. Okay, these things happen. So now the given one then goes like this. Given that the restaurant total is $100 and the service was terrible, when the tip calculator calculates the total charge, then tip calculator shows $100 charge, which means no tip. I'm upset, I'm not impressed, no tip. So let's go and start building this. Okay. I'm going to create a directory, and I'm a terrible typist, so please don't be. So, and again, I like to bring, when I'm teaching, do everything from ground up. Nothing is pre-baked and whatnot, so that we, no ice up my sleeve and nothing like that. And I have this habit because I'm teaching a lot of novices, but I hope you don't mind. I know you're all amazing pros, but just please bear with me. I'm going to create this new tip calculator. This is going to be our solution. Sorry. And in here, the thing I like to do is I like to create tests. I'm big on tests. I love tests. And I'm using .NET because this is this demo was I prepared for .NET for my students. So I hope you don't mind, but you can do this in any tech stack, of course. So I'm going to create some commodities, and I'll be using XUnit. I like it. Nothing wrong with that. So this is going to build me a skeleton, a really simple one. And now I want to also create a shipping app where the code lives. The other one, oh, okay. All right. And again, I'm going to build a little bit of scaffold. A new class lib. All right. And now I'm going to initialize this repo. I'm going to add all. See, typo. Add all. Yeah, it's different in Linux. So okay. I hope you can see my, it's large enough, the font. And if I do get status, I need to commit. First commit, okay, nice. Okay, get status again. Clean. Let's go into the code. So you see here we have app and tests. In the tests, it's given us some skeleton unit test. In the app, some Mickey Mouse class 1. We can safely ignore it. Doesn't matter. What I'm going to do now, and somebody please ping me if the font is too small. I hope it's not. See, first thing I'm going to do now, I'm going to teach this, and I'm doing it from ground up. Absolutely. I'm going to teach this system how to self-heal. And the way I'm going to do it is I'm going to create some automation. So I'm going to say, I'm writing a script file, where I'm saying test underscore commit or reset. It's going to be PowerShell script because this is on the .NET. Right? And this is in. Okay. Now, here I'm going to tell this script to first thing to do to run .NET test. So I want you to run the test. Then when you finish running the test, I want you to check the last exit code, because two things can happen, basically. Either tests are all in green and pass, or one or more tests fail. That's the only thing that may happen. I'm saying if your last exit code is 0, which means everything is in green, everything's cool, no worries, I want you to add all the diffs I made, and then I want you to commit with a message, the generic message working. And some people have qualms with this, but we can talk about that later. Else, I want, if the test, one or more tests fail, which means I broke the system, I want you to reset hard. And this reset hard is going to self-heal. It's going to pull me back to my healthy state. So this thing is now very simple, right? I believe it's self-evident. We run the test, check if it failed or pass. If it passes, add all the diffs, commit. If it fails, go back to healthy state. Very simple. Now, I want to, let me close the terminal. Let's quickly go into tests, because as we talked about earlier today, tests are the specification or the where we declare expected behavior, unit of behavior. Mario had a brilliant talk on that, and I think everybody agreed. Now, here I am designing, and we talked briefly today about being careful how you name your tests and all of that. All these things are brilliant. And today I'm going to really rush through this because we don't have much time. But the first thing, what am I expecting the first thing from this tip calculator? Well, basically, if we think about all these like simplicity zombies and whatnot, we are now dealing with this terrible service with a terrible rating. So I'm going to now cast my mind in that direction. So let me first think about terrible rating. What do I want the system to do? I want the system to know about terrible rating. The system should know that there is such thing as terrible rating. And I'm expecting when I ask the system, is there such thing as terrible rating? The system will say, yep, I found it. So I'm going to call this test. Terrible rating is valid. And now, how am I going to proceed? Fake it till you make it. Maxi told us hard coding is legit. Nobody goes to jail. I'm going to start, of course, with hard coding. And I'm going to say expected response for terrible rating is true. So this is how I'm daydreaming about this. I'm envisioning things here. I'm having my post-COVID visions. And my actual response for terrible rating is what is it? Is let's fake it. It's true. Something, yeah, of course. We're pretending that we have something that's still not there, and we're pretending everything's cool. The only thing left to be done here is to just assert for equality. Righty. So see, this is very, very naive, very Mickey Mouse, and we always start like very, very simple. So what happens when I save this? You see, the system runs that script. Oops. Of course. Demos. Test commit. Okay. What is the problem? Just see if things will. All right. Yeah, amazing how these things happen, right? So I'm saying, oopsie, no, assert. Equal. Apologies for this. All right. Okie doke. Expected response for terrible rating is true, and actual response for terrible rating is also true. And now all right, let's see if this thing will actually behave. So once again, everything seems to be working fine. The gods of demo are smiling. I save. Okay. Sorry about that glitch. I have no idea what happened. So fake it till you make it. We're hard coding this. No big whoop. But you see, the system is not broken, even though it's not doing anything. Now, we want to replace this hard-coded true with some real code, and we need to point at the shipping code, which here in this, the CSproj for the test, I need to tell it where to look. And I'm going to say, look at the app folder for the app CSproj, right? Look. Save. I go back to tests, and now I should be able to use it. Using app. And it finds it. Awesome. Thank you. You see, if I save now, system is not broken. Excellent. Now is the time for me to start designing this. And I like to always start from some kind of a abstraction. I like to use interfaces in C#. And I'm going to say, suppose there is an interface called tipcalculator. I'm going to call it tipcalc. And it is implemented by tipcalculator. So here's me daydreaming. I'm saying, look, I need some code to calculate these things. Of course, these two things don't exist. It doesn't look like I'm looking at the app. I can't find them. So my job now is to actually declare them. So I'm going to say, create a new file, tipcalculator. This will be C#. namespace is going to be app. It's going to be public, public interface. I tip calculator. Okay. If I flip over, okay, he finds I tip calculator, but tip calculator, its implementation is still not there. So I need to also declare that one. So I'm going to create a new file, tip calculator.cs. I'll be using system here, and namespace will be app. The class is public, of course. It's called tip calculator. And it implements I tip calculator. And it's complaining because public class, yes. Okay. Now we see that the declaration is happy, the implementation is happy, and empty, right? This guy is not happy. What's going on? Tip calculator. Now he's happy. Okay, typo. All right. We make mistakes. Awesome. Now there's a time where the rubber meets the tarmac, and we will have to now put this baby into use. So it's going to be tip calc, and here I'm daydreaming again. I'm saying I want to send it a message, say, hey, is this rating valid? So I'm going to invent a new protocol. Sorry, I'm going to say is rating valid? Terrible. And this guy's complaining, saying, I don't know what is rating valid means, so we need to teach it. Here, I'm going to declare a new capability called is rating valid, and it's going to return Boolean, true or false. I'm keeping things very primitive and simple. Don't get upset about it for the purposes. And then later on, of course, we will be refactoring. And now we need to implement this. Is rating valid for the string rating, and we must return bool, and I'm going to return true. So let's quickly go and examine. This guy's happy, this guy's happy, this guy's happy. What happens when you save all? Alrighty. The system is working, not in a broken state. But just, I like to always check, what if I give it a false expectation? I'm expecting false. What happens then? Run again. It heals. It says, no. You failed, and I'm going back to my healthy state. So the system is always in a steady state. All right, but we are cheating because this is hard-coded. Maxi told us it's okay, but we should not stop there. The next prime directive is refactor. And how do we refactor? We start again imagining. I'm going to say, okay, I need these tips to be stored somewhere in this calculator, and I'm thinking, rather than going fancy, I'm just going to use commodities that are available there. And of course, I know something about .NET, and I know for a fact that it has collections for free of charge. I'm going to ride on that. I'm going to bet on the horse called collections, and I'm going to say, you know what? I'm going to use one of the collections to store those ratings so that we can, calculate. And so what is the rating? It's a key value pair. Keys, for example, terrible, and the value is 0%. And then we have other values. So I'm going to use hash table, if you don't mind. It's very simple and primitive. We can later refactor, but for now, I'm staying with fake it till you make it. New hash table, And why is it complain? I didn't give it a name. Let's call it tip percentage. Plural, tip percentages. And let's see what happens when I save. Oh, didn't like something. Tip percentages. Okay, sorry about that. It always happens when I'm demoing. Using system collections, and then doing private hash table. I know I'm still a little bit under the weather. Apologies for that. All right, now we should be okay. If we run the system, it should not crash. So notice how I like to run the system as frequently as I can. I need to get this feedback, because if I stop doing this, if I just start adding code, I know I'm going to be in big trouble, right? So, all right, we have this, but now how do we actually tell it the values? And I'm going to here use just the, I know Maxime may be mad at me, but I'm going to use a constructor just for simplicity. And I'm just going to, what? I'm going to add variable, and I'm going to say 0, and that's it. Run again. Anytime I make a change, I run, right? And you know, it seems idiotic here, but when you're dealing with some hairy things, it helps. And lastly, let's see how do we actually how replace or refactor hard code into actual code. And I'm going to say tip percentages rating. So I'm going to ask it, why is it tip percentages? Sorry, my bad. The vaccine's kicking in. Contains key. So it's a nice commodity method. And why is it? Which key? Rating. Look, everything seems cool. If I run it, I hope I'm not boring you guys with this. All right, we're in a healthy state. And we have, right now, completed the first test. Yay. We have a strong system in the making. Now, I'm a big fan of symmetry. And then anytime I make something work, I'm always thinking, okay, let's flip it on its head. So my next expectation would be whatever rating is invalid. That's how I think. Maybe you call me a bit pessimistic, but I really like to go for some edge cases. And in here, I'm going to say that expected, I'm going to cheat a little bit. Expected response for whatever rating, and whatever could be anything that the system does not know, right, is false. I don't want the system being fooled by some glitch. And the actual, and again, I love to cheat. I'm going gingerly walking on eggshells. Equal, okay. So here I'm totally faking it, and of course, I'm expecting this to be in a healthy state. Yes, my system is running everything, all the tests passed, 2 tests, awesome. Now, I'm going to stop faking, and I'm going to say, is rating valid? Whatever. What do you think is going to happen when I run? You guessed it. Yeah, it didn't find it, so it's false. Which means the code is working, and I'm, again, being the old pessimist, I'm going to watch it heal itself. Yes, okay, back to normal. Alrighty. So I'm satisfied here. I'm like, yeah, okay, I have covered some edge case. I'm cool. I am now going to go one step further and think about the next expectation, which in my mind is that I need to convince myself that this system, when you give him terrible rating, has 0 tip percent. I need to know that. I want to be on the safe side, and I don't want any monkey business. Why? Because later on, you know, this all of a sudden mushrooms is something else. It goes to another team, and they completely mess up, and all of a sudden our tip calculator starts being buggy. So I'm going to say expected. What did I say 9? Oh my god, it's weird. Expected tip for variable rating is 0, and I'm going to say actual tip for variable rating is also 0. Again, I'm faking. Equal actual. I haste to run. I really want to run as much as I can. Alrighty, and now is the time to stop hard coding. We had our fun, and I'm going to say tip calc. Can you tell me if this rating has what's the tip percentage? And it doesn't know, so I need to invent it now. So I'm like get tip percent for variable. Yeah, I want to be able to send it message. See, I'm in charge here, right? I'm the god right now, and I'm saying, okay, I want you to do this, and he's saying, I don't know what it is. So I'm like, okay, just hang on here. I'm going to go to this guy and declare it. So I'm going to say int. We're going to use int. Primitive. Doesn't matter. Get tip percent for the string rating. Okay. I did go back. He's happy. The implementation is not happy. It's in red because I don't know how to do this. Okay, let me teach you. Get tip percent for string rating. Here's what you're going to do for now. Return 0. Fake it till you make it. Return, I know how to type. All right. Quickly, this guy's happy. This guy's happy. This guy's happy. We save all. And we are really shamelessly faking it. But the system is up and running. This is my prime directive in life. Now, awesome. Let's go back and say, yeah, okay, this is cool, but you are actually cheating. So now I'm going to actually try and return the real value for the rating. And of course, it is not integer, it's an object. First thing I want to do is I'm going to convert it to string. And then the magic trick is I'm going to parse that string for the integer. Simple, no big philosophy. And see what happens when I run. Yes, okay, the system is healthy. And now just to appease my skepticism, what happens if I say, 190? Is it going to heal? I want to see it heal. Yes, I feel good. I like when I see these things. Like I said, I want the system always to go low. All right. We're inching our way toward having a nice tip calculator. I'm now thinking about what is my next expected behavior. So we know we can ask it if it has a rating. We know what the percentage is. Now we want to actually calculate the total. So we can say variable rating for 100, because if I flip over here, I say the restaurant total is $100 and the rating is terrible. So I'm saying $100 total is $100. So I'm saying here, if the total is $100 and the rating is terrible, then the total is $100. Oh, no, that's not it. I need to give it caliber rating for 100 is 100. Yes, okay. And now, again, I'm keeping things super duper simple. Expected total for variable 400 is $100, where actual total for variable rating is also $100. And here I have a typo. Sorry about that. Okay, and I'm going to assert expected to be equal to actual. I'm going to run. Everything's fake, everything works. And now replace hard-coded with, yeah, here we don't have any. So I need to again design here, and then I'm the, the maker, and I'm envisioning that this system should have some capability that I call calculate grand total for $100 and variable rating. And this guy says, I don't know what it is, and I'm going to declare it. Double primitive, okay, apologies. But we can refactor. Calculate grand total for double total and for string rating. So declaration, tests happy, finds it. Implementation not happy, doesn't know how to do it. Let me teach you. Public double. Calculate grand total for double total and for string rating. Let's fake it for now. $100. Quickly. Happy, happy, happy. Save all. Yes, okay. System is firing on all cylinders. Yes, some of them are fake, but we are inching away. We're going like really modest here. I'm the older I get more and more sheepish and modest. Alrighty, now is the time to replace hard-coded value with some decent, honest-to-God code. So first thing I want to have is the tip percent, which is give me for the rating. Next thing, I want to actually declare a grand total, and I want to calculate it on the spot by saying it's total plus the percentage, which is total divided by 100 times tip percent. And lastly, I'm going to return grand total. And if I now run the system, yeah, works. So, my friends, we have solved, but not really. Wait a minute. Let's go back and say, what about those edge cases? Okay, let me tackle them now, because I want to be super paranoid. And I want to say public void whatever rating for $100 is 0. Why? Because it's invalid. You should not be calculating any positive values because I have missed the space. Okay, so now I'm saying var expected total, or whatever, 0 var actual total for whatever, guess what? Also 0. Oh, sorry, I need double. Okay. And keeping things brain dead simple as always. I love that. I'm not smart to go into any super duper adventures at this point in my life. I'm keeping it safe. All right, this is all hard coded. Here's when a system run. Oops, something was not happy. Let's see, what is, was it a typo or something? Let me try again. I apologize for this. Public. It's coming to a close pretty soon, don't worry about it. Whatever rating is invalid, right? And we are saying var expected total or whatever is 0. Our actual total for whatever is 0. I'm going to assert equal did and actual. For some reason, it doesn't like this. Public void, whatever rating is, it already has defined. So we're saying whatever rating 100 is 0. All right, cross fingers. Yep, awesome. Now for the easy part, let's go and just like replace hard-coded with calculate grand total. We're saying $100. Rating is whatever. And what's going to happen now? Oops. System is broken. Oh my God, no. Not broken, of course, it healed, but we did not get as far as we hoped for. And now I'm thinking, when I look at it, the error, I'm saying, oh, so this is a null reference, right? Because we haven't really defined, if we go back to the tip calculator, I forgot that here, when we're getting the tip percent, we are counting on rating being there. It's not. And so this is a shoddy solution. It's bad. It sucks. How to fix it? Write another expectation. Never fix the code. When you see, this is one of the errors I always see, like, oh, I see where the problem is. You jump straight into a code without writing test. Bad practice. Never do that. Always first write the code and tell yourself, ever rating is -1% tip. If the system receives, for whatever reason, a glitch, some rating doesn't exist, -1 is a good catch-all, right? So I'm going to say var expected tip for whatever rating is -1, var actual tip for whatever rating is also -1. This is a fake. System runs and everything's cool. All right. Now we need to get it to work. Tip calc get tip percent for whatever. Let's see what happens when we run this. Now it breaks. Yeah, it breaks because we haven't fixed it. Let me make sure we have a test. Whatever. Let me go here and let me say if is rating valid for rating. So I'm going to test, right? We have to know whether this thing exists or not. Then it's safe to return this guy. Else, return -1. See what happens now. Okay. Oh, sorry, we did not save. Oh. Yes, okie doke. Now is the time to go back to our calculate total for our grand total for whatever. See what happens now. Oh, it breaks. I mean, it's healed back, but why? Because it was expecting 0 and it got 99 because it subtracted -1. Okie doke. Let's fix that. So see, I'm going step by step. That's what makes me feel most comfortable. Some people think I'm really, you know, but experience teaches me. Whatever. Okay. And in here, we are saying that, look, if the tip percent is equal to -1, just return 0. Don't worry. Let's save all. Yes, looking good. All righty. So you see our system is now up and running. Everything's cool. We have solved the first scenario. What about the second scenario? It says same situation, total for poor service. And given $100, the poor service will result in $105 total charge. Basically 5%, right? All right. Never touch the code. Go straight to test. That's my mantra. I've been burned too many times forgetting about that. My next expectation is now riffing off the next scenario here that I received from the business. And I'm thinking, poor rating for $100 is 105, right? Makes sense. That makes sense. And I'm going to say var expected total for poor rating is 105. Our actual total for poor rating also 105. I assert. I go expected, actual, and I just want to see system is healthy. Nothing changed. Alrighty, cool. Here I'm going to say tip calc. Calculate grand total for $100 for poor rating. Oh no, it was expecting 105, but it got 0 because it couldn't find poor. So the test, okay, we healed back, but I want to first do the test. Calculate grand total, sorry, for $100 poor. That's good. And I'm just going to go back here and say, well, yeah, I mean, the system doesn't know what terrible is, so we need to teach it. I'm going to say, look, there's another rating, which we call poor, and which is actually rated at 5%. Now, if I save all, awesome. So we now have a system that you can see calculates. And now, if I'm not experienced, I'm going to be excited. I'm going to say, all right, so if I go back and read other scenarios, scenario 3 says, for a good service, it's $110. For great service, it's $115. And for excellent service, it's $120, which is basically all 10, 15, 20%. I'm going to now, if I'm not being careful, and I'll show you why, I'm going to just add these things straight. No tests, nothing. Just go, you know what? I don't have time for this test. So I'm going to say, okay, good service. We're talking 10. Great service. We're talking 15%. Excellent service, we're talking 20%. What happens when I save? Yeah, works. Hey, you go back and say, look, this entire thing is implemented. No problem. Not so fast. I'm going to show you what I mean. And we talked about this today. I'm going to run mutation testing here, so bear with me. Called Striker for .NET. Oopsie. Typo, sorry. My brain is fried by now. It's been... So Striker is gonna, and you know all about this, it's gonna create mutants and blah, 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 and blah, blah, blah. And because it's running first time, it takes its sweet time. So it created 12 mutants and found 7 tests. Now it's going to run it. And it's going to do a full X-ray examination. And it's going to tell us that it found 12 mutants. It killed 9 of them and 3 survived. And let's look at the... So what do you mean survive? Like, this looks like squeaky clean solution. And I want to look into the report. And it's here, it's telling our success rate is 75%. I'm not happy with that. What's going on there? Ooh, you see, it's complaining about these guys. Saying if I replace good with a blank, no tests complain. And I do the same for great or for excellent, which means your system is very shoddy when it comes to understanding what are the ratings. And yeah, you may think this is not a big deal, but it is, because you know, you can imagine this thing mushrooming into something else and blah, 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 and all of a sudden we get a mess on our hands. And so to conclude this, just because, what I want to say here is just because all your system is up and running, all the tests pass, in my mind, that's not enough. I always like to finish the session by running mutation testing, and I want to kill all the mutants. So how would we kill these mutants here? Basically, we'll have to go back to tests, and we will have to either, you know, test that these ratings have been declared to the system and that they have correct tip percentages. Only then would I say, yeah, this is a good to go system. You can take it to the bank. So with that, this concludes my hands-on presentation, and I hope I did not manage to confuse you. But this is all, again, moving or inching towards the system where we get super fast feedback. Now, I want to mention one other thing, and you guys probably know this, but if you follow Paul Bigger, and he's built this system called darklang, this is something to really examine and to have a look, because he is really working hard on minimizing and eliminating accidental complexity. And accidental complexity is the bane of our existence. And, you know, I think we need to go in that direction to remove this long wait from I made a diff and then I don't know when I'm going to see if it works or not. TDD is a fantastic discipline. Today, we've pretty much laid it bare for everyone to see, to learn, to come to us. As I mentioned, we have a Discord channel. We talk like crazy about these things. And of course, all these other presenters have their phenomenal resources. And with that in mind, I think I'm ready to close the conference. I'm sorry, I had to switch computers, so it's not really, give me one sec. Just to go back into the saddle here. Okie doke. And the thing I want to do here, let's see. I want to say thank you all. And maybe find me on Twitter and DM me, and I will link you up with the Discord channel. And I don't know why is this guy not playing. Thank you for bearing with me. And I apologize, this isn't really Mickey Mouse problem to me, but you know, when you really sink your teeth into it and you start rolling with this, that you'll eventually learn like, oh my God, this is saving my bacon. And goodbye, everyone.